Unreal Engine is a 3D computer graphics game engine that has been used to create many popular games. In this full course for beginners, Surav will teach you how to use Unreal Engine 5. Surav has 7 years of game development experience and has developed multiple games.
Hi there game devs, welcome to my beginner to advanced game development course on Unreal Engine 5. In this course, we'll be taking a deep dive into the engine, and hopefully by the end of this course, you would be able to create a game completely by yourself. Now, before you actually start developing a game in Unreal Engine, some of you guys may have a question on what sort of a system to get for Unreal Engine. Now, the docs is a bit outdated on this page. However, this page, whatever's there, is insufficient in my opinion. I have been working on Unreal Engine for almost 7 years now, and I feel this system isn't going to be handling anything. So 8 gigs of RAM isn't enough, and for the video card I would recommend at least going for something like a 1650 or an RTX 3050 if you were to ask me. I have worked in Unreal for about 4 to 5 years with a 1050 Ti. That totally works. However, your experience isn't going to be that great, and you will have to turn down all the settings as well. And for the CPU, a Ryzen 5 or an Intel i7 would do. 6 cores or higher, preferably 8 or even 12 cores would be better. But make sure if you do get more number of cores, you scale up the other components as well. There are a couple of things. For example, in Visual Studio, when you compile a program, you will actually need more RAM as you scale up the number of cores on your CPU. So that's one thing to note. And if you scroll down, you would see this list over here. Although this system is highly overkill and the GPU is outdated, of course, one noteworthy thing is a solid state drive, which I highly recommend. Do not use a hard drive for your active projects. The experience isn't going to be that great. So with that all being said, let's actually start by talking about the installation process. Now there are 2 ways in which you can get hands on Unreal Engine. One is through the Epic Games launcher. So just search Epic Games launcher, download the launcher, and once you actually log in and do the regular sign up stuff, you can go ahead and click on Unreal Engine and head into library, and you should be able to add an engine version. Now as of this date, the latest stable build is 5.0.3. However, 5.1 is in preview, and we shall hopefully upgrade to that. It has quite a few exciting features which I would love to show. And the other way is to download the source code. Now you could use Git or something and copy the link and clone it like that, or you could just download the zip file from here. And then there are a bunch of steps to actually install it. We'll be going through this later in the course, and also for more advanced users, those of you who will be working with dedicated servers might need the source build as well. Now if you guys don't have access to this repository, you just have to request the permission. This is a private repository by default, and it's pretty easy to get it. And once you do get access to it, you will be able to view this page. There are quite a few tutorials on YouTube on how to do that, so you guys could check any one of those out. Once you install the Unreal editor through the Epic Games launcher, you'll also need a code editor in order to work with the C++ files. So generally you use Visual Studio for it. Now the documentation goes pretty well on what components you need and stuff. And if you do need any additional components, the installer is going to prompt you, and it's pretty straightforward to be honest. Now you don't require VS 2019, you could use 2022, there is absolutely no issues. I'll be showing you guys how to set the default code editor to be VS 2022 as well a bit later. So that's about it for the code editor. I guess now we can go ahead and create a project, and let's create a game. So I'm in the Epic Games launcher right now, And before we actually launch the engine, I just wanted to talk about the installation options. Try your best, even though it looks large, to have debugging symbols. Those are going to help us out later. Now you can go ahead and click launch. Once the loading is done, you should be inside the Unreal project browser where you can create your projects. Now yours might look a bit different. I haven't selected templates, so I don't see first person, third person and all that. However, our intention here is to learn, so we aren't really going to use those templates. We might look into them a bit later on, but for now we'll be starting with a blank project. And a couple of noteworthy things. Two things actually. The first thing is the project location. I always suggest having an Unreal projects folder in your solid state drive and maybe move them to a secondary drive if you're not working on them. Now for the project defaults, everything is fine except Blueprint and C++. Basically every C++ project will have Blueprint and everything else that you'll need to work with the editor. However, when you select a Blueprint project, there is one additional step if you want to start working with C++ as well. Please note that Blueprint and C++ work complementary with each other, and every project in my opinion should use a combination of the two and shouldn't be purely C++ nor should be purely Blueprint. So let's create a C++ project and let's leave it at desktop, maximum, and we didn't download the starter content, so we don't have it, but that's totally fine. We can add it later on. Now for the project name, we can go ahead and name it. Let's call it beginner to advanced course, or I'll just call it beginner course. So let's create that. Once you open your project, a Visual Studio window like this with your project solution open should be open by default. If not, head into the editor, go to tools and click on open Visual Studio 2022. And here's where I'll just show you guys how to change the default code editor. Let's say you have a slower computer, head into editor preferences and over here type in code editor and you should be able to change it to Visual Studio Code or whatever. Let's say you do change it to VS Code. Over here under tools again, you should be able to find refresh Visual Studio Code project. Once you do that, you should be good to go. One thing that you will immediately notice is my editor layout does not look exactly like yours. The reason is I have set mine to the Unreal Engine 4 layout. So the way you do that is by heading into Windows, load layout, and this is the one you will probably have. And you can hit Control space in order to get your content drawer, but I feel like it just adds an additional step in viewing your content, and I honestly prefer the Unreal Engine 4 layout, but it's completely up to you. Everything else should be in the same place, so I'm going to be using the UE4 layout. You can choose to use the default one if you wish. And in case you want to go full screen here in the UE4 layout, just get your viewport into focus. Just in case you're wondering, the middle large portion of the screen is called the viewport. Once you get it into focus, hit F11 on your keyboard to go full screen. Let's start talking about the actual GUI of the Unreal editor. So the first thing is your menu bar, which contains file, edit, window, tools, build, select, and so on. These are just the normal options that you would see in any other computer software. So let's say you wanted to save everything, you'd go ahead and click save all. However, there's a key over here as well on the content browser, which you will be using more often in this editor. And under edit, you also have a couple of important things. Obviously for undo, redo, and functionality like that, you'll prefer the shortcut keys. So for example, let's say I add in a light over here and I go to edit. You could undo that, but I just prefer using Ctrl Z and Ctrl Y. And editor preferences, project settings, and plugins are a couple of options which you will use quite a bit. We will be getting into all of those in detail later on. Now, window, as the name suggests, has to do with your actual GUI. So here, for example, if I wanted to know what game mode I have, and again, we will be getting into all of that. So I can just go to world settings, which contains the game mode info. So it says game mode override none. We can set that to be game mode, for example, and stuff like that. It all depends on what you exactly need. You could grab in a second viewport as well, in case you needed it, stuff like that. And under tools, the only thing which we'll probably use here is going to be creating a new C++ class, and occasionally we might need to refresh our project file. And nothing else actually. Find in blueprints is something handy. So in case you have written some blueprint code and you want to find it, like in your entire project, then it's a useful thing. And build is for building your lighting and stuff, basically baking your lighting. Select, not really sure who would use that, because most of the operations over there can be done by shortcut keys. So that's your menu bar, and under this there's another panel over here where you have another save button, and under this select mode option over here you have quite a few options. Landscape is something which you will use when you're working with larger maps, so you can go ahead and create landscapes. So what I'll do is I'll create a brand new level to showcase those things, and over here in blueprints, this is where you'd access your level blueprint, and I will get to what is that a bit later. This option right here is mostly for cinematics. So let's say you're making a trailer for your game or something, these are the things which you would use. And this is just to play your game. So if I hit play, I can see what the game looks like while you're playing it. One more thing, let's say you wanted to look at how your game looked while you're playing without actually playing it. You can press G on your keyboard and it's going to go into game mode, which will show you exactly how your game will look when it is being played. And next up, you have this button right here, where it allows you to launch the game and stuff. We'll be going into this a bit in detail later on. Now, for those of you guys who have slower computers, you can head into settings over here, engine scalability settings, and you can set yours to low. Now, how do you check your frame rate, you may ask? Because that's a major concern. I feel like you do require about 50 to 60 FPS in order to have a smooth editor experience. So the way you check that is by hitting your tilde key under your escape key, that is, if you guys aren't familiar. Once you do that, your focus should be in this enter console command window at the bottom of your screen. Type in stat FPS and you might see that it's locked at 120 if you have a fast computer. So what I'll do is I'll type in t.max FPS, and you can just type in a crazy value like 999. So this is my actual uncapped frame rate. Now this introduces us to another window. This is known as the console. Now the console is really useful. Basically almost every setting you see over here and quite a few other settings which we will talk about later can be set using the console. It's quite handy. Let's say you're debugging your game and you don't have an actual button to change your graphic settings. You could use the console and change it as well. There are many other uses for it. For example, in multiplayer, you can simulate lag and stuff like that in order to represent an actual multiplayer game. So that's the console. And your output log is your output log. So let's say I've printed something. It's going to stay on your screen for about 2 seconds or how much ever you set the duration. But the output log is always going to have the print. So for example, now we haven't gone into blueprints, but I'll just print something and show you guys. If I just type in print string hello, you see you get hello over here. But it's gone after 2 seconds. However, in the output log, you should be able to still see hello. It should be all the way down. As you see, you get hello. Now don't worry about all these errors. It's really nothing to worry about. So that's about it. And on the left hand side, you have the place actors panel, where you have various options. You'll really not be using this. You'll generally just drag those from the content browser. It just contains the same old things, and the recent tab may be helpful if you're placing the same object over and over again. One thing that you might use this for is for a player start. Player start is basically where your player is gonna spawn. Just press G on your keyboard if it ever disappears. You're probably in game mode if you don't see it. And if you want to get close to it like how I did, make sure that is selected and press F on your keyboard. F stands for focus, and it's going to go near it. The camera is going to go near that. Now, once that's done, let's talk about this massive chunk of the screen. This is known as the viewport. This is where you'll actually arrange your level and do stuff. So for example, if you want to place something, you drag that in the viewport and that's going to be added into your level. Now, in order to navigate your viewport, there are quite a few methods which you can use. One is known as the Maya style navigation, where you use Alt and your mouse buttons. And there are many other styles which I won't get into. It's kind of pointless. But there is one style which I personally prefer, and I feel almost everyone is going to prefer that. That is by using your right mouse button and your WASD. This is similar to how you move in video games, except you're holding the right mouse button here. So hold down your right mouse button, and you can use your W, A, S and D keys and move your mouse. So this gives you all degrees of freedom, so you can rotate, you can pan around, you can do everything. So this is my favorite way of navigating. Just try it a couple of times. It's just a matter of getting the feel of it. And if I want to speed up the camera, which I will get into later, you can use your scroll wheel along with this, and your camera speed is going to change. There are a couple of options again here. Now here, instead of the console command, you could use this as well to show your FPS. And there are quite a few other options which you would generally not use. Screen percentage is basically a resolution scale. You could set that all the way up there. I'd leave mine at 100. And this is to change between perspective and orthographic views. Let's say you're aligning something from the top. You would go to your top orthographic view. Now you might see everything is wireframe. So you can change that here as well. Go to lit. Let's say there are shadows interrupting your work. You could head into unlit. There are many other view modes which you generally use for optimization and things like that. But generally you'd stay in lit, unlit or wireframe itself. Maybe a couple of times you might use one of these other settings, but I've never found myself needing those. So that's there. And scalability is basically the same thing which we saw over here. I can set that to cinematic, for example. In my case, it shouldn't really matter. That's about it. And in these options on the right hand side, this one basically allows you to select objects. So let's say I click on this, I select this. Now let me get closer a bit. Set into perspective. So if I click on this, I can select it. Now when I click on something, now I'll create another point light. When I click on something and I have it selected, if I want to move it, I can press W on the keyboard. Or if I want to rotate it, I can press E on the keyboard. And if I want to scale it, for a light it's kind of useless, but it is going to scale the radius, I believe. So for that I can hit R on my keyboard in order to scale things, or you could use these buttons over here. So this is for move, this is for rotate, and this is for scale. Alright, so once that's said, this button right here changes between local and world space. Now over here, if I just drag in a cube, for example, under shapes you should find cube, and if I change this to local space, now when I rotate this cube, you see the gizmo rotates along with it, and now I can move it along its rotation. But let's say I wanted to rotate it along with the world's XYZ. The way I do that is by heading into world space. So now you see it's aligned to the world's XYZ, that is your actual coordinate axis. But this cube is rotated, as you can see. So if I want to move it along that rotation, I can head into local space. Again, if you're familiar with 3D modeling software, these will sound pretty familiar to you. The next thing is grid snapping. Now, if I were to come close enough, you would see that it's moving in increments. It's not moving smoothly. That's because grid snapping is enabled and snapping distance is set to 10. So I can just click on this button and disable grid snapping, and now you see the object move smoothly. Same goes with rotation. If I disable that, I can smoothly rotate the object. If I enable that, it's going to rotate in increments of 10. Same with the scale as well. Now, this map is pretty huge and it's taking quite a while for me to actually go this far. So the way I can actually move faster is by using this camera speed button. So if I head into 8, as you see, we are moving very fast. One more thing is, if you scroll while using your right click and WASD, basically I'm using that to move. If you use right click and WASD and you scroll at the same time, you can actually adjust your camera speed. So I have my right mouse button held, I have WASD to move, and if I scroll forward, I'm going to move real fast. Now let's say I scroll backwards, I'm going to go slower. So you can adjust your camera speed with your scroll wheel as well. And of course you can adjust it over here. And if you want the camera to be even faster, you can go ahead and set this multiplier thing. And that's about it. Now let's actually start creating something. So the way you would actually go about doing stuff is creating something under your content folder. Now you might have some things over here if you have enabled starter content and stuff, but in our case we don't have anything. So one thing is, whenever you create new levels, it's always advisable to have a maps folder in your content folder where you actually put all your maps. So head into this folder, and in order to actually create a blank level where you can start making your own, right click, click on create basic asset level, or you can head into file new level, anyway is okay, and we can call this one beginner course level. You could call it anything you want. Double click on it to open it up, and I've already saved it. It's asking us to save this map actually, so actually don't save this. Now head into your project settings, and this is where we start talking about some of the things which you might need. The first thing is maps and modes. So in order to decide which level is going to open when you start the editor, this is where you actually set it. So anything associated with your project will be over here. So for example, your input bindings is something which you'll use a lot. So all of those are there in the project settings. So we can change the editor startup map to be beginner course level, and we can set this to be beginner course level as well. Close that. And if you were to notice, there is actually a small note here. It says these settings are saved in default engine.ini, which is currently writable. What do I mean by that is, if I head into my project directory and if I head into config, there are actually many config files. So for example, if I open up default engine.ini, it says edit a startup map equals, and it has the relative path of the map, and you have a bunch of other settings as you can see. These are useful. We will actually talk about config files in detail later on. There are other config files as well, most of which you won't use. You would mostly just use default engine.ini. Now heading back to our level, you see everything is completely empty. Now one of the first things that you will need is a sky actually. So if you just search in sky, you're going to find a skylight, sky atmosphere. We are just going to be using a skylight for now. And if you just type in atmosphere, you'll get the same sky atmosphere here. So you can go ahead and drag that as well. And if you type in fog, you'll be able to get exponential height fog. Now you will see the effects of it if you tinker around with this yourself. Basically all of these things just do what they say. So exponential height fog is going to add fog, and if you want to change the properties of this, always head into your details panel, and this is where you will adjust all the properties. Now for something like fog, the location and stuff doesn't matter. So anything you place, the location of it is going to be stored here, location, rotation and scale. Just know that location, rotation and scale combined in Unreal Engine is known as a transform. We'll be using that a lot. Now let's say you had a light which was fixed and you want the shadows to just be baked in and you have nothing to calculate dynamically. You could set your light to be static, or it goes the same with any other object. If you're not going to be moving it, it's going to be static. Stationary is almost like static, but there are a couple of things which dynamically changes. It's generally used for your directional lights, which acts as your sun basically. So we can drag that as well. So if I type in directional light, you see we get everything else that we need. If I remove the fog, you would see that the fog went. Now for example, here I have lost my directional light and or any other component. So in order to navigate to that, you can use this outliner window which will have a list of all the objects that are in your scene. You can do quite a few things actually. If you want, you could select these and you could actually put those in one folder. So I can go ahead and right click, create a folder, and I can just drag those inside this folder. You could do that as well in the outliner. So now let's say you lose your directional light, you can head over here and let's just call this one sky, for example. Let's just call it sky actors. I'll tell you guys why we call them actors a bit later on. So you can drag in a sky atmosphere, skylight and stuff like that. So these are the basic components of your sky. Now if I go ahead and zoom into my directional light, press E on my keyboard and rotate it, you see the sun moves along with it. So let's say we wanted an evening sky, we would use something like this. And if you would notice, the mobility is set to stationary. You could set it to movable, then everything will be calculated dynamically and you won't have to build the lighting. You could set it to stationary as well. You could set it to static if you don't have any moving objects in your level. Now let's go ahead and just save everything. Now let's start actually creating something in our level. So first of all, remember I told you about the landscape tab. This is what you would use if you have a larger world, but for our purposes, I'll just show you guys how to work with landscapes, even though we aren't really looking for a large world. So here you can select your landscape material, but you can change it anytime anyways. And let's say you wanted a water body or something, or let's say you wanted to have multiple layers, in your landscape. You can click on enable edit layers. And these things are basically a transform and stuff like that. And these things adjust these options, number of components and the overall resolution, adjust the size of your landscape. So you can play around with that. to see what the precision, or rather I should say the detail level of the landscape and the size should be. Depending on that, you can increase that, or you can go ahead and use a height map. I actually have a short on my channel on how to use height maps properly in Unreal Engine, but for our purposes we'll just create our own. So let's just create everything with the default options and let's hit on create. So it is going to take a while. And once we're done with that, we have a landscape. Now if I go ahead and press play, as you can see, I can navigate around this landscape just like you can navigate in any other level. So now what I'm going to do is I'm going to edit the landscape. Now these are the tools that we'll be using to edit our landscape. So you have to be under landscape mode, and under this section over here, you would find sculpt. You can increase the tool strength. You can get the brush type over here as well. One thing that you will use is probably the alpha brush. Basically you can have your own mask and stuff, but for our purposes we are going to be using the regular old circle brush. So I'll just increase the size. This need not be the limit actually. I can set this to 10,000 as well. So if I go ahead and do that, you see we have kind of a mountain here. Now what if I wanted to randomize the bumpiness in the map? I could use noise. So you see it's going to be like this, but this is overkill. So I can go ahead and change the tool strength to something like 0.05. And as you see, this is a lot more reasonable. So this is what noise does. Flatten, as the name suggests, is going to flatten your landscape at that level. So let's say select this level. Everything else is going to go to that level if I use flatten. Now obviously you can increase your tool strength if you wish. Completely up to you. And there are many other things such as the brush fall off. So basically if you want a softer brush, so you could use the brush fall off and increase that. If you want a completely hard brush, you could go ahead and use this, but as you can see it produces harsh effects, so we aren't going to be using that. Again, completely up to you. And erosion is basically if you wanted to create natural looking slopes and stuff. So for example, so I'll just reset some of these settings here. So something like this, you could experiment and find out what each one does. But generally you would stick to sculpt, smooth, flatten, ramp, and maybe sometimes you'd use erosion and you'd use noise. And let me show what ramp does real quick. So if I select ramp and if I go ahead and click somewhere and click in another place and click on add ramp, you see it bridges those two locations with a straight line, and this is going to be a ramp. You could add a ramp anywhere like this. So I can go ahead and do this and I can click enter, or I can press add ramp on the menu over there and it's going to add a ramp. Now if you had a character or something, you can walk over it. Now again we can use the smooth tool in order to smoothen this out. So now these two, this intersection looks seamless. So these are basically a landscape editing tools. There is not much depth to it, and not sure what erase does actually. So I've never used erase, to be honest. You would just undo changes if you really had to. And one more thing, if you wanted to do the inverse of an operation, so let's say I am sculpting a landscape. So let's say I wanted something like this. So I'll increase the tool strength. So make that, let's say 0.14. Now this is one way, but what if you wanted a pit instead of a hill? The way you do that is by holding shift. It's going to reverse the operation and it is going to make a pit. Same goes for the other tools as well. Shift is going to be the inverse of the operation. So that's about what you'll use in the Unreal editor most of the time. So now we can start creating our own assets. Make sure you first of all go into select mode again. Don't forget that. And now we can go ahead and start talking about blueprints. So let's start talking about Blueprint. Blueprint basically is the visual scripting language which is used to write game logic in Unreal Engine. So Blueprint code can be written in many types of assets. If you right click, go to Blueprint class, you can write Blueprint code in most of these assets. And we will get to some of the important ones a bit later. For example, actor, pawn, character, player controller, game mode. There are a few others such as the game state, player state, and so on. We'll be getting into all that. Now, the most basic type of blueprint is going to be a level blueprint. So if you head into this menu over here, click on open level blueprint, you'd see you'd get a blueprint associated with your level. Now, begin play is, as the name suggests, something which is called as soon as the game begins, or in this case, as soon as you open the level. Please do not interpret begin play as when you click on the play button. This is only called once you load into the level. So let's say you loaded into another level, the begin play for that level will be called as well. In order to actually start writing code, you would use some built-in functions, or you could write your own. So the way you do it is, if you right click for example, and if you just type in, I don't know, let's say set location. Now let's say you wanted to set the location of something in your level. Let's actually do that. Since this is object oriented, you will need context for everything. So you need to know for which object you're actually moving. So for example, let's say we have a point light here. Now one handy thing which I forgot to mention before, let's say it's up over here and you want to snap it to the ground. You can hit end on your keyboard and it's going to go to the ground level. Now we have this. Have that selected and head back into your level blueprint. If you right click, you get an option, create a reference to point light. Now, internally, this is a pointer to this object, or rather I should say to this actor. Anything that can be placed in a level is called an actor. Just remember that. Now, if I drag off of this, now I want to get its location, let's say for example. Now, the search bar is really useful for that. You don't really need to know the function names, especially in blueprints. So just type in get location and you see get actor location. Now I can go ahead and print it, for example. So if I right click and type in print, you see print string. Now this is called a function. Even this will be called a function. So let's say I drag off of this and I type in set actor location. Again, every getter will usually have its own setter if it can be set. So what we are saying, what we are implying by this is set the location of this point light to be 0, which is what you've defined over here. Now let's say we just wanted to move it up a bit. So we can do plus, and on the Z we can do 200 because Z is the up axis in Unreal Engine, and we can set that to be the new location. So if I go ahead and press play, don't see much. See, mobility of the light is set to stationary, so we have to make it movable, of course. Remember what I was telling you guys earlier, with static and stationary you'd assume it to be in the same place, but with movable it's fully dynamic. So now if I press play, you see it became dimmer. In case you guys wanted to see the change, if you just press D on your keyboard and left click, you get a delay node, or you could right click and search for delay. But I prefer using D. If you press D and left click, you get a delay node. Let's just keep a delay of 2 seconds and then let's move it up. So if I press play, as you see, it got dimmer because it went up. Now, this blueprint function has a couple of pins on the left. So these are called pins, the stuff from which you can drag off of. Now, the triangular one or the pentagonal one, I don't know what shape this is, the one which drags off the white wires, these ones are called execution pins. So this function will be executed only when this pin goes from left to right. So only when you connect something to it from the left, and when this is executed, this is going to be called. And once this is done, this is going to be executed. Now this one is a function as well. Get actor location is a function too. However, it does not have an execution pin, you might notice. The reason is this is a pure function. You can define a pure function whenever you need a function to return immediate values. So what I mean by that? So for example, if I have this hit result and let's say I print this out. So I can't print out a hit result I figured, so let's just take location. Now this is just a sweep hit result, so let's say we move it somewhere and it collides with something in between, it's going to return a hit result if you have sweep enabled. Now if I print this out, this value right here is actually cached. So let's say I copy a print string and let's say I print this out again. Set actor location is not going to be called once again. This value what you had is going to be cached in your memory. However, over here, if I just drag off of get actor location and let's drag off of this once again. So let me drag this over here. This value is not cached. What I mean is get actor location is executed each time I'm calling this print string. Wherever I am referring to this value, the entire function is going to be called once again. And in this case it makes sense because whenever we execute get actor location, we want the live location of the actor, not the location which it was in previously. If we go by that logic, we would get the location before it was set. So we will get the live data using a pure function. And the target works in a similar way. We are getting the point light's location, so the target is point light. Now one more thing you might notice is event tick. Tick is basically a function which is called on every frame. So if I just hit print and if I just print out tick for example, you would see it prints it a bunch of times. Basically every time a new frame is drawn, the tick function is called. Now whatever I told you guys is just a vague overview of how Blueprint works. So I just talked about execution pins and that it's object oriented and types are color coded. But now let's actually start talking about them one by one. So the first thing you'd want to do in any sort of a programming language or if you're writing any code is first of all be able to store data, and that's done through variables. Now the way you create a new variable in Blueprint is by clicking on this little plus icon on the left hand side. This menu is available in almost every Blueprint. So click on the plus icon and you can create a variable. Now let's just call it my variable for example. Now over here, since Blueprint is based on C++, obviously you have to define a type for it. So by default it's set to Boolean, but you can select any one of the other types. I'll go over some of the important ones. If you're familiar with C++, these things will seem pretty simple to you guys. So Boolean is basically a true or false value. So for example, if I drag my variable and let's say you want to get the value of a variable, you can drag it and hit get. So this is going to be the value. So off of this pin, let's say I type in if. We'll get to branching and stuff a bit later, but I can do stuff like this. Since this is a true or false value, if this variable is true, this execution pin is going to come out. If the value is false, this execution pin is going to come out. So that's basically how it works. Same way with all the other types. So I can click on this variable and change the type to integer, which is basically a non-fractional number. Int64 is basically a 64-bit integer. So let's say you have larger numbers, so you would use integer 64. However, I don't really find many use cases for it. Float is a decimal number, and then you have name, string and text, all of which are string types. Most of the times you would be using string. However, in some cases you would use name as well, for example in tags, which we will talk about later. And text is mostly used for UI and stuff like that. So if whatever you see in menus and things like that, the strings over there are stored as text. So that's the data type you'll use. Now a vector is a struct with 3 floats in it, x, y and z. Now obviously if you don't know what a struct is, we will again talk about that, no issues. Rotator is a similar thing, except there is a limitation on what values you can have. You can only have a value of 0 up until 360. Beyond that, the rotator is going to be invalid. And transform is basically a struct again, which contains a vector, a rotator, and a vector. So location, rotation, and scale. So this is transform. These are the fundamental types which you use most of the time. However, if you go under struct, you would see there are a lot more. You will not use most of these. Some of the common ones that you will use are things such as hit result. So hit result is a common one that you will use. Now if I compile this and if I go ahead and drag this out, and if I go ahead and break, and one more thing, if you want to get this variable, there's a shortcut. If you hold control and drag it, you will get the value. And if you want to set this variable, you can alt drag it. So that's just a small tip I can give you guys. So now break hit result is going to show us all the different variables inside this. Now similarly, you can do that with any other struct. If you just drag off of this and type in break, you can do that. Or with some structs, you can even do split struct bin, or actually with all structs. So that's basically another way to see what members are there in the struct. So for example, similar to this was the same struct over here. So you see initial overlap, so this is going to be there, blocking hit, location, and things like that. So that's basically your struct. That's how it works in Blueprint. And one different type is going to be our object type variable. So for example, if I select an actor, and this was an object type as well, if I drag off of this, the variable which is color coded in your sky blue or your light blue color, so these are basically object references. Internally, when you write these in C++, so let's say you create an object reference for Blueprint in C++, you can expose C++ variables to Blueprint, by the way. They are stored as pointers. So basically it's the memory address to that object. Now if some of these things sound confusing to you, just stick along and watch the course till the end. And if you guys still have any confusions, make sure you guys do check out a video on pointers, and I will go over actors and stuff like that. Basically, this variable is going to refer to an actor, and since this is a pointer and the default value is none, so if I go ahead and click on this, you see it says none. So what this means is this is not a valid pointer, and if we actually had some logic in C++, it would throw an exception. So that's basically how object types work. And you also have enumerations, which are in some disguise just your byte, which is an unsigned 8-bit integer. So basically, for example, if I just grab a random enum over here, I can do a switch, which we'll talk about. So basically, depending on the value of this variable, you can perform your logic. So a common thing that you would use it for is, let's say you have a weapon in a game, and depending on the type, so let's say your weapon is fully automatic, you would have an enumeration. So one of these enumerators is going to be full auto, the other one is going to be semi-auto, the other one is going to be bolt action, and depending on that you would execute the appropriate logic. So that's one way of using enums. There are many applications, of course, we will get to most of them later. Now that's about how you basically create variables. So now let's actually talk about a few special types of variables, namely structs and enums. Now I did show you what's a struct and an enum, but I'm pretty sure it went all over your head if you're a beginner. So let's just delete that and click on this variable and hit delete to delete that as well. Compile and save that. Now go ahead and right click, create a new folder and call it structs. And I'm doing this in my content folder. You could do it in the same place if you want to follow along. Right click, go ahead into blueprints and create a structure. And for now, let's just call it my struct. Now, structs by definition in C++ is going to be similar to your classes. So basically you wrap a bunch of data and methods into a single unit. However, in Blueprint, a structure purely refers to a collection of variables. You cannot have functions for structs in Blueprint, sadly. However, you could just create a library for that. So you have Blueprint function libraries and you could just create functions for your structs. Anyways, so the way you work with this is you can create a bunch of member variables. A very simple example is going to be a 2D vector. Unreal Engine already has a 2D vector type, but just for demonstration purposes, let's just create one. So let's just call this X and make this of type float because it's a decimal number. Add in another variable, make it of type Y, and make this of type float once again. So basically, my struct is going to contain these two variables. Now if I head back into my level, make sure you save this. And if I go ahead and right click somewhere and type in my struct, you see you get an option called break, make and set members. So if I go ahead and press break, you see you get options X and Y. Now just like how you create an integer or any other variable, you can create a struct as well. So let's just call this one, I don't know, maybe my variable once again. And it's going to be of type my struct. So my struct is the type. So this is our user defined data type. Now I can go ahead and get this. I can right click, perform split struct bin once again. So this is basically how structs work. Basically you have one variable which stores multiple variables within it. So this can be very handy. For example, in this hit result, you have all these variables. Now they need not be the same type. The types can be heterogeneous. So I could have an integer over here. I could have a string over here. So let's say I have a student struct. I could store name, his roll number and stuff like that. So just a vague example over there. So that's basically how structs work in Blueprint. So I'll just delete that. We don't really need it, but we'll keep my struct. Let's actually have something more descriptive. Let's say we have name and let's say we have points. This makes no sense right now, but we can use this a bit later on. And you could anytime add a new variable, but remember, avoid removing variables from structs. Sometimes they do cause some issues with the Blueprint, so be careful with that. In C++ though, it won't be too much of a problem since you refer to the members by their names. So that's one thing to note. Now one more thing, if you guys want to set the members of a struct, what you do is you just type in set members and you can get the struct name, that is my struct in our case. So we can use this and set the members. Now over here on the right hand side under default category, you can get any one of the variables as pins and you can set the value. Now obviously you will need to tell it which struct. So let's say you created a variable of type my struct. So my struct, you can go ahead and pass that as the struct reference. Now this is a reference because this pin over here is diamond in shape or a rhombus or whatever that is. So that means it's a reference. So it is referring to the actual variable that you pass in. So it is going to adjust the value of this variable. We will deal with a lot of structs as we move on. However, there's one more special type which I would like to mention, and those are enumeration. So I will right click, create a new folder, and I'll call this one enums. Open it up, and over here I can head into blueprints again and type in enumeration. So this is basically a list of values and you could perform your logic depending on this list. So let's just create an enum and let's call this one my enum again. Now over here you can add enumerators, which basically are list items. So let's say add 3 items. So for example, let's take names of fruits. So apple, banana let's say, and maybe a mango. Now once you do this, these are basically the enumerators which are there, and I will show you guys what it actually implies. So I'll just go ahead and create a new variable and I'll call this one I don't know, let's say fruits choice, for example, and it's going to be of type myEnum. Now internally, ultimately an enumeration is just a number. Basically it's a number between 0 and 256. So for example, over here, apple is going to be indexed to 1, banana is going to be mapped to 2, and mango is going to be mapped to, 1, and mango is going to be mapped to 2. So 0, 1, 2. So that's how it's going to be internally. Now obviously you can give a description as well over here in Blueprint. So if I just drag this in, now by default it is set to apple. You can see the default value on the right hand side, and we will talk about all these options a bit later on in the variable section. So just to be brief, if you are like creating new objects in your scene, you would need some of these, and for multiplayer and stuff you would need replication, and we will talk about them in depth, so nothing to worry about. Now you can cast it to a string. So Unreal has it built in to give this out as a string. So if you see, you should get apple printed. Oops, I have something on tick, so let's just delete that. So nothing's printing. Okay, we have a delay of 2 seconds. Let's just delete the set actor location stuff and just print this in. And we could actually change this as well. You can copy this and paste it by hitting Ctrl D. So if you click on this and hit Ctrl D, you can duplicate it. And if you drag off of this, you'll see you can perform a switch. So basically, if the value of fruits choice is apple, it's going to perform this logic. So let's just say healthy, for example. And for banana, let's just give something else. So it honestly doesn't matter. Copy that over. And let's say we give tasty for mango. So if I go ahead and press play, you should see it says apple and healthy. Now, if I set this value, so if I alt drag it and I set this to banana, now you should be able to see that it prints the second string. So this is basically how enums work. And this was actually a bit of a lengthy way I did it. There's actually another shortcut you can use in Blueprint. In C++ though, this is the only way. You would just type in switch instead of using this node. So one more shortcut is if you drag off of this and type in select, depending on the value of this enum, you can make it do certain things. So let me remove the switch here. So now what I'm saying is if the value of fruits choice is apple, this is the value that will be passed. So in this case, I'll just type in 1 for example, and over here I'm going to type 2 and 3. So what we are saying is if the value of this enumeration is apple, it's going to print out 1. So the value which will be returned here is going to be this value. Same with the other two choices. So if I press play, you see it says apple and it says 2. That's because we had set our choice over here. If I change this to mango over here, we are going to get 3. So that's basically how enumerations work. Now that we have a basic understanding of data types in Unreal Engine, let's start talking about the core scripting features in Blueprint. So the first thing that you can do is create functions. Now a function is basically a block of code which adds functionality to your program. So what I mean by that? So in order to create a new function, you can go ahead and click on this plus icon right here. And we could call it whatever we want. We could call this one my function. And generally speaking, you would use Pascal case. So basically each word is going to start with an uppercase character. So generally that's a convention you use. You could use a space as well in Blueprint, but generally it's not a good practice. Now I can call this function from my event graph. Now if you see, you have opened two tabs. One is the event graph and one is my function. So I can close my function and I can double click on this on the left hand side to open it as well. Now if I drag this in, or if I right click and type in my function, you can go ahead and call it. So basically this is going to execute my function. So let's go ahead and actually do something with it. Now inside my function, this is blank right now. I can just go ahead and print a string, and we can call this one my function is executed. So I think I butchered the spelling, but doesn't matter. So if I go ahead and press play, you see my function is executed. Now we can also pass in values. So I have created this points variable here. So just create a new variable and make it of type integer and call it points. Now if you head into your function and click on this block right here, you can actually add input and output parameters. So if I click on the plus icon and change the type to integer, and I can call this one points. So I can take this points value from outside the function. So if you look at this now, you see I can pass in points. So that's pretty handy. Now I can go ahead and print this out as well. So I can print out my function is executed, and I can print out points as well. And if you double click on the wire, you can use the reroute node to keep things a bit clean. Now if I press play, you see you get my function is executed and you get 0. Now if I change the value of points, for example, you see we get that number. So this is basically how input parameters work. Now what if you had some return value? Now let's say instead of points this was health. So let me just call this one health. So compile that. And over here if I click on this once again, I can add in an output. And you see it creates a return node for us. So this is basically like your return keyword in C++. So when your function goes to this, it's going to exit the function, and the value whatever you want is going to be returned. Now you need not have it. You can have an empty return node as well. Now in our case, let's just return a boolean, and let's just call it be killed, for example. And let's change the name of this to be health as well. And we could do a simple if check. We will talk about if as soon as we finish functions, events and stuff like that. So if I can't do that, so let me just grab in an if this value, that is our health, is less than 0 or less than or equal to 0, then what we can do is if it is true, and if you type in Control D, you can have two return nodes. So if our health is less than 0, it's going to be true, otherwise it's going to be a false. Now you can go ahead and print this out over here. Now our health is 32, so we should have false. Let's say we set our health to be -1, which is invalid of course, but we get true. So this is how you can return values outside a function. Now one aspect of functions which I did not cover, and I'm recording this a bit later, it is going to be local variables. So what if you had some variable which you wanted only within a function? So let's say for example we have a variable temp, for example. So let's say you wanted a number to be stored temporarily inside. So for that case you would use this local variable option. They work exactly the same as you would as it works in C++. And one more thing, the input parameters whatever you take are also local variables, so you can just grab an in, and instead of dragging this, actually you can right click and type in, and if I just get it, so I should find it at the very end or somewhere, or rather let me just type it, get in. So in is a really commonly used word, so that's the reason we are getting it so many times here. So let's actually change it. So let's just type in 1 2 3, let's say. So in 1 2 3, so you can get it actually. So you don't actually have to drag this. Let's say you have a large blueprint graph, you don't have to drag it actually. You could just do this over here. That works totally fine as well. Even over here actually, you could do this and it's totally valid. So that's about it for local variables. As you use them, you will kind of understand their purpose, but without a solid example, we will not actually be able to tell the use case. However, once we actually get to the end where we actually create something, that is when we'll get to practical examples. At the base level, those are what functions are, and we will go a lot more in depth about functions, events and stuff, so not to worry about that. I've just gone ahead and deleted that. Let's create a new one once again. And now let's talk about the limitations, and let's talk about the next type of scripting feature in Blueprint. Now, one limitation that you'd see is you cannot add a delay. So if I right click and type in delay, you actually don't get a delay node. The reason is you cannot have latent nodes inside a function in Blueprint. So delay is actually a latent function. So what I mean by that is it actually takes some time to execute. So let's say I cut or copy this and paste it in here. You see, I cannot do that. It says one or more copied nodes could not be pasted into this graph. So the way you can handle this is you can use a macro. Now macros in blueprints are more like functions than C++ macros. So they work a little bit different. Now if I call this one my macro, for example, I can go ahead and add a delay. So I can hold down D on my keyboard and left click and I can add in a delay. One thing you'll notice is by default it doesn't have any input or output pins. You can go ahead and add that. But there is another advantage of macros. Now for example, let's say we have a database on our server, and let's say it takes some time to retrieve the data. So let's say it takes around 0.5 seconds for your computer to connect to the database and retrieve the data. This is just an example. It could be anything that takes time. For example, the prime number program takes some time to execute after you go to a larger number. So while this is being executed, now let's say you just wanted to print out something saying that it's starting, and then you want to do something else when it's completed. This is where it can come handy. Now you can type in print string and you can call this one starting now. You could come in here and now you'd notice this execution pin got disconnected. You can't do them parallelly, but there's a workaround for that. You can type in sequence, and over here you can just print this out and then you can go ahead and perform this. And over here in the output as well, you can drag this in, and a handy thing which you cannot do in your return node in your function is you can have one more of these. So now if I just give a longer delay so that we can recognize it, and if I drag in my macro and if I print out strings over here and over here, so we'll call this one done, and here let's just print starting underscore outside, for example. So if I press play, starting now and starting outside got executed first, then after 2 seconds our done was executed. So things like that can be done by macros, which you cannot do in functions. Now the whole point of using our own macros and functions is of course code reusability. So let's say I want to call this macro once again. I can just type in my macro and I can call it. Now one difference I would like to mention, and then we'll head into the next one, which is collapse graphs, is with a function. Let's say I call this my function. I can actually execute this from another blueprint, but this is not true for level blueprints. It's a little more tricky to do it from level blueprints. You guys will understand why once we actually head into classes and stuff. But I'll just show you guys a simple example. So I'll just create a blueprint here of type actor, and we'll talk in depth about this later. And let's say I create a function. As you can see, the same features in the blueprint are available here, and let's just call it one test, for example. Compile that. Now if I were to get an object reference to new blueprint. So I'll just do that by dragging it into the level. So I'll drag this and I'll create a reference. And if you can notice, I can actually call test from here. However, if I create a macro, so let's just call this one test m for test macro, you would see, even once I save and compile everything, I cannot call test m. I see test, but I don't see test m. So that's one more difference between a macro and a function. You cannot call a macro from, other blueprints, but you can call functions from other blueprints. Of course, if you set the access specifier to be private in that, then you can't call functions either, but you can by default. Now, what if you didn't want to reuse them? What if you just had this code, but this looks a bit messy, so you wanted them to be shown as one node? Let's say this whole thing did something. One, you could just press C on your keyboard and comment it. However, there's another feature in Unreal called collapsed graphs. Now you can right click and click on collapsed nodes, and it's going to create a collapsed graph. Now you can have inputs and outputs here as well, but in my experience, I have never really bothered using them. And let's just call this one my collapsed graph. And if I go ahead and type in my collapsed graph by right clicking, so let's say I type in my collapsed graph, you see I cannot call it because this is not a function. This is just all of this code just stuffed into this collapsed graph. So I lost my event graph here. You can head back in, or you can click on this over here. So that's basically a collapsed graph. That's about it. And when we actually use them, you will get an idea. You can actually have further execution. So let's say I have this. So it's going to come out of here as well. So stuff like that. So I'll go ahead and delete that. It's not of much relevance. Now that we have studied about functions, macros, and collapse graphs, let's actually look at implementing the various programming constructs inside Blueprint. So we'll use the level blueprint again, and after this we will get to actually working with blueprint classes. Now, the first thing that you would want to do is do an if check, and we already did that several times. So if you right click and type in branch, or you could just type in if, or you could hold down B on your keyboard and left click. That's another shortcut which I like to use. You would bring up a branch node. So a branch node takes in a boolean, and depending on its value, it's either going to go true or false. This is an execution pin again. So depending on the value of this variable, you can go ahead and execute some logic. So instead of health, let's say I have be alive as a variable. So if the player is alive, for example, so put that in. So if the player is alive, then we are going to go ahead and run this logic. Otherwise, we are going to run this. Now, there's another thing which you can do with booleans, which I probably mentioned for enums, but you can actually do a select as well. So if I go ahead and select, you can go ahead and do this. So again, you can actually get this return value to change depending on the value of this variable. So this comes in pretty handy. Now this is the most basic type and there's nothing much to explain really. So you could go ahead and print something and maybe do something else. And if he's not alive, maybe you can go ahead and you can quit the game or anything like that. So that's basically it. Now, the next construct that you'll use is switch. Now switch is something which we already talked about, but we are going to go a bit more in depth now. Now I'll change this variable to an integer again, or rather I'll just undo everything so that we have our integer back. Okay, I've saved it in between, so we can't. So I'll just change the variable type. And for this, we are going to rename this to, let's say, health again. Now I have health. So, oops, let's just compile that again. Control drag it. Now if I drag off of this and type in switch, you would see that I get the switch on int node. Now basically what this means is if I just click on add pin, and you can also set the start index. So let's say you want it to be -1 to start with. You could do that as well, -2 for example. So what you're basically saying is if the value of health is 1, head into this execution pin. Otherwise, default is basically like an else. So if none of these correspond, so let's say we have 1, 2 and 3. If the health is neither 1 nor 2 nor 3, it's going to head into default. So for example, if I just go ahead and print, now since our health is 0 and we are starting at 1, we should get hello printed in theory. So we get hello. If I go ahead and drag off of 1, you're not going to get anything. Now the same thing, if I just change the value to 1, I change the health variable value to 1, now you should get hello. So this is how switch works. Generally you would be using this with enumeration. So for example, we have my enum over there. So let's just delete everything in the graph. Now my enum. Now if I grab this into the graph and if I then type in switch, you see you get the options. So if health, okay, we can rename that to something a little more descriptive. So let's just type in some enum. So if some enum is apple, this is going to be executed. If some enum is banana, this is going to be executed. If some enum is mango, this is going to be executed. So this is basically how switch works. So that's about it actually. Now, this was for your selection and to evaluate condition. Now coming to the iterative constructs, let's say you wanted to print numbers from 1 to 10. You can use a loop. Now if you guys are familiar with C, C++, these will seem much easier to deal with. There are basically two types of loop and there is a version of while loop called do while loop. So the types are while and for. And there is one more type which you use a lot, which is for each, and we will get to that once we start talking about arrays. Now if I right click and type in while, you see you get while loop. So what this basically means is as long as this boolean is true, so I can change this to boolean once again. As long as this is true, this loop body is going to be executed. So for example, let's actually make this a number again. Let's change this. Let's say we wanted to print numbers from 0 to 10. So I'd set the sum enum, or we'll call this one num. We can set num to be equal to 0 by default. And now we can do an if check. As long as number is less than or equal to 0, or rather 10, we can go ahead and print our number. So we can go ahead and type in print string, and we can just Control D, print it out. Now obviously this is an infinite loop. You have to change the value of num itself. So what I can do is I can set num to be equal to num plus 1. So this is one way to do it. Also, if you were to notice, if you just drag off of this and type in plus plus, you can actually do increment as well. So this is basically like your num plus plus in C++. That's how you would interpret that. Now if I go ahead and press play, you should see we get numbers from 0 to 10 as expected. So that's basically how you use a while loop. And once this loop is done, again you can go ahead and print something. So let's say printed numbers. Now you see it prints from 0 to 10 and it just goes to completed. This is how you'd execute your logic. One thing to note though, avoid using loops in your program, especially in Blueprint, unless the array length is, less than about a few hundred, it's fine. But let's say you're dealing with larger data sets, please refrain from using loops in Blueprint. try to use as much as you can in C++, because Blueprint, if I haven't mentioned yet, is slower compared to C++. When you call print string, for example, this is actually a function call in C++. So the actual function of print string is written in C++. It actually takes a little bit of processing to actually switch between Blueprint and C++. Blueprint is kind of like your JVM, where it actually runs on a virtual machine. So Blueprint code is going to be comparatively slower than C++. But in this case, this code is pretty simple, so you don't really need to do that. We will get to where to use Blueprint and C++ much later. There's nothing much to worry about for simple games. Now the other type is going to be a for loop. So if I just type in for loop, you see you get for loop. This is how you basically execute your for loop. However, this is a little more, or actually much more easier than what you have to do in C++. In C++, you give an initialization expression, an update expression, and a conditional expression. I mixed up the order, but anyways, you get the point. And you got to actually give the body of the loop like that. But here in Blueprint, you just type in a first and a last index, which makes it very simple for you to execute a for loop. And if you were to just drag this in, let's say I just type in 0 and 10, and I just go ahead and print this. We don't even need a variable at this point. We can just grab this and we can go ahead and run this, and it's going to print 0 to 10. So this is how you use a for loop. Now there is another variation known as the for each loop, which is used similar to range based for loop in C++ to iterate arrays and stuff like that. We will talk about that. Now again, the completed works the same way. Once this loop is completed executing, you can go ahead and print something or execute whatever logic you have. So this is your for loop. And there is another variant of for loop called the for loop with break. So if I just type in for loop with break, you see you get this. Now let's say I wanted to stop at a certain point. Let's say, I mean in this case it's kind of useless to do it. But let's say I wanted to stop in between. Let's say I have some logic. We can just grab in some random logic. Let's say this number divided by 15, we have to make this float, remember, because integer division works in a different way. So let's say this number divided by 15, if it is greater than 3.5, we want to break. Let's say we have that logic. So we are going to print as long as this number divided by 15 is greater than 3.5. So do that. If this is true, we are going to break. Whoops. And if we go ahead and print this, we can just go ahead and print the number instead. And once this is completed, we can print something else. Now obviously to tidy this up, you can use a reroute node and you can do this. So this is one way to keep your blueprint graph tidy. So we can type in completed. So that's done. And we have a compiler error, it says. So okay, we'll take that in as a float. So convert this pin to a float, convert this pin to a float, and then let's just do that. And let's compile this again, save, and go ahead and press play. Now we would see it's 52. So if we actually bring up our calculator, so we get 51 by 15 is going to be 3.4, and 52 divided by 15 is going to be 3.466. So that should be the last number. So now if I do 53 divided by 15, you see you get 3.53, which is greater than 3.5, so it did not print that. Okay, now that we have talked about iterating, now it's a good time to head into our for each loop. Now for this, we'll need to learn about another data structure. Now this is a variable, right? Over here, where you select the variable type, to the right of it, you get an option to change it to an array, set, or a map. Now, an array is basically a collection of homogeneous elements. So basically, in this case, num is now no longer a single number. Instead, it is a collection of numbers. And why I say homogeneous is because I can only have integers in this list. I can't have 0 and I can't have a string in the next index. So basically, each item is going to be referenced by an index. So the first item which you put in is going to be 0, stuff like that. You can put in any number. And if I have to iterate through this, I will use a for each loop. Now, if I go ahead and print this out, you would be able to see that I print in all the elements in that array. So I printed in 2 and 32, which is exactly what we have. So that's basically how it works. Now, one more thing, you can have it of any type. In case you guys were confused, I'll create a new one. For example, let's just call it one str array, and let's make it of type string, and let's compile that. And I can go ahead and add a few elements. I can just type in any set of characters, and I could iterate through this as well. So I can just drag this in, compile that, and go ahead and run this program. Now you see, you can print that as well. So this basically stores multiple of the data types elements. And one more thing, since this is an array, this is more of a theory thing, but the elements here, so this string, so let's just actually name it 1, 2, and 3 for our reference. So 1, 2, and 3, these are actually stored in continuous memory locations. So iterating through them is actually a relatively cheap option. Now, unfortunately, Unreal Engine does not provide us with a linked list structures in Blueprint. We have to implement that ourselves if we needed to, but most of the times you'll be using arrays and maps. You'll not be using sets or linked lists most of the time. However, it is handy to use linked lists in some very rare occasions, but we will not be going over that anyways. So let's just delete all of this. We are done with this. So that's basically your array and your for each loop. Now you can have an array of structures as well. It's totally fine. So I guess we called ours mystruct, if I'm not wrong. We could have an array of those. That's about it. Basically, you could store any type of element. Now I can go ahead and click on the plus icon, and I can add the name and points, and it works just as you would expect. So I can go ahead and delete this. We don't need that anymore. Now, along with your regular if, switch, and your loops, Unreal in Blueprints provides us with a couple of handy nodes which you might need. One of them is called flip-flop. So what does it mean? So flip-flop is basically this is how a flip-flop works. If this execution pin goes in once, A is going to be executed. Otherwise, if you come here again, B is going to be executed. So let me actually show you what I mean. So if I just drag this in, and if I print, and let's just say A is executed, and now if I just go ahead and give in a delay of, let's say, a second, and if I copy this over and let's just type in B is executed, give a delay of a second, and again head back over there. So I'll just use a reroute to make things a little more clear for you guys. Now make sure you guys do comprehend this logic correctly. If I go ahead and press play, you would see it says A is executed, B is executed, and it's going to be alternating like that. So that's the use of a flip-flop. You could use this for key presses. So let's say you wanted something to happen when you press the key once, but you wanted something else to happen when you press the key again. So for example, let's say you have a scoping in thing in your game. So let's say you're scoping into your weapon. Let's say the first time when you flip-flop to A, you want the guy to scope in, and when you flip-flop to B, you want your weapon to scope out. So that's basically one place where you can use flip-flop. So it's pretty simple. Now, one more thing which the engine provides is do once. Now, do once, and there's also a gate node which you might need, but I've honestly never gotten an actual use case for this. So there's nothing much to really worry about this, but it can come in handy depending on your game, especially if you're going for, you know, puzzle type games maybe. Not really sure. So do once, basically as the name suggests, it just allows you to execute this one time. So let's say I print this string and I go back to this. This is no longer an infinite loop. It's just going to execute it once. Look, it just executed hello, and that's about it. Now, let's say I want to call this function just once again. So what I can do is I can drag this into reset. So if anything goes into this reset, the function which goes after completed will be allowed to execute once again. So that's basically how do once works. I don't think there's any explanation required for it. So if I do it on tick, so basically every frame it's going to allow you to do it once again. And if I just go ahead and re-execute this, I know this is an infinite loop, but we do have a little bit of a duration for us in the tick. So that's how it will work. Okay, so it did stop the execution over there. That's a different thing. But yeah, basically reset is going to let you do that once again. So I can actually get a more practical example. So let's say we have a delay of 0.2 seconds and we do this. I can actually use a sequence. So sequence, remember the node which we used before. So after 0.2 seconds, I can go ahead and reset that. And after, let's say, 0.5 seconds, I can try executing that once again. So if I go ahead and press play, you see it works as expected. Whatever we spoke until now were just the basics in order to get you started with Unreal Engine. But in order to actually practically create a game, we need to first go into some background so that we can learn how to use classes and objects. Now, if you guys aren't aware, Unreal Engine or any game engine in general is going to be working on the principle of object-oriented programming. A bit of a background here. So there are two main programming methods that we'll talk about now. The first one is procedural programming. So this is the approach used in languages such as C, where basically your approach is mainly using functions. So procedures, that's what basically procedural programming stands for. So you have a main function and you have several other functions. Now this is the most simplest form of what it could be. However, you could have a function over here as well. So let's say you have function 4 for example, and maybe function 4 can call function 2 or vice versa. Doesn't really matter. But basically your whole program is divided into multiple functions and there is some global data on which it operates on. So you have some data over here and maybe function 3 accesses some data here. Stuff like that could happen in procedural programming. However, the approach which is used in Unreal in object-oriented programming languages such as C++ is going to be object-oriented programming, of course, as the name suggests. And here we use a principle known as classes, and an instance of this class is known as an object. So let me be a little more specific here. So all the data and functions, so for example, or in this case, this was a method, this was the main function, so we have one method here, another one, and we also have some data over here. So all of these is going to be encapsulated into a unit known as a class, and I will get to some examples later. So once we have this encapsulated, we can go ahead and create instances of these called objects. So basically your class acts as a template for these objects. Now the first question that pops up in your mind would be, why do we use object-oriented programming over procedural? Well, it's pretty simple to explain that. So if we look at the wrong approach, that is procedural programming, you would know that you would have a character, let's say for example. So let's actually talk about a character which you'll have in a game and how you would approach it with both programming methods. So in procedural programming, you would have a character. Of course, you're not defining any unit known as character, but let's say we have a character in a program and you're going to have several functions. So you have move, turn, jump. Of course, you'll have other functions. I just took the most bare bones example. And obviously you'll have the character's transform. And if you guys forgot about what transform is basically location, rotation, and the scale combined. Then you're also going to have a velocity for the character, health, and other variables pertaining to your gameplay. However, there is one problem which you might notice. We do not have a unit which we can recognize as a character. So we have several functions. Let's say we call the move function, for example. Now, when we call the move function, we actually have no idea which character we are moving. So character itself is not actually an entity. So we don't have an actual entity known as a character. Our program just has functions. Same with the transform. We cannot instantiate another character. So this entire code isn't reusable. So that's the problem. Now, what if we head back into the object-oriented type? So if we head back, and if you can see here, we have a class and we have instantiated several objects. Now, if you were to actually model a character with this, you would have your character class. Obviously, with the above mentioned functions and data, I didn't want to rewrite that. So you'd have a character class. And now that we actually have a unit which we can identify as a character, we can go ahead and instantiate a character, and let's say we call it character 1. So we are going to instantiate it. And let's say we have another player, let's say an enemy. So we can go ahead and reuse that once again and instantiate character 2. So now we don't have to rewrite all the functions, and whenever we are actually writing code, we have an idea of which exact character we are referring to. So character 2 is actually a real-time entity, and this is known as an object. So character 1 is an object, character 2 and character 3, all these three are objects. Now if you were to remember, in our blueprint nodes, we had a target pin. So if I bring in, for example, set actor location, so I'll just use the same node, so set actor location. Now you would notice there is a character pin. Now if you were to just hover over it, it says actor object reference. Now in our programming approach, what this basically means is we have set actor location defined in our class. So let's say, for example, we have something like this. So we have our actor class. Now anything that can be placed in the level is called an actor. So let's actually create that. So actor. So inside actor, you actually have a set actor location method. So set actor location, I'll not write the whole thing. And let's say you instantiate actor 1. So let's call it A1, for example. When you instantiate actor 1, your program needs to know on which actor set actor location has to be called. So we have actor 1. So that is our target. So when we call set actor location, in our case, in our blueprint, we call set actor location. Now it needs to know on which actor it has to perform it. So when you call this, through the target pin, in blueprint, that's how you do it. In the target pin, you specify that, and the program knows that it has to set A1's location. So that's how it basically works. Alright, so it's time we apply whatever we learned just now. So head into your content folder and create a new folder, and we'll just call this one blueprints. And inside here we'll create all our blueprint classes and we will compare all of them. So basically the most bare bones one which you can create is an object. Now please do not confuse this with an actual object. We are creating a class and the class name is going to be object. We are basically deriving a class from this object class. This is how you basically start in Blueprint. However, as you proceed further, you will understand. Note that this is not an actor, so I cannot drag this into a level. Now, as I'd mentioned before, Unreal Engine already has a 2D vector structure, but just to showcase what we can do with such classes, let me just actually create a 2D vector. So let's just call this one 2D vector, for example. Now please note, you cannot name a type with a number beginning in C++. However, you can do that in Blueprint. So let me just call this one vector2, for example. So if I open this up, you would see you have a standard Blueprint editor, you have an event graph, but you don't have your viewport and stuff like that, which you would see in an actor. Now one more thing you would notice is you don't have an event begin play. So you get an option to add a custom event, which is basically like defining a function, but it does not return anything, and you can call it just like a function. And we will be using a lot of custom events, so you would get an idea of what I mean. Now, in vector2, we are going to have two variables. The first two are going to be floats. So obviously we'll think about what we can have later on. So it's going to be an x and a y. So these are the variables which are encapsulated inside this vector2 class. Note that this is not an object, this is a class. And when we actually create an instance of this, we create a vector2. So that's how it basically works. Now, we don't want this x and y variable to be directly accessible. Now, the reason I want it this way is for data security. Now, I don't want to be directly able to write any random value to x and y. Let's say this was exposed and you could actually change this directly in memory. What would happen is, now for example, let's say I have a vector2 object. So let me just create that. So you use the construct object function. So construct object from class. So I think I misspelled that. So construct object from class. Yep, there we have it. So I'll just delete this. And if you go ahead, we will get access to our vector2. So vector2, for example. Now we have a vector2 object over here. So this is actually a vector2 object. We could go ahead and promote that to a variable. So it's going to create a variable of that type. And let's just call this one r vector. Now we don't want any other external entity to actually be able to directly set x. So this would be prone to lots of exploits basically. So that's the reason. What you generally do in object oriented is you make this private. You see the option over here called private. Now basically you will not be able to access x and y from here. So now if I type in get x, you see I can't get it. If I type in set x, I cannot set x. So that's one way of providing security to the data. Now what if you just wanted to access the value? That's pretty simple. You would just go ahead and create a function. So you type in get x value, for example. So get x and get y. And we are going to make this pure functions because we are just returning the immediate value. And we could add a compact node title and call this one x, and we'll call this one y. Now in the return node, we could just go ahead and return the value. So return node, and we can go ahead and grab our y here and return that. And over here as well, we can go ahead and return x. So grab in the return node and return x. So now if you wanted to access x or y, you can go ahead and type in get x. So you will get access to the x value. However, you will not be able to edit x directly. So again, for that, we can go ahead and create setters. So setters are basically just functions which are going to set the value. So let's say I type in set x and I type in set y. I accidentally typed x again. So set y. Alright, so once that's set, we can go ahead and take in the value. And this is going to be of type float. And we can go ahead and set our y to be equal to that. And we can go ahead and type in the return node. We don't really need it in this case, but anyways, we'll have it. And in our set x function, we could do the exact same thing. We could add in an input pin and call this one value once again. Value. And we can go ahead and add in a return node. Whoops, we didn't need that. Now what if you just wanted to set this entire vector? Now when we set our vector, we are actually just getting a reference to it. We are not actually setting our members. So we can go ahead and write a function for that again. We could add a get vector to, and we could also have a set vector to. So something like this. This was just to show you guys how you would work with classes and objects. So for get vector to, we can go ahead and actually return the value. So we can go ahead and add in the return node, and we can get our x and our y. So things like that. So for a set vector to, we can go ahead and alt drag this once again. Now obviously please do understand that this is kind of impractical. Unreal already has a struct built in which handles all this for us. I'm just trying to show you an example of how you would actually use it. So this is how you do it. So now if I type in set vector 2, you see I can actually set its value, and the target is our vector, so we are adjusting this value. And we could go ahead and write in a few more functions. So for example, we could write a function to print the vector 2. So print vector 2. So we can go ahead and type in print string, and we need a world context object. However, it is going to take the outer object by default, I believe. But anyways, in these contexts, what you would want to do with something which I haven't seen much is you would just get the outer object. There is a function for this. Basically, the outer object is the object from which this object was created. So in our case, it's our level blueprint, and we can call the print function from there. The reason is it actually needs to know where to actually print the string. So that's the reason actually. So now I can just type in self. Self refers to this object itself. So we can just pass that in. Now we can go ahead and actually print something. So in our case, we can get our x. And one handy function which you'll use a lot is going to be append. So we can go ahead and type in x for the x value, give a space, and then print out our x. Move that over there to keep things clean. And we can go ahead and do the same for the y as well. So we can go ahead and give a space, and we can type in y with a colon, and we can go ahead and print that. So we have our y. We can go ahead and convert that once again, and we can go ahead and print that. If you right click, you can actually remove the extra pin. So that's an option available as well. So now this is how you would do it. Now if I go ahead and press play, obviously we are not calling it anywhere. So now that we have our vector, we can go ahead and call print vector 2. So this is going to print our vector. So this is how it works. And obviously we can also test out our set functions. So we can type in set vector 2, and we can just give some random values to this. And if we go ahead and print vector 2, we should get that value. So this is basically how you would work with the most basic type of object. Now this is mostly useful in cases where you only need some data and methods, and you want methods basically, because in Blueprint you cannot have struct methods. So in those cases you would use an object type. So we are not going to be messing with this any further. Now the next type which you will use is going to be an actor. Now this is probably the most commonly used type, and most of the other types of classes which you'll create will also be derived from actor. So let me just create that. Right click, go to blueprint class and create an actor. It's directly available here, or you could search down there. So if I create an actor, we'll call this one my actor, for example. Now if you were to notice, if I drag this, I cannot do that. because you cannot place a vector 2 in your scene, right? However, I can drag my actor and I can place it in the scene, and if I hit F on my keyboard, I can actually see it. Now this is just a visual representation in the editor so that you can actually see it. However, if you hit G on your keyboard to go to game view, it actually won't be seen. Now if you were to open your actor, you'd see the editor is a little more complicated than your basic object. You have 3 tabs: the viewport, the construction script, and the event graph, where you will be working with most of the time. We will separately talk about construction scripts and we'll also get to the viewport, but of our relevance is the event graph right now, and we will talk a little bit more about actors. You would also notice that we have our begin, play, and tick, which we missed in our basic object type class. Now if we wanted to have multiple of these actors, so let's actually do something practical. Let's say we had a pickup actor in our game. So we have pickup actor, and it's generally a convention. You do something like this, BP underscore pickup, because more often than not, or here if you see the parent class, it says actor, right? So more often than not, you will actually create another class of your own in C++. So any code that needs to run fast or something, you would put that in C++, and then you would derive BP pickup from the C++ pickup actor. So that's why it's a convention. I usually name it like this. So I can go ahead and grab this. So I have BP pickup. Whoops, deleted the wrong thing. So I can delete my actor here. BP pickup 2 will be created. So these two are pickups, and both of these contain all the variables and functions which this creates. So we can go ahead and edit our blueprint just like how we would usually. Alright, so it's time to dive a little bit more deeper into some of these events, and let's actually start writing some practical code. So event begin play is called not when the game begins actually, that's the wrong way to interpret it. However, event begin play is called when this actor is instantiated. So for example, we have our BP pickup here, and since this is placed in our level, this will get created as soon as our level starts. So it is technically called when the game starts. However, if I just go ahead and print this, and let's just call this begin play, you would see 2 begin plays because we have 2 instances of our BP pickup. However, it need not be called when the game begins. It is called when the pickup actor is actually created. So when BP pickup is created, that is when it is called. So let's delete a vector 2 stuff. We don't really need it. Now in order to actually create an actor, remember that every actor is going to have a location, rotation, and scale. So that's the reason you cannot just create an object, because you do need a certain number of default parameters in order to actually be able to place something in the scene. So without a location, the engine has no idea of where to place it. That's the reason actor exists. Now if you head back into your level blueprint, let's actually give a delay of a few seconds just to show you guys. So let's say we give a delay of 2 seconds, and in order to create an actor, you call a function known as spawn actor. So spawn actor from class, and over here under spawn transform, we could just set that to 0 for now. It's since we don't have any visual representation, it doesn't matter honestly. So once that's done, we can go ahead and select our BP pickup, and we can go ahead and compile it. Now if I press play, you see begin play is called, but 2 seconds later another begin play is called. If you guys couldn't catch that, I'll give a longer delay. Begin play, and another begin play was called. And if you would notice in the outliner, you would actually notice another instance being created here. So if you were to notice, there is another BP pickup that is created. So that's basically how it works. And tick is called every frame. However, it need not be once again. So if I just go ahead, or I can just go and reuse it actually. So instead of this, I'm going to type in tick, and now this should be called every frame. Let's only have one pickup actor, and let's go ahead and not spawn this. So if you want to disconnect pins like that, by the way, you can go ahead and press Alt over here, and it's going to disconnect the pin. So we don't need that. Now if you were to notice, it's going to constantly print tick. So this should be about 200 to 300 times a second on my computer. So if I just type in stat FPS, whoops, missed that, stat FPS, it's locked at 120, so it's 120 times a second. So if you want to increase it, actually you can remove the cap by typing in t.maxfps space max FPS. Give something like 999 or 1000. Alright, so I don't know why I did that. Now head back into your blueprints, under your pickup, and under your class defaults, you can actually disable your tick. So you can go ahead and disable, and as you can see, nothing's being printed. Now there's another thing. You can actually change this parameter at runtime as well. People don't know this, but any and all details which are there in this panel over here. So let's say, for example, I go to my class defaults. I will definitely be able to change most of these at runtime. So for example, we have start with tick enabled. So we should be able to enable or disable tick at runtime. So let's actually just type in tick enabled. And as you can see, there is actually a function which lets us do it. So if I go ahead and actually enable tick first of all, and if I go ahead and disable it after 1 second, you would notice that tick is being printed, and a second later it stops printing tick. So that's basically how it works. And not only that, any and all parameters, and you can actually change the tick interval as well. Let's say it's printing too often, you could just set it to 0.5. So it will be roughly 0.5 seconds. Now as you can see, it is not printing as frequently. So that's basically one aspect in blueprints that is handy to know, because any and all settings that will be there will be usually exposed as functions to be adjusted at runtime. Otherwise, again, you have your class defaults where you can actually set them. I think whatever we did till now is clear now, so we can go ahead and delete this code. We won't be using it as of now. So now let's go ahead and actually write some code for the pickup itself. So let's say we had an object and we had to pick it up. First things first, there is no visual representation for the object. So let's say we actually just go ahead and, whoops, we go ahead and press play. You would see that you can't actually see anything. Now, if I zoom into this, so as you can see, you can't actually see this pickup. So first of all, let's actually add in a model and stuff like that. Now there is one thing, the default scene root is not actually required. If I delete it, I won't be able to. However, I can actually add in a static mesh. Now a skeletal mesh is a mesh which contains bones and stuff like that. So basically your characters and anything with animations is going to be a skeletal mesh basically. However, your models like your pickups and stuff usually are going to be static meshes. So that's basically how it works. As you use them, you will understand. So now if I drag this into the default scene root, I'll go ahead and delete the visual representation and the static mesh will be replaced. Now one thing to note, when you do this, the most high component, the component which is the uppermost in the hierarchy over here is called the root component. So for example, this default scene root is the root component now. When I drag this static mesh, this is the root component. And if physics has to be simulated, in our case, let's actually try that. Let's make the pickup fall down and follow the laws of physics. So in that case, we will need it to be the root component. So that's one thing to note. Now, if I go ahead and select a mesh, so for example, I can just select this random sphere that we have. I think it's way too big. So yeah, we got to adjust that. Now I can go ahead and enable simulate physics. So now if I go ahead and press play, you see that it falls like you would expect. So we basically simulated physics. Now we have a visual representation. Now how are we actually going to pick this up? Now actually let's select something a little more smaller because I don't think this is convenient. Okay, this seems like a reasonable size. So if we go ahead and press play, we are simulating physics, so absolutely no problem with that. And one thing to remember, in case you are not simulating physics, make sure you do have collision and stuff like that. If we actually encounter such an issue, I will go ahead and show you guys how to deal with that. So we have physics now. Now we can go ahead and set up some logic now. We want to be able to pick this up when we overlap it, let's say for example. So we can do on actor begin overlap. So what this says is when another actor overlaps this actor, so in our case it's going to be this, when it overlaps this actor, we can go ahead and perform some logic, and Unreal Engine has set this up for us. Now there is one problem though. This is just our cube, which is our model. However, we don't have an actual bound, so our code won't really be able to know when to actually call on actor begin overlap. So even if I disable collision, so the way you do that is you can head over here, and from physics actor you could go ahead and change it, but we do need physics, so we can't do that. Even if we actually bump into this, you won't really notice anything happen. So if I go ahead and bump into this, nothing is really going to happen. Now if I actually go ahead and create a bound, so the way you do that is right click, or rather go to add, and you can type in sphere, I believe, sphere collision, yes. So when you create a sphere collision, we could call this one bounds. You would have created a sphere, and you can't see that because the size is too small. You can go ahead and increase the sphere radius. Now these are our bounds. So as soon as we enter this, our on actor begin overlap will be triggered. So we can go ahead and print it. And if you were to notice the collision preset over here under the details panel, select this and head into your collision preset. You see it says overlap all dynamic. And obviously if you select custom, you can go ahead and edit each channel, and we will talk about this later. So if I go ahead and press play, you see we get hello every time we overlap it. Now hello is going to be printed every time any other actor overlaps this. However, we want to print hello only if a character overlaps it. And it need not be a character as well. Now in Unreal, character is actually a derived class of another class known as pawn, and I will talk a little more in depth about this right now. So basically this is how it's laid out in Unreal. Basically we are looking for a pawn, and I will get to that in just about a minute. So we can type in pawn, and if you were to scroll down, you would see cast to pawn. So cast is another programming feature. Now if you were to feed in an object to this, you can check whether it is a pawn object. So now if I go ahead and print this out now, you would go ahead and actually get hello just normally. The reason is, when you are actually controlling your camera over here, you are actually controlling a pawn actor. Anything that can be possessed by a player controller is known as a pawn, and we will talk a little more in depth right now. And just to clear your doubts on whether this logic actually worked, let's say it wasn't a pawn, so which means it's not a player basically. So if I copy this over, and instead of hello, let's just print not player. And now if I go ahead and press play, you'd see you won't get anything. And if I overlap it, it says hello. But if I go ahead and copy this over, and let's say keep it above this, and if I press play, you see you get not player printed. That is because the box overlapped another box, or rather our BP pickup overlapped another BP pickup. However, those are not characters. So this cast right here failed because the object which came from this actor begin overlap was not a pawn. Hence, we got not player printed. Now, since we are still at the beginner part of the course, I'll just tell you guys the most basic form of inheritance hierarchy which is there in Unreal. However, once we get to the more advanced part, I will tell you guys more in depth. But as far as what you guys need to know, So at the base level, the most simplest type of class from which you can instantiate objects is known as object in Blueprint. So object is the simplest type, and from that, the most basic one which you can create is going to be an actor. Now an actor is basically an object which has a transform and can be placed in the level, as you would have figured by now. Now under this you have various other classes. However, for the most basic level, we are going to be considering only two. So there are many more, and we will talk about many others once we actually come to the advanced part, but these are the two which you do require to get up and running. So the first one under this is going to be your controller. So a controller, as the name suggests, is a class which has functionality for you built in to take player input and stuff like that. And under controller you also have a special type known as a player controller, and there are others such as AI controller. So you have a player controller. So player, and I'm just going to put this. So player controller. Now a player controller is basically a controller which belongs to an actual player. You also have other things such as AI controllers, which is assigned to CPU players basically. So if you have enemies in game for an offline game or something, you would assign an AI controller. Now another class that you'll need is pawn, and that's what we talked about. So this is called pawn. Now a pawn is basically a class which is an actor obviously and can be placed in the level. And note that you cannot place a controller in a level, although it is derived from actor. It is actually an exception. Controllers, player states, game states, there are a few other classes which are exceptions and you can't place them in the level. However, pawns can be placed in the level, and a pawn is always possessed by a player controller. So a player controller is going to be possessing a pawn. So when you call the possess function and you give the target as a pawn, you are going to be possessing the pawn. And one special type of pawn which has a lot of functionality built in for us already is called a character. Most of the times you will be working with characters and not pawns. However, you can use pawns. So by character I mean a character such as a living being basically. So generally if you have like a human, or if you have like an animal or something like that, you would generally use characters. However, if you have something like a vehicle, you would usually stay away from characters because it has some properties which are not realistic for those. However, it is completely possible to use a character class for something like a vehicle as well. So you can possess a character as well. There is no harm in that. Pawn or any derived class of pawn can be possessed by a player controller. Since we have the basics in order to get us started, we can go ahead and actually create our own character class, or I should rather say pawn class, which is also a character class in our case. So we can create that as well as a player controller, and I'll show you guys how to set those and how we can go about interacting with this pickup using those. So right click, go ahead and create blueprint class, and as you would see, you have character and player controller right here because they are really common. So type in character and let's just type in BP underscore character. Again, you can name it appropriately or as per your wish. Now if I go ahead and open it up, you see this looks a little more different and it already has something set up for us. And some of these are quite handy, especially the character movement component which is there. And if I haven't mentioned yet, whatever we did here under the components tab, these are called components basically. Basically every actor is made up of several components, and you can actually create your own components as well and make them behave as you wish. But as of now, just know that these are just constituents of this actor, and these are the constituents of BP pickup, and these are the constituents of BP character basically. Now we haven't set a mesh and we don't really have one, so let's just take, okay, we have a character, tutorial TPP, and one thing to note, this arrow actually represents the forward direction of the character, so you can go ahead and move it down and you can go ahead and rotate it 90 degrees. So let me have snapping enabled. So rotate it by -90, and you can go ahead and bring him all the way down until I feel it's correct. Now we don't have any animations, but I'm not really sure if we do have an animation blueprint for him. So let's just check tutorial animation blueprint, I guess. Tutorial TPP animation blueprint. So yeah, we do have an animation blueprint for him. Now, if you want to change the default character that you'll be using, the way you'll do that is by first of all heading into Window, World Settings, make sure that is enabled, and then over here on the right hand side, head into World Settings, and under Game Mode Override, you can go ahead and set your own game mode. Now, if I were to just select game mode, I still cannot edit it. So I will get to game mode classes later on because they're not that important. But for now, you can just go ahead and create a new game mode, and it could be of type game mode base or it could be of type game mode. It doesn't really matter, but I would suggest sticking with game mode base. And let's just call this one BP underscore game mode. I just did something there. So yeah, BP underscore game mode. That's what we'll call it. And now under this, we will get our option to select the game mode. Now, since this is our custom made game mode, we get the option to select the default pawn class. And over here, we can select our BP character. And if I save everything, and if I go ahead and press play, you'd see that we have indeed possessed our character. And you were to notice that the camera is a bit off. So what you can do is you can actually create a camera. If I go ahead and type in camera under the component section, you can create a camera and you can align it as per your requirement. So this should be about correct. So I feel rotating this a bit, maybe a bit back, maybe a bit to the side would be nice. So there you have it. So this is our character. However, we are not actually able to move. The reason is we haven't actually written the code for it to take our input. Now, setting up input in Unreal is really easy, and I will show you guys the brute force method as well as the proper way to do it. So the brute force method is, for example, we want W to be able to make us move forward. So you can press W, and if you just give a space and type in keyboard, you would be able to get W, and we can make the character move forward. So in order to make your character move, basically there's a function for us built in already under the character movement, and not character movement, I believe. It's there in our pawn class, I believe, or a character class. So if you right click and type in add movement input, so it's written in our pawn class, we can go ahead and make him move. And if you were to notice, we have to provide a direction and a scale value. Scale value is useful if you're on a joystick or something where you can partially press down. So let's say you're halfway pushing the joystick knob. So in that case, it would be 0.5. So the scale value can be given through an axis value. Now, if you were to notice, there is another problem here. When I actually plug this in, it's not really going to work as you would expect. So for our direction, we need the forward direction of the character. So a very simple way to do that is typing in get forward vector. So get actor forward vector. So get actor forward vector. So that's the way you would actually get the world direction. That's how you do it. And if you were to notice, it's not going to work as expected at all. The reason is this has to be called every frame in order to actually work. So the way you do it is type in, or rather we can do it on event tick, for example. So if we go ahead and do it on event tick, I'm just doing this to show you guys how to do it. If I do this, now we would see that our character is moving forward. Now the most obvious question is, how am I actually going to set this up? So there is something known as an axis mapping which runs every frame. Basically what add movement input does is it moves you a very slight amount, and by calling this multiple times in a single second, you are going to be adding considerable amount of movement. Now if I head into my project settings and under input, this is the right way to do it. The brute force way would have been like doing this on tick, and I'll just show you. This really shouldn't be your option, but I'll just show you just in case. So for example, we could just have a boolean here and we could just set this to true, for example, and when you release it we could set this to false. Now this is wrong, so don't really worry about the logic. This is just gonna work, but you shouldn't really do this. So we could do if new variable is true, we want to move, otherwise we don't want to do anything. So if I go ahead and press play, I can press W and move, but as soon as I release it, I'm going to stop. This is the brute force way to do it, but Unreal has a much more elegant system to do it. So we can go ahead and delete all of this. Head into our project settings once again. And under input, you would see action and axis mappings. Now we want an axis mapping because we do want to be able to control the scale. And since add movement input is actually a function which depends on the scale value. So remember what I told you about the joystick. So we can create an axis mapping. So for things such as jump, where there is no scale value, so it's either jumping or not jumping. So wherever you have a toggle, you'd have an action mapping. Wherever you have some value which goes linearly, you'd have an axis mapping. So we can call this one move forward and make that Pascal case, and we could have W on the keyboard for that. And again, for move backward, we could reuse this actually. So S is going to be move backward, and for the scale value, you can make this -1. Now, if I right click over here and if I type in move forward, you would notice that we have an axis mapping. So if I grab this into this input event, or rather if I bring this into this axis move forward event, and for the scale value, if I put this under axis value, now this will work exactly as I would want it to. So if I go ahead and press W, it's going to work, and even S is going to work now for us. So this is basically how you do axis mappings. Similarly, you could do it for move right. So we could have move right, or we could call it move sideways. And we'd have our A and D keys. So we have our A key and we have our D key. So D is going to be this one and it's going to be -1. So let's actually just test it out. So it's not really doing anything because we didn't set up the logic obviously. So move sideways, whoops, axis move sideways. So once you have the event set up, you can go ahead and add the movement input, and again you can get the right vector of the actor. So basically the right direction of the actor is going to be your right vector. So your forward vector is always in this arrow's direction and your right vector is going to be a vector in this direction basically. So right vector, and if I go ahead and press play, so it's always 1, so that's the reason it's happening. So if I plug that into the axis value, I am moving reverse actually right now. So that's just a simple mistake I did here. So I can type in -1 for this and I can type in +1 for this. Now everything should work as expected. So if any of your directions are reversed, just multiply the axis value by -1. Now as you can see, we are able to move forward, left, right, and all of that good stuff. Now that is about it for the keyboard input. However, if you were to notice, I really can't rotate the character. So let's actually set that up first. So first things first, head back into your BP character, and the functions which we require to set up keyboard input, mouse input for our character is going to be your controller pitch input and your controller yaw input. So controller pitch input and controller yaw input. So these are the functions that we need. Now again, since our mouse needs to be captured as much as possible because it has to detect every tiny movement, so we again need to create an axis mapping. So go ahead into inputs and create 2 new axis mappings and call one look around, and the next one call it look up. And for this, look around is going to be the x-axis of the mouse, so type in mouse x, and for this one type in mouse y. So that should be good. And over here, if I go back and if I type in axis look around, and we can go ahead and add yaw input over here, and over here axis look up. Oops, I misspelled that. So head back into input, so look up. Now if I go ahead and compile this and press play, you would see that I am able to look around. However, I really am not able to, look up and down. That's mostly because your character isn't really meant to rotate along with it. So that's the reason it's happening. So if I head into my camera and enable use pawn control rotation, and if I press play, you see I am able to rotate my camera. However, there's one small problem here. We are again doing it reverse. So again, in that case, as I told you guys before, just change the scale value to -1. Now if I go ahead and press play, you would be able to see that our camera is working as expected. Now there is one slight issue though, that is our view is kinda off, which you can fix. But when we actually look up, our character doesn't seem to be looking up. But the reason that's not happening is because you can't just rotate the whole character. Now if I were to actually go to this main tab over here under BP character, and if I search for control rotation, so if I type in control rotation, and if I enable it to use pitch, you would actually see that I am in fact able to do that, but there is a small problem. Now if I hit F8 to unpossess my character, you see he just rotates like that. However, we want only his spine to rotate, and that is something which we have to set up using an animation blueprint, which we will do later. So for now, we'll just disable this. And even for the yaw part, you could disable this, and you could technically do something like this, and maybe set up some other logic in order to actually rotate your character. But for our purposes, we'll only do it for the pitch. Another tiny thing that I would love to cover here is how do you actually set up different sensitivities? Because obviously right now, the current sensitivity may be a little too much for some maybe it's a little too less. So the way you do that is you just multiply this axis value by your sensitivity value. That's basically how you do it. So multiply this and multiply this as well. Press Ctrl D to duplicate that. Now we could just promote this to a variable. However, remember that this BP character refers to only the character which we are playing. So let's say we are playing a death match or something where your character dies and you respawn with a new character. You would have to pass in the variable every time. So instead of doing this, we are going to set this up in a class which will be common even when your character is destroyed. So the class which we'll use, and as you would expect, is called player controller. So go ahead and create BP player controller. So make sure everything is in Pascal case. Now if you open this up, now over here we can go ahead and create a variable and call this one sensitivity. And now this is going to be of type float obviously. And let's make this one private. And let's create a method to get the sensitivity. Now this player controller is going to be persistent even after your character dies. So that's the reason we are using it. And since we need the immediate value, this will be pure. And for the return value, we are just going to return the sensitivity. Now obviously, the reason we are doing it this way is you don't want an external entity to actually modify sensitivity, that would be crazy. And one more thing, make sure you set this value to anything other than 0, because if it's 0, your mouse obviously will not move. So maybe something like 0.5. So once that's done, I should be able to set my player controller first of all. Over here in your game mode override, for your BP game mode, go ahead and change your player controller to the one you created. Save that and open up your BP character. And now on begin play, what we can do is we can actually get our player controller. So we can type in get player controller and we can cast this to our, as you would guess, BP player controller. So we are getting our player controller and we are checking if it is a BP player controller. Obviously we set it over there in the game mode, so it will be. There's no way it's going to head into cast failed. So we can just right click and make this a pure cast. So this just helps us save some space in the graph. This will be a success for sure. And we can go ahead and type in promote to variable and we'll call this one PC ref for player controller ref. Now go ahead and compile that. Again, you can go ahead and make this one private, but honestly it doesn't matter in this case. So on begin play, we have gone ahead and stored our player controller. And from our player controller object, we can go ahead and get the sensitivity. Go ahead and get the sensitivity. Go ahead and do the same thing over here. Compile that. And if I go ahead and press play, you would see our sensitivity works. And not only that, actually, if I go ahead and change the value, so let's say I make this 0.01 or rather 0.05 for example. 0.01 would have been too less. Now as you can see, I can make very precise movements. So now this sensitivity option definitely works. So this is how you would actually go about setting up sensitivity. Obviously if you really didn't care, you could just have a variable here and stuff like that. Doesn't really matter honestly. And there's another thing which you could do is first on begin play itself, you could go ahead and pass your sensitivity over here. And you could promote this to a variable over here. And instead of calling the function every time, and make this one private once again. Instead of calling the function every time, you can go ahead and use the sensitivity variable. So that's a little more better in terms of performance. This is something which you could do as well. Now remember, we are only able to do this because the player controller is always created before your character spawns. Let's say your player controller is not yet created by the engine, you can't actually do this. So let's say I go to my player controller and I'm not sure if I can do it on begin play. Maybe it would work on begin play, but technically if I type in get player character and if I type in cast to my BP character and if I go ahead and print a string, copy that over and I'll just type failed for this. And doesn't matter to be honest, and I'll type in success. Now if I go ahead and press play, you see we get success. However, this happens only because our player controller is probably created, or rather the begin play is actually called after the character is created as well. However, now I'll just show you guys another class. Now we'll discuss more in depth about this, but if I just type in game instance, I can go ahead and create a game instance class. And this is actually referring to your whole game application. So if I type in event init, this is when your game starts. It's not like the begin play where you're actually, talking about when this entity is created. The event init is actually called when the game starts. So that's one difference. So over here, if I go ahead and put this logic over here, and if I go ahead and go to my project settings and change the game instance to new blueprint, we'll delete that soon. And if I go ahead and press play, you see it says failed because our character is not yet created. So that's one thing to note. The begin play logic only worked because our character was already created. Now let's say we added a 2-second delay. Now this is gonna work. So now if I do this, it's gonna work because our character is now successfully created. So that's basically one thing that you guys need to understand. Just make sure all your entities are valid before you actually set them, and we can go ahead and revert our game instance. So again, we'll talk about all of this more in depth. This is not something which you would really worry about at a beginner level. Now save everything, and that should be good to go. To go a little more in depth on the part where you'd actually check if this object is created. So in our case, I mean, everything just worked out smoothly, but what if it didn't? What if this wasn't valid yet? Because as I told you guys, the default value is none. What if this wasn't valid? Well, there is a fix for that as well. There is actually a function called isValid. So if I go ahead and type in isValid, there's actually a macro which is created for us. So what we can do is we can go ahead and actually do this. So if we can convert this to a normal impure cast. So on begin play, we can go ahead and do this. We can check if it is valid, and if it is not valid, we would not want to do anything. But I mean, if it is valid, we want to set the reference obviously. But if it is not valid, we want to again check after a while. And if it is valid, obviously after setting the reference, you would want to go ahead and set the sensitivity and do the regular stuff. Now what if it's not valid? Now how do we actually check once again? So for this, you would use a technique known as polling. So polling is where you repeatedly call a certain function until a certain condition is met and you actually get your desired result. So the way you can do this is by using a timer, and that takes us to the next important concept. Now if I right click and type in set timer, you'd see you'd get a few nodes over here. However, the only one which you'll use is set timer by function name. Set timer by event is kind of pointless in my opinion, because even if you do use this, you can actually refer to an event by the function name itself. So most of the times you would be using set timer by function name. So use set timer by function name. Now it returns us a timer handle which allows us to control this timer. And what this basically means is it is going to call the function with a given name. So we can right click on this and type in collapse to function, and let's call this one, for example, get references, or let's call this one initialize. And we don't really need this in the event graph. And over here we can copy over this name. So what we are basically saying is after certain time, call this function once again. So we can have a very small time such as 0.01 seconds and make this one looping, because if you just set this to 0.01 without the looping, it's just going to execute it once. And we can go ahead and store the handle of the timer. So we can call this one initialization timer. And once we have that, this timer is now set, and we could just comment it out and call this one polling for references. Again, you could name it a little more descriptively. You could give it a color as well. That's one cool feature in Unreal. Honestly, you would never use it, but yeah, I just showed it. And under initialize, we need to stop the timer once we actually finish everything. So once we finish setting the sensitivity, there's no reason for this function to run again. So we can go ahead and get our timer handle first of all. And if you just type in clear, you'd get an option called clear and invalidate timer by handle. Go ahead and call that. This is how you stop the timer. Copy this, and if it is not valid, we don't really want to do anything. And if the cast failed, again, we don't really want to do anything. So again, yeah, this cast is bound to fail actually. This check is kind of useless in this case. So we can just go ahead and do this, because if we don't have a play controller, this cast will obviously fail. But anyways, I'll just keep it like this. And now if I go ahead and run this, what will actually happen is every 0.01 seconds, it is going to repeatedly call the function until we have cleared it. So once we get all the references, we go ahead and clear the function. clear the timer. There are some key differences though between doing this and using a delay. Obviously you could have done this as well. So you could have done delay, and let's say we gave 0.01 once again, and over here we can go ahead and call initialize, and we can go ahead and loop this. Obviously we can call this first. So initialize, then after 0.01 seconds we could do this, and maybe we could check if we have all the references. We could maybe return a boolean over here or something and do something like that. The difference between a delay and a timer is that a timer is going to be very, very precise. It is going to be precise usually up to micro or even nanoseconds if you have a precise timer. This one I believe is precise up to a couple hundred microseconds. So as far as my testing is concerned, you could use chrono in C++ and actually test it. So this is going to be accurate. However, a delay is going to be very, very inaccurate. So that's one thing to note. If you want something to time accurately, you would use a timer. Or in our case, we needed the looping functionality. So that's the reason we used the timer. Since we have built a fundamental idea on how inputs work, now we can go ahead and check the other type of input, that is input action mapping. Now before that, let's actually just clean this up a little bit. So just comment it out and type in movement, and maybe you could type in movement and camera maybe. So movement and camera. So now we can just group these. Now head back into your project settings, and under input again, if you look at action mappings, you can go ahead and add one, and we can call this one interact, and we could set that to the F key. Now the advantage of using it through the project settings like this rather than brute forcing, so you could do F over here as well. So if I just type in F and give a space and type in keyboard, I can actually do this. But this is not the proper way to do it, because these action mappings can be actually changed through your in-game settings menus. So you can actually create a menu inside the game and allow the user to change, or allow the player to change these key bindings. So we'll call this one interact now. So action event interact, and this gives us a pretty basic pressed and released option. So when we actually press it, so we want to be able to pick up an actor. Now how are we going to actually set this up? So first things first, remember we had our actor begin overlap. Instead of doing it here, it's always advisable we do it from the character. So do your actor begin overlap here, actor begin overlap. Once you call the actor begin overlap, over here for the other actor, instead of casting to a character, since we are the character ourselves here, because we are inside the character class right now, we can cast to the pickup instead. Now that we have casted to BP pickup, we are checking if this is actually a pickup. Now there is a better way to do it using interfaces, but that is a much higher level concept than casting. But I will definitely get to that a little later in this course. So we'll probably change this to use an interface. Even that is casting at the very fundamental level, but that's a more elegant solution to do things. Now if this is actually a pickup, we can go ahead and actually store it. So promote to variable, and let's just say let's just call this one nearby pickup, and what we can do is on our actor end overlap, so end overlap, over here we can go ahead and again cast it, first things first, and if it is, we can check if it is equal to the nearby pickup, and if it is equal to the nearby pickup and we have left its bounds, we can go ahead and remove it and invalidate the reference. So we can alt drag it and we can set it to be equal to none. That is going to invalidate a reference. So that's about it. Now once we have our reference, what we can do is we can head in our interact function, check if this is valid. One more way you can do it is by right clicking and converting this to a validated get. So if our pickup is valid, which means we are near a pickup, so what we can do is we can actually call a function. For now, let's just print out a string, let's say. So, or rather we can just destroy it. So type in destroy and you will get destroy actor. If I go ahead and press play, and if I go close to it and if I hit interact, you see I destroy the pickup. And if I do that once again, that is not gonna work. The reason is, once our pickup is destroyed, it's no longer valid. So what we have to do basically is check once again if we have any pickups nearby. So that's actually really easy to do. So once we destroy it, we know that our nearby pickup isn't actually valid. So we can go ahead and set our nearby pickup to the nearest one. Now how do you check that? Again, using a function. So we want to see if we are overlapping. So type in overlapping. And you already see you actually get options for get overlapping actors, which is exactly what we need. And for the class filter, it's obviously going to be BP pickup. And over here, we get an array of actor references. Instead of getting all of them, we can just get the first one. This is an array, so obviously we have to get the first index of the array. So once we get that, we can go ahead and cast this to BP pickup once again. And it is going to be successful all the time, so we can just make this a pure cast, because we are actually using the class filter here. And then we can go ahead and set the nearby pickup. So now our logic should work for both the pickups. So if I hit F, one of the pickups got destroyed. So I shouldn't have moved back actually. So if I press F, one got destroyed. If I press F again, the other one got destroyed as well. And there are no errors. So this is basically how you do something like a pickup. Now obviously, before you destroy it, let's say you had some properties. Let's say for example, let's say this was a health portion or something which gave your player a couple of health points. So we can add in, I don't know, let's say health points. Obviously you'll have a better inheritance hierarchy and we will get into that. So health points, make this a float. Let's say we have 10. So what we can do is, for now we can just go ahead and print it. So we can grab this health points and we can just print it out. So move all of this logic a bit over there to make space. We can just print that before destroying it. Make sure you call print before destroy, otherwise you're going to get a log error. Now if I go nearby, if I press F, we are going to get 10 printed every time. So that's basically how you do it. However, let's say you wanted to change some of these properties depending on which pickup it is. Now, apart from having these as a variable, you can go ahead and check these two options called instance editable and expose on spawn. What these will do is allow us to edit these properties when we actually spawn it. So let's say we spawn a pickup, for example. So over here, let's say I do spawn actor. Let's say we spawn a pickup. You see, we actually get an option to change our health points. So we could do something like 90, for example. And for the spawn transform, we can just get a random location, let's say. Let me just add in something for us to recognize. So something which you'd use for such a case is called a target point. So you can use a target point. So this will represent a point in space. You can copy this over and we can go ahead and paste it in. Or okay, maybe we can't do that here. You can do it in the details panel. So 1150 and negative whatever this value is and 650. So 650. And we have health points set to 90 over there. Now as you would see, we actually spawned another pickup. Now if I go ahead and pick these up, you get 10. But when I go near this, I get 90. However, it need not be restricted to spawning it through the blueprint. You can actually edit expose on spawn variables right here as well. So even when you're placing them in the level, you could have this to be 20, for example. So if I go nearby, you'd see 10, 20, and this one is obviously going to be 90. So stuff like that, which you can do using expose on spawn. You can expose any variable on spawn and they will be passed right into the actor, and the value which you pass in would be set to that variable. And now we can go ahead and remove this logic. That was just for showcasing purposes. And we can go ahead and collapse this to a function and call this one, call this one pickup. And along with this, maybe we could also have something like door open or something. Let's say this is not valid. We could go ahead and perform door open or something like that. We could go to the return node and we could have a sequence node here. So first we would check for a pickup, and we could also do something like a door open or maybe anything else probably. Maybe if you had some sort of an interaction system with the player or something, so you could interact with the other player. Stuff like that, which you can do using these input bindings and using the overlap events. To showcase that, let's actually do one more of the interaction events. Now I will show you guys how to do it the better way with interfaces later, but this is the brute force way. And if you have maybe 1, 2 or maybe 3 or not more than 4 interactions, you could use this method itself, the one which we did with casting. So this is totally okay for small things. Now let's actually do it. So right click, create a new actor, and let's call this one interaction actor. Maybe we could just nudge it or something. So let's say we have another static mesh, make that the root component, and we need some sort of bounds, so sphere collision maybe. And for the mesh, let's just take a cone for example. And also I've gone ahead and deleted the code which we had inside BP pickup since we are not using it. And over here, go ahead and simulate physics. Make sure you don't forget that. And we can go ahead and, okay, maybe we can have a smaller one for example. So I'm not really sure. I'm just looking for any mesh that's available to us because we haven't imported ours. Okay, this is way too big. Okay, this sphere seems like a reasonable size. We can go ahead and increase our bounds. That's about it. And once again, over here we can head into our BP character, and what we can do is we can copy over the same logic. So instead of nearby pickup, we are going to have something else. So if this cast fails, so if whatever we are nearby is not a pickup, we can check if this is actually an interaction actor. So we can do cast to interaction actor, and again other actor is what we are checking. If it is the interaction actor, we can go ahead and promote this to a variable and call this one interaction actor. Again, I prefer going with Pascal case. Alright, now when we actually go away from it, we can again do the same cast. So we can copy this over, we can paste it, and for this actor, if it is equal to the interaction actor which we were nearby, so copy this over, grab in the interaction actor. If it was in fact the interaction actor, then we can go ahead and invalidate it and set that to be equal to none. So that should be about it. Now over here in the interaction logic, we can go ahead and check if this is valid. Right click, convert to validated get. So if we are near an interaction actor, what we can do is we can, instead of destroying, let's actually add impulse. So add impulse. So add impulse. So we want to add impulse to the root component here, which is simulating physics. Basically, these are the physics functions. You have impulse, force, torque, and all sorts of stuff. Obviously, you could spend some time and study those, but we'll not get into that. So we have a sphere here. So static mesh is the root component. So we need to get the static mesh. If I go ahead and scroll all the way down, I should see get static mesh. Now this variable refers to the component. Even components are objects, so you can just get them as variables. And for the impulse, what we can do is we can go ahead and get the forward direction of a character, get forward vector. Now you could change it according to your, this is logic based, so it's nothing much really. And we can multiply this by a certain value. So we can make this one a float and change this to a float. Make this, let's say something like 10,000, something big maybe. Get actor forward vector, multiply that by 10,000, and that should be good to go. Now we can collapse this to a function, and we can call this one nudge ball or something, because the sphere looks like a ball, so nudge ball maybe. And if I go ahead and press play, okay, we have a compilation error, so we can check what's that. So it says, let's read the error first of all. Okay, it was just, it just compiled it in the wrong order. It compiled character before this, so it didn't know what static mesh was. Now we should be able to go ahead and play this. And first of all, we don't have an interaction actor. Let's actually create one. Go ahead and press play. Now if I go ahead and bump into this, oops, I shouldn't have bumped into that. If I press F on my keyboard when I'm overlapping it, the bounce is a little too small. Let me just increase that. So increase the radius, don't scale it up. And one more thing, if you want to see the bounce just for testing purposes, you can set this flag called hidden in game to false. So now it is going to be visible in the game as well. So if I look around, yeah, there we have it. So we can enter our bounds. And now if I press F on the keyboard, you see we actually nudge it. So the force is way too small. So I can go ahead and make this something like 50,000, let's say. So if I go ahead and press F over here, you see we are actually nudging it. So this is the way you would set up interaction using casting. Obviously you can use interfaces to simplify things a little bit. But yeah, this is the basic idea. Alright, so in order to understand whatever I just told now, in case it went above your head, please do tinker around and try some of the functions yourself using the context sensitive and the search bar basically. So when you right click and let's say you drag something off of this, you can go ahead and type any random function. So for example, if I just press A, you get a bunch of functions. Maybe you could have a look at all of these, maybe have a look at documentation, and maybe try out some of your own logic and try out something else. Maybe add in another actor to do something else with, maybe add in a door and make it open or something. So you guys should be able to try it out yourself. And once you are actually done with that, now we can go ahead and talk about the next part. Now, until now, we talked about the basics, and I'm pretty sure you can write some basic game logic with whatever we have done already. But there are a couple of functions which the engine provides us, which is going to make our job a lot easier. The first one, and one of the most commonly used ones which I would like to talk about, is raycasting. Now, if you guys are familiar with other engines, you guys would know what a raycast is. But in Unreal Engine, you call it a line trace. So if I right click and call line trace, so you see you get a bunch of options. The one you'll use most of the time is line trace by channel. Multi is basically used when you have penetration and stuff, when you are detecting multiple hits in the same line. I'll tell you guys what's line trace first. So line trace is basically a function which lets us draw a line from a given starting point to a given ending point, and in between these 2 points, if you are actually hitting anything, you are going to get it as a hit result. So I can get access to the hit location. And in case you want to see the line itself, you can change this draw debug type enum and make this for duration. And if you guys wondered, this is an enumeration. That's the reason we are getting these options. So none, for one frame, for duration, and persistent are the enumerators. So if we select for duration, we are going to get the line for some time. Persistent means the line is going to be shown to us forever until you close the game, of course. So let's actually do something with this. So let's actually set up an input event. Let's say when we click our left mouse button, so we can type in left mouse. Now I'm just setting this up brute force because I don't really know what exactly we are going to set up. Once we actually get to the examples, we'll do that. Now for the start location, you can choose the camera's location of the player because this is where you would be seeing stuff. So you can select the camera's location, for example. So if I go ahead and get the start location, the way you do that is there are a couple of ways. You could do this and you could do get location. So you can get world location and you could use this as a starting point. And the way you would go forward towards the center of your screen is going to be first of all by getting the forward vector. So you can get the forward vector of this camera and multiply this by a certain value, again by a float. We'll do that. Add that to the starting location. So starting location plus forward vector into a certain number that is going to be your end, and we can go ahead and change this to a float. And we can do, let's say, 50,000. I mean, the number is arbitrary. Obviously, Unreal uses centimeters. Remember that. So anything that you type in will be in centimeters. So 50,000 centimeters is going to be divided by 100. So it's going to be like 500 meters. Now, if I go ahead and press play, if I press my left mouse button, you see, you get a line drawn over there. So if I press F8, you see I can actually see the line which was drawn. So the red thing which you see, that is the line which was drawn. And as you can see, where it hit the surface, it actually registered a hit. And in order to show that, there is one more thing which you can do actually. Oh, and about the other options, trace channel is something we'll talk about later. But basically you can do stuff like ignoring several types of objects. So let's say you had a shooter game and let's say you wanted to like ignore teammates, you could use it for that. But you'd use tags for that as well. But there are several other use cases. Camera is another thing. Depending on what type of objects you want the hit to detect, you would do that. And actually if you were to notice, if I select my mesh, and if I scroll down to the collision part, so I'll just type in collision instead of searching for it like this. So collision, you were to notice it says character mesh for the preset. And over here, if you see, there is actually visibility and camera. So what you can do is you can actually make it block certain things. So now let's say I wanted this line trace, which is using visibility right now, to block it. I would have to change this to custom and make this one block visibility. So then I would be able to make this line block it. Stuff like that which you could do. Now obviously I'll change it back to character mesh. We didn't do anything, but still. So over here, change it back to character mesh. And let's say you wanted to ignore the camera channel, you could do that as well. Now, let's say you wanted to just mark the place where you actually hit. So now we have access to the hit location. So there is a function called draw debug sphere. You can actually draw many other shapes, but sphere is the one which you'll use most often. And the center is obviously the place where you hit it. So out hit location and radius 100. Maybe we can have 10 seconds for the duration and thickness, let's just say 2 units. Line color, let's set that to maybe something like a greenish yellow or something. Now if I go ahead and press play, if I left click, you see it's drawing a sphere where it actually hit it. And you could change some of the properties. Let's say you wanted a more detailed sphere. I don't know why you would want that though. And maybe reduce the radius of the sphere. You could do that as well. So as you can see, we are registering a hit over there. So that's what it's basically showing us. So this is how you do a line trace. Basically you draw a line from one end to the other and you can detect hits. Obviously for shooting a weapon and stuff like that you use it. Now there is another way you can actually determine the start and end location. Now whatever logic you have here is fine if you only have one camera. But what if you had a first person view and a third person view, for example? Let's say you had two cameras. You cannot check which camera you're using and stuff. That would make the logic complicated. So the way you do it is you'd use a function called getPlayerCameraManager. Now this is going to get the current camera which you're using. And it's going to be an actor. So we can just type in getActorLocation. And this is going to be your camera's location. So let's say you switch between cameras. This is going to work universally regardless of which camera you're using. However, since in this logic we are using this camera's reference, let's say we had another camera, this logic is not going to work. It is going to work with respect to this camera. So instead of this, I can go ahead and replace it. And we can get the actor forward vector again. Get actor forward vector. And we can replace this by this. And we can go ahead and delete it. And the rest of the logic remains the same, obviously. And now if I were to press play, you'd see that the logic does not work. Okay, we didn't plug it in. So the actor location is going to be the start, of course, not 0. Press play and the logic works exactly the same. One more thing you'll notice is that the line trace is going exactly to the center of our screen, if you were to notice. That's one more thing. The reason it's happening like that is because we are going from the center of our viewpoint and going exactly forward to the view. So that's the reason it's actually going right at the center of the screen. And if you had a crosshair in game, it would land right at the center. So this was raycasting. There are many other options as well, such as hit actor. So you can cast it. So let's say we cast it to pickup, for example. So we can check if we actually hit a pickup. So if we actually did hit a pickup, what we can do, in fact, is we can go ahead and run some logic. Let's say we destroy it. So I'm just showing you guys one more example to make things clear. So if I press play, so that's not a pickup, so nothing happened. But if I hit a pickup, as you can see, we are destroying it. So something like a gun. All this is fine, but we do not have any sort of a user interface. Now, apart from the lighting needs to be rebuilt thing, you can actually delete that by typing in disable all screen messages. So, oops, I didn't type that. So, disable all screen messages. So, you can go ahead and type that and it's going to remove that. So, there's nothing much really. We don't even have a simple health bar. So, we can go ahead and add a couple of components on screen. So in order to create widgets on the screen, if you want user interfaces, the way you do that is using widget blueprints. So let's get to that. Inside your content folder, I want you guys to create a new folder and we can call this one UI. And inside this, we can call this one, for example, HUD to denote heads up display. Now open it up and inside this folder, right click and create a widget blueprint by heading into user interface. Now you could do it through the blueprint class menu as well. Type in widget blueprint. You should find a widget blueprint somewhere over here. So user widget is the one actually. So go ahead and select that. And we can call this one HUD BP underscore HUD. Generally, I also like to add underscore WB to represent widget blueprint. But if we are going to have separate folders for each one, it's not really required. Open it up and you will get a blank canvas and you'll have two tabs over here on the top. You have a designer and a graph as well. So what we'll be using most of the time is the designer, and to add the logic for it, we are going to use the graph. If you guys have used the Qt framework in C++, the functions and stuff work pretty similarly over here, but since this is going to be in Blueprint, it's going to be much easier to comprehend. Now, the most basic type of widget that you can add is a canvas panel. So add in a canvas panel. Before, this actually used to come by default without you having to actually add it. Now, you won't worry about most of the settings actually. The only thing that you'll worry about is custom or filled screen actually. These are the only two which you'll most probably use. Custom is basically used if you have stuff like drop down and you're making like a child widget for something. And I will show you guys examples for that when we go to the higher level part. So for now we'll use fill screen. So this is going to take up the entire screen. Now in order to actually create this, now there is nothing, but we can just create it nonetheless. Generally it's not advisable to create it in the character. Widgets usually would be created in something a little more persistent, such as a player controller. So we have one set up already. So we make sure you set that in the game mode, open it up, and we could do it on begin play. Add in a custom event, and this is where you actually use custom events. So you could use a function, no harm with that, but let's use custom events. This is what you would use them for. So we are going to be calling this one, for example, create HUD, and we can call that, so create HUD. Over here we can go ahead and type in create widget. We'll get to select it, so BP HUD is what we want to create, and we can promote this to a variable and call this one HUD, or you could call it HUDref if you really want to be that specific. Now we have a reference to the HUD. However, we still haven't actually created it. We have just internally stored it, but if you want to show it on the screen, type in add to viewport. So now this should be added to your screen. However, there is another thing which you could do actually. There is another option called add to player screen. However, this is not really used that much. So this is usually used for split screen and stuff like that. We'll not get into this. So you'll use add to viewport most of the times. Alright, so now under your HUD, for the health bar, obviously we need a progress bar. So type in progress bar, and Unreal has everything built in for us. So let's add it at the bottom left hand side of the screen. That's the reason I chose the canvas panel, so that we can easily just drag stuff in. With other types of widget, it's usually like a layout which you create, so it's going to be harder for you to just move things around. Alright, so let's add the progress bar. And on the right hand side under the details panel, we can rename it. We can call this one health bar, and we can set all sorts of parameters. Maybe we can make this one 350 by 45, and over here you'll see another tab called anchors. Now anchor is basically telling you the position with respect to it. Basically, for example, let's say set it to bottom left. In this case, bottom left is ideal. So this is going to be your 0, 0, and with respect to that, your y and your other values are going to be set. So when I say the anchor is at the bottom left and my position is 88, what I mean is I have placed this progress bar 88 units to the right of this anchor, and y is basically your vertical direction. So minus 120 is 120 units upwards basically. And size X and size Y will remain the same. Alignment is basically telling you what to take as the reference point. So if I make this 0.5, you see it's going to center off. So it's the distance between this and the center now. Same with the Y. So if I type in 0.5, it will move a little bit down or up actually, because it was over here. So now the point shifted over there, so it moved a bit up. And if you want to center something exactly at the center of the screen, so for example a crosshair, so you would set the anchor to be this, the center one. And over here you'll change the alignment to 0.5 and set the position to 0 and 0. Now this is going to be perfectly centered regardless of your resolution. Now another reason to actually use this, so let me just actually move this back, so 0, 0. Another reason to use anchors is for different resolutions. Let's say you had an 800 by 600 screen. Let's say somebody is playing with that and you had a progress bar over here. Let's say you left it at the default anchor. Let's say you didn't actually modify the anchors. This widget is actually going to go outside the player screen. However, if you change the anchor to the bottom right, now this widget is minus 461 and minus 137 relative to the bottom right corner. So then it will always be inside the screen. So that's another reason to use anchor. So I'll go ahead and undo all of that. So that should be good. Now if I go ahead and create this, so in our player controller, on begin play we are actually creating it. Now if I go ahead and press play, you see we see our progress bar. And since we have our anchor over here, you see it always stays at the same relative position on the screen. The next thing that you obviously want to do is actually bring in the values of health from the character to the actual widget. So it's actually pretty simple to do that. So let's go step by step. There are quite a few ways in which you can do it. So if we would have created the widget on the character, it would have been simple to just pass in the health value to the widget. However, since we have done it in the player controller, there is an extra step, but nothing to be worried about. So now let's create an event in the player controller so that we can actually interact with the widget. So we can call this one update health, for example. So type in custom event and call this one update health. And for the new value, we can go ahead and add in an input, and it's going to be of type float, obviously. And we'll call this one new health. Now over here in the progress bar, we can go ahead and create another event, or we could even directly adjust it here. So we could get the HUD, and over here we could type in, first of all, let's check if our progress bar is a variable. Make sure it's set to is variable, otherwise you won't be able to access it. So if once that is variable, get the health bar. And again, this is where your blueprint menu is going to help you a lot. Now you want to set the percentage. So type in set %. You will go ahead and get this node. Now in case you guys don't know, this % is going to be a value between 0 and 1, and our health is a value between 0 and 100. So let's just divide this by 100. So do that, or you could make your health variable store 0 to 1, that works too. Alright, so you can do that, or you could have a custom event inside your BP HUD, that works too. So let's head back into a character now. And what we can do is we can actually do something. So let's say when we actually pick something up, let's say we reduce our health, for example. So we can head into our interaction. So when we pick it up, let's say we reduce our health by 10 maybe. Now if it is valid, we destroy it and we invalidate the nearby pickup. And let's reduce our health by 10. So create a health variable first of all. Now health is a variable which is dependent on which character you're in. So that's why we are creating it in the character. Make this private over here. Make this variable private. And we can go ahead and set the health to be equal to, we can go ahead and set the health to be equal to health minus 10. And we don't want it to actually go below 0, so we can go ahead and clamp the value. So we can call this one clamp. So clamp float. Minimum is 0, maximum is 100, obviously. So you can go ahead and set it. Now if our health is 0, so if our health is less than or equal to 0, if you don't clamp it, you can check for less than or equal to. So let's do that actually. So if our health is less than or equal to 0, less than or equal to 0, we can go ahead and just kill our player. So instead of killing it, let's just exit the game instead. So we can execute a console command. So type in execute console command, and this one we'll simply type in exit. It's going to exit the game. Even quit works. Now this is something which you might need multiple times. So what we can do instead of this is we can actually make a set health function, because we want to exit the game even if our health is reduced for some other reason. So here in this case we picked it up so our health reduced, but we want to be able to reuse this. So right click, collapse this to a function and call this one set health. Now let's say you don't want this to be able to called on the other blueprints. So let's say you want to only be able to call it in this BP character. You can make it a macro instead. And obviously we need the health value. So grab in health and head back into your event graph, pick up. Over here we can go ahead and pass in the health. So this is going to handle everything for us. And let's actually make this a larger value. Let's say 40. So on our third pickup, in theory we should exit our game. And if it is not less than or equal to 0, we can go ahead and update the progress bar first things first. And remember we had our player controller reference. Now we can go ahead and use that. So regardless of what we do, we want to update the health bar. I mean, we'll exit over here, so we don't need to update it. So we can type in update health. And new health is going to be our health variable. Now, some people might show you how to do this using a binding. So you can actually go into your progress bar and you can type in bind and create a binding. However, this is very inefficient and it is going to run on tick. So actually don't really bother using that. Do it the way I am showing you guys. This is the proper way to do it. However, there is a small chance that it might miss. It might not update. But that's nothing to worry about. It's going to be like 1 in a million maybe. So it honestly doesn't matter. So once that's said, we should be good to go. And make sure by default your health is set to 100. And once just update the progress bar once you set the player controller reference, because we are not actually setting the health by default. In the HUD you could set it. However, what if a player disconnected from a match and is coming back? So you don't want it to be 100 because you'll be creating the widget once again, right? So set it once you get the player controller. So in our initialize function, once we get the player controller reference, we can go ahead and set that. And we'll clear the timer at the last. Order doesn't matter here since this function is already being executed. The order honestly doesn't matter, but we can do it like this. Now if I go ahead and press play, you'd see our health is set to 100. And if I go closer, okay, let me just speed that up a bit. So if I interact with this, nothing happens. But if I go ahead and interact with this, our health reduces. My health reduced. And now we exit the game the third time we do that. So this is basically how you work with widgets. So if you want to update it, you would just use one of the functions which are there in one of these widgets. And what if you wanted text? Obviously, you would just search accordingly. Type in text and you should be able to find text. So let's actually type in the actual health value. So over here, what we can do is we can just give 100 by default, or we could leave it a text block and set it normally. So over here, get back into your player controller and in your update health function, we can go ahead and grab our text. I don't know if it's set variable. So it is not set to be variable. So we can type this one health text. Now you should be able to access health text from the player controller once you set that to is variable. So grab in our HUD, health text. So get your health text. And over here we can go ahead and set the text to be equal to the health value itself. Now there is a special node which you'll use a lot called format text. So this is very simple actually. Use curly braces and type in health. It will make a pin for you. Whatever you type in curly braces will be a pin. And the first one, let's just put a plus over there, because it's usually health is denoted with a plus before. So your text is basically going to be plus along with a health, appended with your health. So let me just show that actually. So grab in your new health. You can grab in any sort of pin, by the way. Now if I go ahead and press play, you see it says plus 100 because it took plus and the actual health value itself. Now I apologize, I do realize that the screen is a little bit black and white. So now it should be fine. So you have plus and you have your health. Similarly, you could do something like maybe hyphens. So it's just going to append it as is. You can go ahead and mess around with it a little bit. Let's say you wanted another parameter. You could put curly braces once again and type this one maybe something. And over here, you can go ahead and make a literal string or a text. So let's just say hi, for example. So it's going to print plus 100 space hi. If I put a hyphen here, it's going to take it as is. So plus 100 hyphen hi. So stuff like that which you can do using this format text node, and it's really handy in my opinion. So now if I go ahead and press play, we have our health bar. Now we could do a little more of designing. So head back into your HUD and you can actually wrap this around with a border. If you right click and type in wrap with, you can wrap it with a border and actually have a border color and stuff. So I can select this and make sure you set your padding to whatever you want. Padding is basically the spacing you give. So if I change the padding in this case, so if I change this to 10, you'd see that you're giving more space on all directions. I'll just set it to something like 5 maybe. And I'll make this one black. So not content color, that's going to be a progress bar color. Instead go to brush color and change that to something dark maybe. And over here as well, let's just change the fill color to green because that's more appropriate for your health widget. So change that to something a bit more greener. Now if I go ahead and press play, you'd be able to see we get the appropriate color and our health bar updates as normal and our text updates as well. So that's basically it. So that's the basics of widget blueprints. We will talk a lot more in depth about this as we move further. But now you guys should have a pretty basic idea on how to create stuff. Now the palette is something which I want you guys to explore. So checkbox is a checkbox and you won't use most of these. Most often you'll use text, slider, button, image, border, and image is, as it says, it's an image. And one more which you might use if you want something like a username password menu is a text box. So you can grab in a text box and this will allow the user to enter any text inside. Stuff like that. Now I want to cover widgets in a little more detail. So let's actually create another level called main menu and let's actually transition to this level using a widget. So like you'd click the play button in your widget and then you would enter this level. Let's do that now. First we can go ahead and create our map. So head into content, maps, right click, create a new level and we can call this one main menu. Open it up, or rather let's just be a little more descriptive, call this one main menu level. Open it up and this should be blank and that's really none of our concern. Head into UI, create a new folder and we'll call this one main menu. Over here, go to user interface, widget blueprint and go ahead and select user widget. Now we can start making our main menu. So we can call this one BP underscore main menu. Open the widget and we can just have a canvas panel again. Add in a button. We can center it first of all. So make it 0.5 and 0.5 and set the positions to be 0. We can increase the size a little bit. Maybe we could make that something like 350 by 100 maybe 450. Again, size is your personal preference. And we can make the background black. So background color, change that to something darker. Maybe something like a dark gray. we can go in and add in some text, and we can call this one play. Now, you can change the font as well, by the way. Under font, you can actually import your own custom fonts. We'll not get into that, but it's actually pretty simple to do it. We'll try to get into that in the later part of the course, but I'm not really sure if I will. So maybe change that to regular, increase the font size to 35, let's say. This should be good. Now head into your event graph and let's call this one play button. So select the button and then under the details panel rename that. Now if you select the play button variable, you should get a bunch of events including on clicked, on pressed, on released. All of these are as they stand, obviously. Maybe if you have a sound effect or something, you could play it on hovered. Or there's another way actually where you can play a sound effect when you hover your mouse. So over here, if I just type in hover, I should be able to find hovered sound. Let's just play, so maybe let's just play this. I mean, it doesn't make any sense, but anyways. And I think there is a clicked sound or a press sound, I guess it's called. So we can play a press sound. So click on button. And what we can do is on clicked, we can go ahead and open our map. So we can type in open level and we can do by object reference. So over here, let's just select our level, beginner course level, and that should be good. Now if I go ahead and press play, as you see nothing happens because we haven't created the widget yet. Now since this is a widget which is the only thing in this level, you could simply go ahead and create the widget here on begin play. So create widget, BP main menu, add to viewport. We don't really need to store it because we are not actually calling any functions. So if I press play, you can see it, and when we hover over it, you see you get the sound effect. However, one thing you would notice is if you actually have your focus on the window, you can't see your mouse cursor. So the way you do that is, first of all, get your player controller. So type in get player controller. This is a static function. So inside any actor, basically, you can get your player controller reference. And from here, there's actually a variable called set show mouse cursor. So show mouse cursor is the variable. Set that to true. And another thing which you can do actually is change the input mode to UI only, so that it only focuses on this widget. There is another option called game and UI only. We'll use that. Set input mode to game and UI only. Grab in the player controller reference. And that should be good. So we can just reroute it. Double click on the pin to reroute it. And now if I go ahead and press play, you see even when I focus it, I can still see my mouse cursor. Now if I press play, you see we transition to the level. Now we obviously spawned at 0, 0, 0, so that's the reason that happened. Now if you want to fix that, you can go ahead and add in a player start where your default player will spawn. So now if I head back into the main menu, play it. If I head in, we will spawn where our player start was. But one thing you'll notice is we still haven't actually got rid of the mouse focusing part. So your mouse isn't behaving like how it should. So what we can do is on begin play. Now we are in our main menu level. Head into our beginner course level. Generally you do it on your player controller. So BP player controller. And what you can do is you can set input mode game only, and we can get a reference to self, and you can also set show mouse cursor to false. So set show mouse cursor, make that false. Now if I go ahead and press play, okay, I mean that wasn't what I intended. Now head back into your main menu, go ahead and press play. Now you see your mouse is going to behave normally. So that's basically how you deal with it. Now you can do your normal gameplay stuff. So that's how you would actually interact with your actual levels and stuff. You would transition levels and stuff using widget blueprints. So head back into UI, main menu, and if we take a look at our code, it's really simple. And our widget as well, it's really simple. So that's about it. Now let's say we wanted to have more than one option, and let's say we wanted to lay them vertically. So if you want to add multiple rows, you can go ahead and use something known as a vertical box. So if I right click on this, type in wrap with and use a vertical box, you can go ahead and get this. Now the vertical box will automatically use the same anchor as we used for the child, but nonetheless, it's just something which you can change. Change the size Y to something big maybe, and press Ctrl D to duplicate this button. Now over here I can type in exit, let's say, and again on clicked we can change that. So play button 1 is not appropriate, we'll change that to exit button. So exit button, and on clicked we can go ahead and execute console command, and we can type in exit. So that should be good to go, and you'll notice one thing, it's just taking up a fixed amount of space and it's not actually filling it properly. So if you want to do that, you can select both of these and select fill. Now let's say you wanted your play button to occupy more amount of space than exit. So you can increase this text box which is available to you. So if I hit 2 and the exit button has 1 on this option, basically they are occupying space in the ratio 2:1. That's basically what it means. So you don't want your players to exit obviously, so you'd make the play button bigger. So this is how you do it. Now if I press play, now the same logic is copied over. The reason why the sound is playing even for the exit button is because we copied over the code. So that's why. So all the sound effects as well is copied. So as you can see, press sound and hover sound are actually the same in both of these. Now if I press play, if I press exit, we are going to quit the game. If I press play, we load into this level. So that's pretty cool. So that's about it for this part. Now it's time we start talking about another feature which Blueprint offers. That is Blueprint function libraries. Now let's say you wanted to have some functions which might be used in multiple places but are not relative to a certain object. So in that case you would use a Blueprint function library. So let me actually show you guys an example. So head into blueprints, and or maybe we could create another folder. Let's call this one function libraries. Open it up, and over here right click, head into blueprints and select blueprint function library, and we can call this one my or our blueprint function library. Now inside here you would notice that we actually have functions, options to write functions. So for example, let's say we have something generic. So for example, let's say we have a vector, and let's say we wanted to normalize it. Now obviously there is a normalize function already, but I'm just taking an example. Now normalizing a vector is a general operation. It's not relative to any object. So we can type in normalize. And for the input, obviously we are going to take in a vector. So take in a vector, and we can type this one in maybe. And now once we have the vector, we are going to first of all get the magnitude of this vector. The way you get magnitude of a vector in Blueprint is by typing in vector length. So get vector length. Now this is the magnitude of the vector. So we can divide this vector by the magnitude. So that is going to normalize the vector for us. And once we actually do that, we can go ahead and return it. So this is going to be the return value, and obviously we'll make it a pure function. Now let's just call this one normalize underscore hours, because I think there is another function called normalize, so just so that it's understandable for us. Now head back into any one of your blueprints, let's say our level blueprint, And over here, if we just type in normalize, so we already had a normalize function, but I just took the example, underscore ours, you see we actually get our function, and this is not relative to any object, so you can call this pretty much everywhere you wish. So this is basically your Blueprint function library. You just go on creating functions. So once that's all settled, now what if you wanted to use some code or some assets created by somebody else? There is actually a huge marketplace called the Unreal Marketplace, and you can access it through the Epic Games launcher. So if I head into my Epic Games launcher, head into Marketplace under the Unreal Engine section, you would see that you get a massive library of assets, and there are a bunch of free ones as well. Like I really mean a lot of free assets. So what if you wanted to use them? So that is where using plugins and other content packs comes in handy. So how you do it is really simple actually. So for example, I know one which is very handy. It's called low entry, I believe. Oops, low entry. So I actually have it in my library. So it's by this publisher actually. So low entry standard library. This is the one which I'm using. This is really useful. So once you search it up, and you can look it up in the marketplace, and there are many forums on Reddit and stuff talking about which plugins are good and stuff. So you can go ahead and install it according to your needs. So let's say I wanted some weapon models for prototyping. You could just type in weapon and you're going to get weapon packs. The way you install it is by clicking on this install to engine button. I've already done that, so that's why it shows that I can't. Now over here in my plugins panel, now I should be able to access it over here under installed, or if you just search it up, you would be able to find it and you can enable it. So low entry extended standard library, and I need to restart the editor. So let me go ahead and do that. Now that it's done, I can go ahead and use the content in the plugin. Now, how do I know what content is there? There will actually be a documentation and source code and stuff available. So you could just look it up. So there will be a place where the documentation is given. So you have a preview over here. Then you also have access to the source code and a bunch of stuff. You could also take a look at this over here. So maybe let's say we wanted to use some function here. So for example, I type in is debug build. Let's say I wanted to see if I am currently in a debug build. So I can type in is debug build, debug build, and as you can see, I can use the function. Now this was a plugin which has to be installed to the engine. However, we will also look at other types of plugins, such as, let's say I type in weapon, for example, I needed a weapon pack. So I actually have some in the library. You could find a free one, so you can head under free and you can look for it. But again, now in my library, I actually have some weapon packs. If I want to install those, it's actually really simple. So FPS weapons bundle, this is one thing which I have. So I can go ahead and add this to a project. And it does say none of my projects are compatible, but plugins like these, actually it doesn't really matter if you're using a later version than what is supported. As long as you're using a later version than that, it should be totally good to go. So click on show all projects and you can go ahead and select this, and you can change the version to the latest available one, and you can go ahead and add it. Now just another thing, in case you don't have a plugin of this sort, so the one which we saw last time. So let's search for low entry once again. So let's say we have a plugin of this sort which you install to the engine, but you actually don't have the appropriate version. So the way you'd actually go about upgrading your version is actually really simple. People haven't made any tutorials on this. I don't see any forum or anything talking about that either. So basically you just come into your Unreal Engine installation directory. So I go to program files, Unreal Engine, this is where I have it. And over here under engine, plugins, and the marketplace ones will be in the marketplace. And for example, I go to low entry extended standard library. I can right click on this U plugin file and I can actually open it with any text editor, or I can open it with something like VS Code. So I'll open it with Visual Studio. Inside the U plugin file, you should see something a little like this. So you don't have to worry about any of these things. The only thing is the engine version. Let's say it was there for 4.27 and you're using 5. And if you want to make it compatible and let's say you're getting build errors, you could just go ahead and change 4.27 to 5.0.0. So let's say it was 4.27.0 by default. So you can go ahead and change it to 5.0.0. Whoops, 5.0.0. So stuff like that. Alright, so that's about it. There isn't really that much depth to plugins. I mean, I will talk about creating plugins and stuff, integrating third-party libraries a bit later on in the advanced part of this course. But now let's go ahead and actually talk about a recently released tool, and which is quite handy in my opinion, and those are the modeling tools. First of all, in your plugins section, make sure your plugin is enabled. So make sure modeling tools editor mode plugin is enabled. And if you don't want to separately drag your model in the level and edit it, then you can press this as well. And now if you check your content browser, make sure you have some sort of a 3D model. Make sure you have some sort of a static mesh. So you can import that from your 3D software. So I just got one in from the engine content. So what I did was basically, actually I'll just go ahead and delete that and redo it. So delete that. And delete this folder as well. Save everything. Now I just search for SM underscore. Usually it's a convention to name it SM underscore for static mesh. Under content, I just went ahead and created a new folder. So new folder, and I called it models. Open it up and just paste it in. Just using the one from the engine content. Now you can drag it in the level and start editing it by heading into this tab right here and heading into modeling. So we have a bunch of options. The first few are for creating objects, but some of the useful ones are, for example, moving the pivot. So let's say you didn't want this to rotate along the center. You can go ahead and type pivot and you can move this point over here. Now if I rotate it, it's going to rotate along this point. And these changes are actually applied to this. So even if I just drag in another ball, these changes will be applied to that. So just be careful while using them. Of course, you can undo them at any point. So just save that. And sculpt is basically to deform the shape. So something like this. And again, you can use shift. The same principle works over here as well as we did with the landscape editing. So stuff like that. Then desculpt does a similar thing. Just works a little bit differently. So I can just drag it like this. I'm not sure what I did there, but yeah. So I'm not really here to talk about the tools in detail, but just to give you an overview of how to actually use it. So you could experiment around with all of these. So if you type in accept, so now we have this shape. Obviously it just messed up with the UV map and the materials and stuff. But anyways, that was not our point. Now a couple of useful things. First of all, creating shapes. So if I just type in stair over here, and if I head into this and I can actually make it a curved staircase, I can actually increase the number of stairs. I can decrease the step height. So I can increase the curve angle, for example. Then I can decrease the step height. So I can make it something like 10. Maybe place that and type in complete. Now if I go ahead and press play, you would be able to see that I can actually use my stairs. So that works well. So stuff like that. And now shapes are pretty obvious. Obviously, just create a box, do stuff with that. And now you might be wondering where these are stored. Over here, just check what is selected under this, under the new asset location. If it is selected to global, in your content folder, there should be a underscore generated folder. In my case, it was set to world relative. So wherever you have your map, over here, you should see a underscore generated folder. And if you open it up, you should be able to see your static meshes. So for example, we have this stair which we just created, and we can drag this in. So this is going to come in really handy for many people, in my opinion. Now, not only that, it provides us with several other cool features. I'll just showcase one of them actually. So if you head into your modeling tools once again, so I'll just close it and open it up again. So I'll open up the modeling tools, and if I type in poly extrude, you can actually draw a shape. So if I just click somewhere, drag a point, do something like this, and if I join them, now I would be able to create something like this. So let's say I wanted to create a castle wall or something, you could do that. And the good part about this is UV mapped by default. You don't have to actually UV map it. The UVs are pretty good. So you can directly go ahead and apply a texture and it is going to look decent. Generally, if you create a weird shape like this in a 3D modeling software, you separately have to go through the effort of UV mapping it so that the textures don't look distorted. But in this case, you are good to go. So that's about it for the modeling tools. So you can mess around with those. These are really, specific to what you're doing. So according to what you would need, you would use the appropriate tools, but it is there. Now, even over here, you can change the pivot point, let's say, for example. So I'll just show you guys once again. So modeling, if I select pivot, and if I move this over and press accept, you would see that the pivot point moved over there. So that's about it. So let's move on to the next part. So what I'm going to be talking about next is kind of the basics of what we did till now. So basically we worked with these models over here. Basically these are called static meshes. So any and all 3D models which you get in the engine without any sort of animations or anything, those will generally be static meshes. Any mesh with some sort of animation is going to be a skeletal mesh basically. So stuff like characters, gun models, and those are going to be your skeletal meshes. Anything which simulate physics or which does not have animations. So for example, this staircase, maybe a weapon model in a pickup blueprint, stuff like that are going to be static meshes. So they are recognized by a light blue color in the content browser. So if I head into models, you see it has a light blue color coding, and this indicates that it's a static mesh. Now we will dive into skeletal meshes a little more in depth later on. But for now, I'll just head into static meshes. There are a couple of things which I would like to cover. First one is enabling Nanite. Now, if I head into wireframe mode, so now I can actually see all of the vertices in space. Now, say I have many of those spheres, and in this case, I have more than 6,000, so 6,480. So your first question over here is, how's the performance still this great? That is thanks to Nanite. So if you right click on your model and enable Nanite over here, if you right click and click on enable, you will enable Nanite. Now if I go ahead and disable this, you would see that the performance dips immediately. So that's one thing about Nanite. So as you can see, it's really not playable at this point. Now, obviously this is highly unrealistic, and moreover it will depend more on your computer as well. So if I go ahead and enable Nanite now, and if I press play, as you can see, even with so many spheres right in front of me, it's absolutely not affecting performance. Now we are not here to talk about the actual technology involved in Nanite, so that's the reason I'm not telling anything else. But this is basically it. Currently in 5.0.3 there are a few limitations. For example, let's say you wanted to use this on a tree, you probably cannot, because trees contain leaves and leaves used masked materials, and those are not yet supported on Nanite, but they will be supported in 5.1. So very soon you would be able to use them. So that's about it. There are a few material features which you can't use, and we will talk about materials. So stuff like dithering and stuff, you'll have to just disable those nodes if you want to use Nanite. But for most objects, so stuff like walls, or maybe if you have an insane level, something like this, Nanite is going to come in handy. So that's about Nanite. By now, one thing that you would have probably noticed is that any and all objects in the scene actually have some sort of a material on them. So for example, this has some neon blue texture on it and it seems to be glowing, and this box right here has some sort of checkerboard, and same with the ground. So what's up with that? So basically those are materials, and that's what gives the color and all the other roughness related properties of a given surface. Now let's actually go about seeing how to create a material and apply it on objects. So let's just use a cube for example in order to demonstrate using materials. So let me just grab in a cube and I'll just place it in the scene. Now this has a material, basic shape material. You can actually explore this by clicking on this search icon over here. So you'll actually go to the directory where the material is stored. But in our case, let's create a new folder called materials. And let's go ahead and open it up. Right click and create a new material, or you can head into materials and create a new material here. Now the most important ones are just materials and material instances. The rest are just stuff which you might need in specific circumstances. So we'll take a look at material and let's call this one our material. Now applying a material on a surface is actually really simple. Now we aren't going to be dealing with multiple materials on a single object in this part of the course. We will try to deal with it later on, but for now we won't be doing anything. So by default you get this checker material, so I'll just drag this in, and you can, in order to apply it, you just drag it basically on the surface. That's how you do it. Or if you want to apply it to a static mesh in general, so let's say I wanted all of the okay, whatever this object is, so let's say I wanted all of this object to have our material. So what I do is I'd head into the static mesh, and over here I'm going to select our material. So let me go back. So all content materials, our material, you can select that and you can click on this arrow icon which will use our material. So now it's actually using our material. So we haven't seen any change because we don't have anything set up in the material. But the way you actually start working with this is by using these nodes. So this pin right here is, as the name suggests, the base color. Now how do you define a base color? So the most basic node over here is going to be a constant. So whoops, I press C on the keyboard. I'm supposed to press 1 on the keyboard and left click. And you see you get this node here which allows you to enter a value. Now generally you would enter a value between 0 and 1, but in some cases you would enter higher and lower values. So in this case, if I just plug this in the base color, and you can see it's compatible, so you'd see that our material is fully black. Now it's just a fully black material. What if I increase this a bit? Now save that again. As you can see, it became a lighter shade of gray. So 1 is going to be white. So this is basically a gradient. 0 is black and 1 is white. What if you wanted to give a color? So you'd hold 3 on your keyboard and left click. Then you'd get something known as a constant 3 vector. This is basically your R, G and B values. So red, green and blue. So you can go ahead, if you wanted red, you could do 1 on red. And as you can see, you get a red color material and it's applied to all the objects which are using our material. So that's about it for base color. Now if you want to bring in any textures, I recommend this website called CC0 Textures. So open it up. Now it's renamed to Ambient CG. Keep forgetting about that. So if you just head in and you can just grab in any texture. So I'll just grab in the lowest resolution one. So I can open it up in my folder over there. And over here I'll just drag it into images for now. I just have it set up like this. So I'm just going to extract it. And over here you see you get a bunch of textures. If you want to import it in the engine, it's really simple actually to import any asset, be it textures, models or whatever. So we'll create a new folder and we'll import it. So textures, open it up, and if I go ahead and drag this, for example, so I can just select all of these and I can go ahead and drag this in my content browser, and we can go ahead and save it. Now if I want to apply this texture to this material, now first of all we'll see which one is the base color. Sometimes these textures are labeled as albedo, but albedo is basically a base color without any sort of shadow related information. That's basically what it means, without any other sort of detailing. It's just the raw color. So if I drag this in the base color, I can do that. Now you could do this as well, totally fine. So this is how you bring in a texture. Now if I go ahead and look into my level, you see we have this wood texture on our little wall here. Now what if I wanted to tile this texture a little better? Now let's say I wanted to make this bigger or smaller. You'd use something known as a texture coordinate. So you type in text coord and you're gonna see texture coordinate. Plug that into the UVs. And now let's say I press 0.1, your texture will now be scaled 10 times. U and V are basically like your X and Y, to be very vague. Now we zoomed in way too much, so let's make 2 now. So now you see it's going to be more tiled. So now if you would see, you would have a more tiled material. So if I make this 3 for example, and if I go ahead and save this, you'd see that it'll be even more tiled. So I can make this 3.5, I can increase the value and it's going to be more tiled. So I can click apply, save, and I should be able to see there are more number of bricks. Now I'll just set this to 1 once again and save that, and as you can see it's applied to our level. Now this may be fine, but what if you wanted more details? Let's say you wanted to make this very glossy. So in that case you can use the roughness node. Now the roughness is basically a 0 to 1 value, so you can again use a constant if you want. So 0 is going to be fully reflective. Now you could use the specular channel as well, but most of the times you'll only use roughness. It's very rare that you will actually mess with the specular channel. So now if I go ahead and apply this, you'd see that it's very glossy. And if that's not really that clear, drag in a point light, just move this, and as you can see it's reflecting everything over there. You see the little point over there, so that's showing roughness 0. Now if I change this to 1 for example, and if I hit save, you'd see that it's not reflecting the light at all. So that's the use of the roughness channel. Now obviously this is some sort of a wood floor texture, so obviously it will be depending on the grains of what's there over there. So how you would set it up is by using a roughness map. Now generally in websites such as CC0 or ambient CG now as it's called, you would get something known as a roughness map. Basically the brighter parts of the image are where the light is reflected more. The darker parts of the image are where light is not reflected. So let's say there is a fully black area here, so that's where all the light is going to be reflected. So I might have told it the other way around. Basically the more bright the color, the more the roughness. Now if I drag this in, use this in the roughness channel, as you can see this gives us a little more definition. Now as you can see at the borders over there, you can clearly see that the roughness map is doing something. So this is about roughness. Similarly, normal is basically your depth. So as you can see, this texture, although it has a bit of roughness, it looks completely flat. Now if I go ahead and add in the normal map, so if I just snap this to the left and bring in my Unreal editor on the right, And if I go ahead and apply my normal map here, and if I hit apply, as you can see, you'd see a little bit of a depth over there. Now, if you can't really see it, that's probably because this is pretty subtle. So you can use something known as a multiply. Basically, it's just going to multiply the value of each pixel in this texture. So multiply this, you can use a constant, or you can set the value over here itself in the multiply node. So if I type in 100, let's say, for example, so now you would be able to see a little bit of the depth over there. But since this sort of a texture isn't really containing much of depth, so you won't really see it. There are other ways to increase the depth of a normal map, but that's not the point of this tutorial. So basically, normal map is for your depth. If you're into PBR rendering, you'll probably already know all this stuff. Ambient occlusion is basically like your depth in your crevices and stuff. It's kind of hard to explain it. There's actually a comment here. So simulate the self-shadowing that happens within crevices of a surface. Basically, that's what ambient occlusion is. So in stuff like trees and rocks, ambient occlusion is something which would play a major role. In this sort of a texture, it's really not going to do much. So this is about the basics of materials. Now, obviously, this is completely wrong because we only have a texture coordinate for that one texture. So make sure you plug everything in. So just plug everything in. Now if you go ahead and apply and save that, now you'd be able to see that it's applied properly. This had a subtle effect from the start itself. So that's the reason you couldn't really see anything wrong with it. So we created a basic material here. Now for any of these, you can actually use your constants, but most of the time, except base color, you won't be using constants. You'll be using textures. Now that's the very basics of materials. There are a lot you can do. Let's say you wanted to make this thing glow. So let me just remove all of this stuff. Let's say I just wanted a glowing neon green color. So let me just get a constant pre-vector. So the same right click search menu exists in the material editor as well. Drag that in the base color. And what you want to do is first you can grab in a constant and maybe let's say you have 10. This has to be a value greater than 1. So let's say I have 2 for example. So now you'd see that it's completely glowing white in color. Now if you wanted it to glow in this color itself, what you'd do is you'd actually get this and you'd multiply this by 2. So you'd multiply this by 2. Now if I go ahead and press save, you see it's glowing in a sort of green color. So this is basically called an emissive material because it emits light and it's pretty cool to look at. By adjusting the value you multiply it with, you adjust the intensity. Now, one problem which you might have noticed here is every time we want to change a value. So, for example, we want to make this less bright, let's say 1.5. Now, every time we have to apply and save this. What if we could dynamically change this? That's where material instances come in. It's basically like your derived class in your C++ inheritance. But to put that in short, basically you create another asset known as a material instance, which is subordinate to this material, and you can edit all the parameters in it. So I can right click on our material and create the material instance, and let's just keep it as the engine has suggested. Now instead of applying our material, we'll apply our material instance. Nothing has changed obviously. However, if I head into our material instance, now I can change the parameters over here. The first thing you might notice is there is nothing to change. So how do you do that? Basically, you'd have to head in here, right click and convert it to a parameter. So any constant or any texture which you convert to a parameter will be a value which you can change. So this is going to be called brightness, let's say. Brightness. and this one is going to be called color. So right click, convert to parameter, and call this one color. Now apply and save it. Now if I open up my instance, you'd see that you get two parameters, and now I can edit them. So now if I press 2, you see the changes are live. So 0 works, 1, 2, 0.3. So I can adjust my values just like this, and I can change the color as well, and it's updating dynamically. So for the most part, you'll be using material instances for this purpose itself. So these were the basics of materials. Now you could tinker around a bit, look into the documentation, and create something yourself. Now we haven't talked too much about the other type of mesh, that is the skeletal mesh. So let's talk about that now. Now if I go ahead and press play, actually, you'd see that we have a character over here which is moving around. Now the animations aren't actually complete. If you were to notice, he's just sliding around. He's not actually doing anything. Now how do you define the logic where, you know, if you're moving above a certain speed, maybe let's say you start moving, you want to play an animation. How do you define that? So that is where you use an animation blueprint. And that is what I was searching at the start of this course when we actually did the character. So head into your character. Over here, one thing that you would notice is if I just head into mesh, and if I just click on the search icon on the animation blueprint, it actually takes us to a folder inside the engine directory where there is an animation blueprint which actually does something over here. So this is how the animations are actually controlled, and we'll create one from scratch. We can reuse these animations, no problem. So head into your content folder, not the engine, so content, and for now we can just head into our models folder, and over here let's assume we had our character here, so let's call that tutorial character, because I guess that's what it was called, tutorial TPP, I guess. I'll just open it up, right click, create under animation, create an animation blueprint, and select the skeleton. Now I'm assuming you have a little bit of knowledge of what's a skeleton, what are bones and stuff. So at least that much would be required if you want to understand this. Basically, know that each joint which you have, each point which can hinge basically is going to be your bone. So if I'm not clear about that, if I head into the actual skeletal mesh, so if I head into this one, so I'm not sure what it's called, and this one let's leave it at new anim BP. So let's TPP, I guess. So this is the skeletal mesh. Now if I were to just click on this, and if I head into the skeleton view, you'd see, for example, this is going to be your index. So if I rotate it, you can see that we can actually control it. Index 2 is going to be the further part of the finger, stuff like that. I'm not actually applying these changes, so that's totally okay. And for example, if I take the pelvis, I can go ahead and rotate the entire thing because that's the root, that's the reason it's happening. If I take spine, it's gonna rotate the back, stuff like that. Let's say you wanted to rotate it a little something like this, so you could make him bend forward, stuff like that. So this is a skeletal mesh, and output pose over here in the anim graph, as soon as you open the animation blueprint, this is what determines what pose you're in. By default, it'll just take a T pose or whatever pose it was in when you imported the model. So let's apply our animation blueprint to our character. So head into your character, select the mesh, and for the animation blueprint, let's select new anim BP or whatever that was called. So new anim blueprint. So as you can see, we are stuck in a T pose right now. And let's start applying animations. Now, in order to add an animation, the most basic way you could do it is you can simply drag in this animation and you can play it. So this is going to be the idle animation. And these are animations which the engine has provided. So I haven't really done anything here. So If you have your own character, you would have your own animations. But as you can see, there is really no logic that you can define over here. So the way you do that is by, first of all, we can start by creating a state machine. This is the most basic thing you can do in an Anim blueprint. So basically you can use your variables over here to determine logic on how to change between animations. Let me show you with an example. So we'll just leave it at new state machine for now, or we can call this one walk run, maybe idle walk run, let's say. Just name it appropriately. And now if I compile, I'll be in a T-pose again. Now entry is where you'd start. So obviously if nothing's really happening, you'd want to idle. So head into tutorial idle. If you were to notice, it just outputs the animation pose. This is something like your return node basically. Head back into your idle walk run state machine. Now if I compile, as you would see, it's playing the idle animation, and if I press play, actually this is going to work. Now we want another state, so right click, add state, and this one is going to be called walk/run. Now this is a shortcut way to do it, like I'm not doing a separate walk and run phase. I will do a separate walk and run state after I do this. So we want to be able to transition from idle to walk run, so drag in an arrow, and when we stop, we actually want to be able to go back as well, and I will show you what I mean by that. Now if I head into walk run, and if I drag this animation, you would see that he's not actually heading into walk run. So what you can do is you can just set this to true, for example, and you would see that he will be in this walk run state. So what this basically is if this boolean is true, the character will be able to transition from this animation to this basically. So how do you do that? We can actually set up some logic here. So we can say is moving, for example. This is not how you do it. I'm just showing you guys the basics. So if he is moving, we want to transition to the run phase. So idle walk run, we have that. Now in the event graph, we'll actually set up the logic to get is moving, because remember we only have the variable, but we're not actually setting the value. So every time the animation updates, so that's going to be every frame, what we can do is we can try get pawn owner. Basically that's going to be our character reference, and we can cast it to our I don't know what it was called, BP character, I guess. Cast it to that. Don't do a cast on update actually. You can actually do it on, I guess it's called start. There's an equivalent of begin play actually. Event blueprint begin play. So on this node you can actually cast it, and you can store a reference and use that. Don't cast to it every frame, it's not efficient. So you can promote that to a variable and call this one character reference. So character reference, and once we have that stored, what we can do is we can use that if this is valid, of course. So convert to validated get. If our character reference is valid, what we'll do is we will get the speed. So how you get the speed is by getting the velocity. So velocity, get velocity, and we are going to get the vector length. And if this vector length is greater than 0, it means we are moving. So now if I compile, you see he's idle. But now if I press play, if I start moving, you see the animation triggers. But now he's not going back. And that is where the transition comes in. We have set up the logic to go from idle to walk run, but the engine doesn't know when to come back. So a very simple thing you can do is put this back. And if he is not moving, so you can type in an exclamation. So if he is not moving, then we can go ahead and transition back. Now if I press play, as you can see, it's working just fine. Now there are only two animations here, but what if you wanted to blend between them? What if you wanted a walk phase, let's say? So the way you do it is by using a blend space. So what a blend space is basically transitioning between two animations. And I'll just show that. I'm not really going to talk too much in depth about animations and stuff. But I guess you guys kind of get the basic idea. Let's say you had like a jumping animation. So what you'd do is you'd have another boolean for the jump state. And in this state machine here, you'd create a new state and call this one jumping. And then you'd transition from this and you would go back, stuff like that. That's basically how you do it. And now if we wanted to set up our blend space, as I told you guys, so head into your models, tutorial TPP, and let's just right click animation and let's create a blend space. So now we can select a skeleton and we'll call this one walk run, for example. So walk run. If you have a separate walking animation, you can inject it in, but for now we won't. Now in the axis settings here, this is what you will actually be using. So your vertical axis is like your speed. Basically, I mean, it's a convention. You can interchangeably use this, but you can use the vertical axis as speed. So basically you see the value 0 to 100. So that's what it is. So we can type in speed, because we can use this name later on. And for the horizontal axis, we can call this one direction. And it's going to be from -180 to +180. Over here for speed, we can go 0 to whatever maximum speed. By default it's 600, so we'll go with that. And we don't have sideways animations. Otherwise, on the left here, you can place your sideways animations. I'll just show you with these ones. So obviously when your speed and direction is 0, you would be idling. And walk forward is going to be over here. Now if I hold down shift and if I walk through this, so whoops, so I must just leave that over there. So at 0 and 0 and hold control, actually hold control, and if you would notice, you're transitioning between the animations. So if I play, as you see, now if you're walking slowly, so let's say I leave it at here. So when my speed is 373 and my direction is whatever that is, this is how the animation is going to play. Now if you want this to change a little bit, you can actually increase or decrease the values over here. And smoothing time is basically for your transition time. So how long it will take to transition from one animation to the other. Generally, I just leave it at 0. I've had no issues, honestly. Now in our animation blueprint, instead of this, we can use our walk run blend space. Alright, you can connect this blend space to the output. Now we would see that you have to provide the direction and speed. And doing that is actually pretty simple. So head into your event graph. And what you basically do is you grab your character reference over here. And from this, we can actually get the velocity. So velocity, get velocity, and then from here we can get the vector length. So basically the magnitude of the vector. Alright, once we get that, for the direction actually, we have a node called calculate direction, which requires the velocity, and I will tell you what to do next. So we need direction and speed. So we can promote these to variable. So promote to variable, we can call this one direction, and we can call this one speed. And if the character is valid, we can set the direction and speed. Over here in the direction, for the velocity, we can just directly grab in this pin over here. And then what we can do is we can get actor rotation. Now if I hit compile and if I go ahead and plug these in over here in my blend space player, then in my transition over here, so walk, run to idle, instead of not moving, what we can do is we can get the speed, and if it is less than a certain value, so if it is less than, let's say, about 10, so then we'll enter this transition. Similarly, if the speed is greater than 10, we'll enter this transition. So if the speed is greater than 10, so then we can go ahead and transition into the walk run state. So once we change that, we should have our logic working. So now if I go ahead and press play, as you can see, the walk run animations are working. So that's about it. Now we have finished animating the character with some basic animation blueprints. So that's all there is to it. Obviously there are many more things you can do with this animation blueprint. Of course you can have sprinting as well. So if you would have sprint, you would have another state called sprint, and then you would plug it in according to what logic you want. Basically all you have to take care of is when your character can transition into states, and make sure it's not going to be in two states at the same time. That's about it. And in the event graph, anything that has to update, so for example the speed of the character, those can be done over here on blueprint update animation event. So now I think this is more than enough for blueprints, and I think with this much of blueprint knowledge you would be able to make an entire game, assuming of course you would be ready to look into the documentation a bit and look into what the various functions do. If you actually play around with whatever we did, plus look at a few extra functions, you can create an entire game. And now, for the more keen ones out of you here, we are going to head into C++ now. We'll be taking a deep dive into the more advanced features of the engine. Now, not to worry for those people who don't know C++, I will also be brushing through some of the prerequisites that you need in C++ in order to get started. Honestly, there's not much to do with the language. Most of it would just be function calls and stuff like that. So anyways, without any more further delay, let's actually start learning C++ for Unreal. Now I will be going through the basics now. Now let's just talk a little bit about the prerequisite knowledge of C++ which you'll need to actually understand the further part of the course. I do still recommend you learn C++ separately, but I will get you guys what you need for Unreal, because it's really not that important to know the language. More so you need to know the features which we actually will make use of in Unreal. So I'll just create an empty console application here. So it's just going to be a blank application with in the terminal. Now I won't even use this, I'll just use an empty project template. So I'll just search for empty in Visual Studio, of course. I mean, we have it right here, so just go click next. And doesn't really matter, I'll just look for a folder. So I'm just going to create it there and click create. So just leave all the settings at default, none of these would matter for now. Now once I've created this, I'll just go ahead and set up the basic stuff which you need for C++. So first of all, you'll need a C++ file with a main function in it. So just for my reference, I'm going to name it main.cpp. And we need a main function. We'll not get into that now. So int main, and we're just going to return 0. Now I'll not get into this, but the feature which first of all we'll need is to include code from other files. Now if you want to do that, you would do #include, and inside angular brackets or inside double quotes depending on the situation, you would include the actual header file. So let's say I have a header file, so I'll create one. So go ahead and call this, I don't know, header.h. Let's just leave it as is. And Pragma once basically means this header file will only be included once, so you won't have circular dependencies and stuff basically. But anyways, let's go ahead and type some code. So in order to create variables, that's the first thing you'll need apart from including. So including this header file is simple. So in double quotes you can put header.h, or you could even use angular brackets. You know, generally you would use that only for like standard C++ stuff, but both of them will work. So if you want to include header.h through this, you might have to add it in the include paths. So we'll not do that. We'll stick with this. So let's say something standard C++ such as IOStream. So I misspelled that. IOStream. I can go ahead and do this. Or if I have something standard C, for example, Windows .h, so I can do that. So for standard C++ libraries, you would not use .h. For standard C ones, you'll use .h. So for example, if you want CMath, that's going to be without a .h, or you could do math.h. This is the CMath library. So stuff like this. For now, we'll include header. So whoops. So header.h. Now this should work, and later on I will be showing you guys how to include Unreal headers. That's not an issue. So this main function I'd just like to go over. Basically your program is going to start from here, but again, as I told you guys, when you're developing a game in Unreal, you'd really not worry about the main function. That is handled in the engine. So if you actually go through the engine source, you will find somewhere where you have int main, and there'll be a while loop which actually runs the game. So we'll not talk about that. So let's write some code. So first of all, creating variables. And before we do that, one thing to note is that these are just text files. Honestly, you can put the same code in a header and a C++ file. It really doesn't matter. By putting .h, you just indicate that you want to include it as a header. So that's the only reason. Both of these are technically just text files and can be opened with any text editor such as Notepad, Notepad++, Visual Studio, or Visual Studio Code. Honestly, doesn't matter. So if you want to create a variable, you can first of all head into CPP reference to know the basic types. But if you want to create an integer, for example, you type in int space your variable name. So for example, we'll have my integer. And if you type in equals, you can assign an initial value to it. You actually don't need to do that. You can do this a bit later as well, but you have to do it inside of a function or something. So if I just put my integer equals 12 and make sure you end everything with a semicolon, this is not going to work because even though you have this line here, you're not executing this at all. So remember I told you guys the program starts from the main function. So over here, if I put my integer equals 12, this is going to work. Why this works is because we have included header.h. So it's as if it just copied over all of this content and pasted it in instead of this hash include. Now similarly, you can have other types which we discussed. So you can have float x for example, and you can have many other types. So for example, if you wanted a string, you would put in std string. In Unreal you use fstring, but again, now you're getting an error. That's simply because you have to include string. So these are the few additional complexities which come with C++. So std string, my string equals, let's say, test string. And you can go ahead and set the value again, test string. So not sure what we call that. So okay, my string is what we called it. So my string equals, and you can assign any value to it, or you could even use the constructor for this. Anyways, this is how you create variables like this. Data type, variable name equals value. Value need not be defined, initialized as soon as you create the variable. You can do it later as well, but it's always a good practice to do it. Now, one more thing is that these variables can be printed out which you will not use in Unreal. You'll use the print string function to print it on the viewport. But in a console application, you do something like std cout, and you would go ahead and print my string, for example. Again, we're not using this in Unreal, so that's the reason I'm not really covering this. So the error is because we haven't included the header which contains this function. So you can go ahead and include IOStream. And if you go ahead and run a debugger here, as you see, we get 232 printed because that was our string. Again, if we just delete this part, you would see we will get test string. And we can also print my integer like this. So we get 12. So this is how you would go about printing stuff. And what if you wanted to write your own function? So what if you have like 10 lines of code and you wanted it to be called once? So basically you can create a function with this syntax. So if you want to create a function, what you do is you'd put the return type. Let's say we create an addition function. So our result is going to be an integer. So the return type is int space your function name. So in our case, let's just descriptively name it add. And in the bracket, you would put the variables which you take from outside. So in order to add two numbers, we will need two numbers first of all. So we are going to pass two integers. So the same way in which you created a variable and in the same way in which you'd handle anything else, you would just do int a comma int b. So you separate arguments through a comma. So what this basically means is when I call add, so when I say add and I put my parentheses, so this is how you call a function. So if you want to execute add, this is how you do it, and you'd end it with a semicolon. Now inside the bracket, you would put the values of a and b. So in my case, if I just put in 12 and 43, or I'll just take some random numbers. Now the result of this is going to be returned here. And in fact, instead of, you can set it inside the variable. So if I do my integer equals add of 1342 comma 43, so whatever value will be returned here, that will be set inside my integer. Now if you want to actually write the logic for this, so you'd simply do return a plus b, something like this. So this is how you do a function. But honestly, you don't need the syntax, since we actually have a simpler way to actually write functions. We'll be using classes mostly, so you shouldn't really bother too much about all this. And with that being said, let me just show you guys how to create a class. So I'll do it in my header. So for example, I'll just do a class called student, and I'll open up my curly braces. Just follow along with the syntax. It's just a matter of getting used to it. So under private, so these were the private variables which we talked about in Blueprint as well. So I can say we have a name, and let's say we have his marks. So int marks, something simple like that. And under the public section, we can have some methods. So we can say std string. Oops. And we can call this one get name. And instead of writing the definition over here like this, so this is similar to what we did here. It's just that it is inside the class now. What we can do is we can only have the declaration here like this. So only the name is given here, but we can actually have it defined outside this class itself. So I can do this, and I can go ahead and actually make another function. So I can say int get marks. So now you can also go ahead and define this outside the class. How you do that is you'd use this syntax. I'm not talking in depth about this, mostly because there's a shortcut to do it, which I will talk about. So std string, and what was our class called? Student, followed by two colons. You do get name, and you can write your function definition over here. So you can go ahead and return, I guess it was called name, so name. And similarly you can provide a definition for the marks as well. So int student get marks, and you can go ahead and write the definition for it, return marks. So basically you are going to get the marks from this. Now if you want to instantiate a student, so let's say you wanted to create a student object from this. Remember we talked about classes and objects. So you just do student, let's just call him S1 for example. And you can do S1 dot get name. Now dot is what you'd use to refer to the members inside a class. In Unreal though, when you create objects, you generally have a pointer to it. So basically the memory address of it is a pointer. Nothing much to worry really. So I'll just show you guys a way to create it. So if I type in student pointer instead equals new S1, basically we are dynamic new student. So new student. Basically we are dynamically creating this, and instead of the actual variable name we have a pointer to it pretty much. Now nothing much to worry about, you just put a star instead of just referring to student. And if you want to refer to something through a pointer, you do S1 instead of putting a dot. Now if you were to do dot, you see it just got replaced with an arrow, so you'd refer it with an arrow. So something like this. So if we actually just create a method to set the marks, so I'll just do void set marks, and it's going to be int the parameter which we need, so int marks. So we'll take this value from outside and we can say marks. Okay, we are using this again, so we can type in marks with a lowercase, so marks equals marks. So what we can do is we can say S1 dot set marks, or rather with the arrow set marks, and we can just say 56 for example, just a random number, and we can print it by typing in stdcout, and we can print this. So run a debugger, and as you can see we got 56 printed, so we successfully set the marks. So this is how you would call functions which are defined inside a class, and you will need to call them through an object because you need to instantiate them first of all. This is something which you will not do in Unreal. You'd use the functions such as spawn actor and stuff in order to actually create objects. But anyways, this was just something I showed you guys. Now with this much you can pretty much do it. If there's anything else such as for loops and stuff, you can just follow along and look at the syntax. That's pretty much it. And if statements are also easy, so you just do if, and you would have the condition in the bracket. So let's say the marks is greater than 56, so I can do S1 get marks. S1 get marks greater than, let's say, 35. Then we can go ahead and print that the student has passed. So stdcout, and I can say passed. So if I do this, as you would see, we get 56 and passed. Obviously this is not in a new line, but that's pretty easy to do. So you can do stdendl, and now you'd see 56 passed. So with this much basic C++, you can actually follow along. But again, I do recommend you separately learn a bit of C++ before you come in. The upcoming sections of this course is going to be for intermediate and advanced users. So before you actually get started, I recommend you guys do a few things. First of all, spend maybe a few days actually exploring the engine a little bit more, maybe creating a tiny game or something. And secondly, make sure you do know the basics of object-oriented programming in C++. So stuff like your classes and stuff like structs, functions and variables, and the basic stuff basically. If you guys are familiar with that much of C++, and you have used the engine a little bit, you would be able to follow along with the further part of the course. So in order to start coding in C++ for Unreal, head into Tools and open your Visual Studio project by clicking on that button over there. And you should be in some sort of a file over here. Now you may have something blank, so we'll just close that. Now under your games folder, you should see your project name here, and this is where you actually start working with stuff. Now we don't have anything actually under this. We are going to be having our source files. So you don't actually create it here in Unreal. In Unreal, you actually have the option to just generate all the boilerplate code for you. You can do that by heading into Tools and by typing in New C++ class. Now over here, you get various options. Now if you have something really simple, if you have some pure C++ logic, you could just create an empty class and you could just tinker around. It's just going to create a constructor, destructor, and it's going to write the class definition for you along with no macros, just the standard C++ one. But the most basic useful thing that you'll use in Unreal is going to be your object. So under all classes, if you select object, this is going to be equivalent to your object in Blueprints. However, when you actually create it, so if I just create it, just select public, and this is just to determine where your CPP file will be, whether it will be in the public folder or the private folder. Now over here we can just call this CPP object. So let's not confuse ourselves. Let's just call it CPP underscore, yeah, object is fine. So this is not an object, this is the class which is named CPP object. Please don't get confused with that. So create a class, and now as you can see, you have some really basic code. And one thing you might have noticed is, okay, live coding is on, that's a different story. But what you might notice is it already has several things, such as it has included some header files here. These are just Unreal standard header files, and you will need them. And you might have seen a few extra macros as well. So this is a UCLASS macro, and inside these actually take in arguments too. Now these are useful for the Unreal header tool. Basically when you compile this, it happens in two phases. Basically your Unreal header tool sets up stuff which are specific to your objects for Unreal called UObjects, and in order to implement those features, it does certain extra steps. So when you get a compiler error, it could be either from that or from your standard C++ compiler. Anyways, that shouldn't be much of a problem to you guys. Now, if you might have noticed, even though we called it CPP object, it's prefixed with a U, and we have inherited it from UObject. Now, why is it like this? Now, basically any object that you create, that is a derived class of UObject, must have the prefix U, and even object has the prefix U. In Blueprint, it is just shown as object. However, in theory, it is actually UObject. And similarly for actors, so let's actually create an actor as well. So we can head back into the editor, tools, new C++ class, and as you can see, you see pretty much the same stuff over here. But these are the two important ones, object and actor. Now obviously character, pawn and stuff like that are important, but they don't have any specific prefixes. So I'll be talking about them a bit later. And obviously we'll talk in depth about the inheritance hierarchy. So I'll select actor, and let's call this one CPP underscore actor. Create that. And live coding, if it works properly, it should in theory compile it for us. Now if we actually open it up and reload this, you would see you find something which looks a little bit overwhelming if you're looking at it from the first time. But if you ignore this macro and if you ignore this comment here, I don't even know why this comment exists, because if you come to an extent where you can write or interpret this code, I don't think you need to know that a constructor sets the default value. So we'll just delete that comment. And begin play is basically your event begin play in Blueprint. Same thing. Tick is again your tick in Blueprint. You can delete the comment. Now this code looks a lot more cleaner. Now this is a virtual function. And if you were to notice, it's not called CPP actor, it's called a CPP actor. Basically, every actor is prefixed with an A and the actor class itself as well. Alright, now that we have established a basic understanding on creating Blueprint equivalent actors and objects, let's look at the inheritance hierarchy in Unreal in a little more detail. Now I'm not covering everything over here. Now I have left a few things such as interfaces, and I'm not going into each class. I'm just talking about the ones that you'll use in almost every project. So that should cover things for you. If you need anything in specific, the documentation should help you if you understand this much. So at the base level, you have UObject. Of course, you have your typical basic C++ class, but we are not getting into that. Now under that, I can categorize these into three main other classes which you'll use. Now there are many others, but you won't really use them. The first one, and which you probably expected, is a actor. Now an actor, or a actor as it's called in C++, is something which can be placed in the scene. So if you want to place something in the scene and write the code in C++, you would create an A actor, or in the menu or in the Unreal editor, it's referred to as actor everywhere. Now similar to pawn, you have a pawn, which is basically something which can be possessed by a controller. So basically you can control it, and it need not be you, it could be an AI as well. So maybe you could write some code for bots or something. So you would use pawn in that case. And if you have something specific like a humanoid character or something, generally for most of the things which will be pawn, you generally use character. So if you need a movement component and stuff like that, you would use character. Some functionality is already set up in your character which is not set up in pawn. So something such as adding your controller pitch and yaw input, and many other functions which we will talk about as we use them. So that's where you'll use character. This might be clear. Now a controller is basically an actor which takes in input. Now you cannot place a controller in a level. Obviously it sounds a bit stupid to place a controller in a level, but basically each player will have his own controller, and to be specific, he will have a player controller. If it's an AI or something, you have something known as an AI controller, but again, we are not getting into that. It's really not that common to use it. A controller will basically take your input. Now, although you can set up your input bindings in other actor blueprints, controller is the right one to actually hardcode bindings and stuff like that. Generally, when you create widgets which are not associated with your character, you'd create them inside your player controller blueprint. Generally, you create a player controller, you don't create a controller. And that's about it for what you'll use for the most part. And if we actually head into more gameplay oriented classes, you have A-info. The reason I put this is because this was just a wrapper for these classes which you'll use. You'll never create an A-info actor, so ignore this. This is just for your reference. Over here you'd see a game mode base. As the name suggests, game mode base, it's basically your game mode. So any code logic regarding your game mode will be there in this, and obviously it's really simple for me to just tell it like this. But once I take a couple of examples, it's going to be crystal clear for you guys. And there is also an A game mode class which is inherited from this, and it has some additional functionality. For the most part, we will stick with A game mode base, but again, you can feel free to use A game mode. Similarly, A game state base and A game state. Now you might ask, what's the difference between these two? The main difference is that game mode exists only on the server in multiplayer games, whereas game state exists both on the server and client. So things like match timers, which you would want all the players to be able to see as well, you'd have them stored in the game state. And maybe some other variables which you only want to use as a means of calculating something in game. So stuff which will only be there on the server in multiplayer games, or something which is core to your fundamental gameplay. So something like maybe, you know, switching to another level when you enter a place or something. I mean, it depends on the game, honestly. Can't just tell what you do with it just like that. But basically, game mode, game state work together hand in hand. Now there's one more actually called the player state. Now the player state is really special because this is replicated by default to all the clients in multiplayer. We'll talk more in detail about multiplayer later on, but for now just know that player state is going to be kind of the class which you'll use for anything that all the players must know at all points of time. And generally you'd store info common to a given player which other players need to know. Stuff like your player name would be there in your player state because all other players need to be able to access your player name at any point of time. So I just gave you an example. You could be creative with it and do whatever you want. Now one thing you might have noticed over here for the last one which I'll talk about under UObject is, or actually two more, game instances. As the name suggests, your game's instance. So this is talking about your game as a whole and not anything inside the game. So instead of begin play, actually you have something known as event init here. So let's say you call something off of event init. That actually runs well before your level actually loads. So we'll look into examples again. If you have anything pertaining to the game which has to sustain between level transitions, let's say you move from your main menu to your actual gameplay level. If you want stuff to sustain between them, let's say you wanted a variable to sustain, in that case you'd use the game instance because the game instance will not be destroyed between levels. But when you transition from one level to the other, all the actors and all the widgets, everything else that you could possibly think of are going to be destroyed. Now, speaking of widgets, we have multiple classes here which you'll probably never even touch. Even widget, to be honest, you'll never touch in C++. It's very rare that you'd require a C++ class for a widget. So user widget is the class which you'll use. Of course, in the editor, it's going to be referred to as user widget. So this is how you'd create widgets, but honestly it's too much of a pain to work with widgets in C++ for something that's just, you know, very simple. You could just work with other blueprints and just have a blueprint widget which you'd interact with, stuff like that. So that's about it actually. Now the way you'd practically use this is you'd have one C++ base class. So for example, we can have, for a character, we can have one character and we can go ahead and derive one. So let's say we call this one R character. So let's say it is A, we'll just call it CPP as a convention, A CPP underscore R character. I'll just call it rchar for now. Now what you do is you'd have core functionality written inside this class. So for example, your movement maybe if you have a first-person shooter game, your firing logic, basically stuff that is mission critical for the game and stuff which would break if they don't execute. So for that, you'd write it in C++. But other cosmetic things which you don't really require, and it's fine if it executes a bit late, stuff like, you know, creating widget, maybe let's say you have a crosshair on the screen, maybe updating its position, if you have a dynamic crosshair, that is. Or maybe, you know, stuff which is not essential, like effects, spawning effects. So if you have stuff like that, which is not really mission critical, it's fine if it's a bit slow. And maybe if you don't have too many loops. So if you have many loops in your code, Blueprint generally runs slower. I will talk about why that is and stuff. So what you do is you'd have the core functionality in your base class, and then you'd create a blueprint class which I'm marking in yellow, and you'll call this one bp underscore rchar. Now this is just a convention I use. You could call it anything. You could simply call this one rchar. So this is going to be our blueprint class, and this is what you'll spawn in the level. So since this is inherited from this, bp rchar will have all the properties of acpp rchar. Similarly, you do that for all the other classes, and that's how you'd work hand in hand with Blueprint and C++. Blueprint is going to make your coding a lot easier. So it's basically your visual scripting language. So it's going to be very simple to write game logic. But when it comes to finer control, and when it comes to using other libraries, when it comes to doing mission critical stuff, you would use C++. So that's basically how you use Blueprint and C++ hand in hand. Of course, this is a very in-depth topic, and we are going to be talking about this in the future. Now let's actually go ahead and work a little bit more on whatever we learned till now. So now that we know about the basic inheritance hierarchy, let's actually start creating stuff on our own. Now, the first thing which you might want to create are variables. Now, for our case, just for reference, we'll be using our cpp object.h. But anyways, you don't have to use this. You can do this inside the actor as well. So stuff like that will remain the same. Most of the time, you will not have anything in the global scope. You will create everything inside of your class itself. So the rest of your file, maybe if you are creating a new struct or something, you'd use it. But most of the times you will be doing stuff inside the class. So let's create a variable. Now you could do your normal C++ syntax thing. So for example, let me just create an integer. So by using int, let's say our integer variable. Alright, you could initialize it here or in the constructor. Now, one thing that you might know is that since this is private, our derived classes, hence any blueprint class which we create out of this, cannot access a variable. So in order to actually access it, there are two ways. I'll be showing you guys both the ways. So I'll type in our private integer variable because we made it private. This is how you would ideally do it. I'm just explaining you guys each thing, but you could brush through if you are already aware of object-oriented programming. But anyways, it will give you a learning experience nonetheless. Now, another way you could do it is you could create a variable in the public section. So we'll call this one our public integer variable. Now, this is good if you want to access it everywhere. However, it's really not appropriate to do it this way, because if you have it in public, any other class can just straight up modify this variable, which is not good for us. Let's say you have something like your character speed or something. It's very easy to misinterpret that, maybe accidentally change the value. So it's better to have getters and setters instead. Now this is how you would work with a public variable. I know you guys are still waiting for the Unreal's reflection system. So all these macros which you see, UCLASS, USTRUCT, UPROPERTY, I'll tell you about all those. Not to worry. Now another thing is that since this is private, in order for other classes to access it, we actually need to define a method. So we can call this one int get our private int. We called it integer over there. So let's call it like this. Now we also probably need a setter. So set our private integer. Now we don't have a function definition. So the reason I told you guys at the beginning that you don't really need to know too much C++ is that once you know how to write the declaration, you could just right click quick actions and you could just create a definition like this. Same way with our setter function. Oh, and this has to be void because we aren't actually returning anything. You could make it bool. So let's say you have a condition where you can't set it. So let's say for a health variable, you can't set it to 101. So then you would do those checkings and stuff. But in our case, we'll just use void. Head into the file here. and instead of this we will return this variable. So not public, we'll return our private integer variable. Now this is how you would set it up for the private variable, and this is the proper way to do it. Also, currently none of these use Unreal's reflection system. Now if I just run a debugger, so it's going to launch the editor. Make sure it's set to development editor in the configuration. So wait for that to build, and once it's done building, it should start the editor. Now in order to actually use this over here and actually check stuff in Blueprint, so what you would do is you would right click, go to Blueprint class and type in cpp_object, but you see that it's not visible. Now the reason it's not visible, but our actor was visible, because by default all actors, if you were to go into this file, by default all actors are going to be marked as blueprintable. So if I actually head into the actor over here, and if I actually look into this UCLASS macro, you see it says blueprintable. So what we need to do is, in our object, if we want to use this in Blueprint, that is, inside this UCLASS macro, type in blueprintable. Now this is how you expose your U objects to Blueprint. So let's say anything is not accessible in this menu over here under all classes, it probably means you haven't marked it as blueprintable. So let's stop the debugger and run it again. So wait for it to compile. Then once the editor loads up, we should be able to use our cpp_object class. So give it a second for it to load. And now if I head back into blueprints, right click, blueprint class, cpp_object, you see that it's usable. And this one will call it bp_object. Now if I just right click and if I want to access the function, so we have get our private integer. So get r, and as you can see there is really nothing. The reason is Unreal doesn't really know that you want this to come in the editor. Basically you're not utilizing the Unreal standard macros which enable you to do it. So how you do it is, for variables, what you do for a public variable here, we are going to type in UPROPERTY, and in the arguments we'll use a parameter known as blueprint read write. Now when you put this in the arguments, basically what you're saying is you want this to be readable and writable in Blueprint. Let's say you only wanted to be able to read it, you do blueprint read only. Now how do I know how to do this? Basically you can just head into your browser and type in UPROPERTY UE4 or UE5, oops, not properties. So yep, UPROPERTY. So basically you have to go to the documentation page, and as you can see there should be a list of specifiers somewhere over here. There is. So all of these are the specifiers. So let's say you wanted a function to be blueprint callable, you do that. There is blueprint pure as well. I'll be showing you guys the common ones, but you can have a look at all of these. The documentation is king. Now for a private variable, actually we don't need to make this a UPROPERTY. However, you could choose to make it. Now if you want to use these getters and setters, which will technically, enable us to use our private variable, our get function will be pure, of course. So we are going to use a U function now. Now U function is another macro. Again, you could have a look at it. So here if I head into U function over here, you see again there is documentation which talks in depth about this. We will be looking at the common ones anyways. This one will be blueprint pure. Blueprint pure means those green nodes which we saw without any execution pins. So if I actually head into any blueprint, these types of nodes basically without this execution pin, that's going to be our pure function. And I talked a lot in depth about it when I talked about blueprints and stuff. Now this one will be a U function as well, and this one will just be blueprint callable. Alright, now we can go ahead and run a debugger. Now we should be able to access these. Now live coding is a bit finicky. That's the reason I'm not using it. Otherwise I would have chose to use it. Now let me just create that. I didn't actually save it. So cpp underscore object. We'll call this one bp underscore object. Save that this time. If I open it up now and if I type in get our private integer, you see we get this function which gives us access to the value. Similarly, set our private integer also works, but it's kinda useless. We actually didn't set up any functionality. So let's just take in a parameter. Parameters are pretty simple except references. Everything else is going to be the same for parameters, like how you do in standard C++. So you could type in int new value, and over here as well we could just head into the definition and change that, and then we could do our private or our public, it should be private. So our private integer variable equals new value. Now that should fix things. So we should have our logic corrected over there, but that's not really our concern right now. Now what if you wanted to take a value by reference? Now this is passed by value and it will work. You could try it out. Not really going to waste my time to show it. If you actually want your value to be passed by reference, you use this macro known as uparam. So uparam ref, and then you use an ampersand over here. So copy this, do the same thing in your CPP, and now if I go ahead and actually build this once again, and in my object, if I go ahead and type set our private integer, you see it's taking in by reference. If you hover over it, it says new value integer by reference. So this is how you do pass by reference. I just showed that. This is one thing which is a little different from C++. You can't just use an ampersand. However, if you use an ampersand, it is going to take it as a second return value in Blueprint, basically like your out parameters. So let me show you guys what I mean by that. So if I do this, now this is wrong. Logically this is wrong. I know that. But anyways, I'm just showing you guys what's going to happen. So if I go ahead and run a debugger once again, this time it's going to take it as an output rather than an input. If I open my BP object again, and if I type in, let's say set our private integer, you see the new value goes out. Basically this is how you handle multiple return values as well. You could just do pass by reference, and in Blueprint it's going to interpret it as an out parameter. In our case, uparam ref was the correct choice, so we are going to do that. Undo this over here as well. So that's about it. Oops, just correct that. Also, if you guys want to access your public variable, you can just directly use our public variable. So our public integer variable, so it's directly accessible to us. But one thing you might notice is that unlike these variables here, it does not let you edit the default value and stuff. Now there is one reason for that. That's because you again need to set a flag in order to do it. Remember the UPROPERTY macro? Over here you have to type in edit anywhere in order to be able to do it. So edit anywhere, if I can spell that correctly. If I actually do this and run a debugger once again, I should be able to use our public integer variable and set its default value. Now if you were to see under the class defaults, we have an option to set the default value, or when we even get our public integer variable, you see that we can set our default value. So this is basically how you expose that to Blueprint. I suggest that you guys now try it with a few more functions of yourself, and maybe check how they work in the editor and stuff. Once that's done, let's talk about the next type, that is USTRUCT. So basically, if you want to create structs for the Unreal Engine, you need to use the macro known as USTRUCT. Now generally, I prefer doing it inside this .h file for your project. So you will have a file like this, but you really don't need to. You could do it in any file. So for example, let me just do it in our cpp object.h file. It could be really anywhere. Unreal is going to recognize it for you. So I'll just do it above our U class. So I'll just type in struct. And if you guys don't know what struct is, well, you got to learn that before. It's basically like a class, but by default, all its members are public. But remember, when you're working with Unreal Engine, you don't really work with struct methods. You only work with variables, and any methods you'll have it in another class as static functions. So that's how you work with it. Anyways, I will show you guys what I mean by that real soon. So for example, let's just create a struct known as, let's say, book. This is obviously highly impractical, but just as a basic example. And for the variables, we could have maybe a string. Now remember, in Unreal Engine, the variable you use is not std string. So you don't use std string actually. What you use is called fstring, which is Unreal's string type. Obviously, most of the string types are just interconvertible at any point of time. So if you're using a third-party library or something, you can convert it. So fstring is the string type in Unreal. So if I type in fstring, let's say name, and maybe we can have an integer for number of pages, and we can have a float for rating. Alright, we have a really basic struct over here. Now if I go ahead and build this actually, so I'll close my editor. If I go ahead and build this, you would see that it would build successfully. However, obviously, as you would expect, you cannot access this struct in the editor because we haven't used the Unreal macros. So in order to use this in the editor, you call USTRUCT. And inside the parameters, what you do is you would make this blueprint type. So this is what you use to expose struct to blueprints. Now if I actually run a debugger right here, so you would find that there are a few build errors. So what this is this is not your C++ compiler error. Basically, there are a few rules in order to use structs in Unreal. Similar to how you have a U prefix, for all structs you need to have an F prefix. So now if I go ahead and run this, in the editor it's going to be visible as book. You see that we get another error. Now it says expected a generated body. Now if you notice our class here, it has a generated body. Similarly, for our struct as well, for all USTRUCTs, we are supposed to be having a generated USTRUCT body. So it's going to set stuff up for the editor for us basically. So now if I go ahead and build this, you should see that we compile successfully. And we open up the editor right now. But you will soon notice one problem again, which you probably would have guessed if you would have seen these. So if I just head into my object, for example, and if I type in, let's say I create a new variable and call this one book1, and I get the type book, you see I can access this. There's no issue. But if I right click, I can't actually split the struct pins. Now if you actually hover over this, cannot split the struct pin, it may be missing blueprint exposed properties. So what it basically tells us is we actually need to mark these as UPROPERTY as well. So the same macro can be used here as well. So UPROPERTY, and there's a little bit of an issue with the indentation there, don't mind. So UPROPERTY again make this one a UPROPERTY. depending on what you want. Let's say we don't want to be able to change the name, so let's make that blueprint read only, so then we won't be able to change it. Now if I stop debugging and open the editor once again, now if I go ahead and take a look, and if I drag this in, right click and split struct pin, I am able to split it. Now if you drag this in and if you want to edit the members, you would use the set members function. And obviously you can have number of pages and rating as a parameter, and we set name as not being editable. Since we did blueprint read only, as you can see, we don't have that available as a pin. So this is basically how you use structs in C++. Now the way you use it in C++ is pretty much the same like how you would. By the way, if you want struct methods, you can use them, but you cannot write U functions inside struct. That's the thing. So if I actually go ahead and try it, basically, I'll show it to you guys. So if I head in here, type in, let's say, void test function, and I'll just give it a simple body here, and I won't do anything. Now you would see that it will build successfully. There won't be any issues. So as you can see, it builds. But if I actually make this a U function, I won't even give any parameters. If I just make this a U function, as you would see, it says U structs cannot contain U functions. So how do you actually do stuff with it? So how do you actually operate on structs? Basically, what you would do is, instead of having the U function here, you would have it inside either a function library class, or you would have it inside some other object and make it a static function maybe. So let me actually show that. So let's create a test function. So for example, let's create a U function here. So U function, and what we can do is we can make this blueprint callable. And over here, instead of just declaring a regular function, let's do a static function, static void test. And now we want to operate on this struct. So if you want to operate it similar to your objects, what you could do is you could simply create your own target pin. So the way you do it is fbook target, and obviously you would make that a reference. So uparam, and in the brackets you would have ref. So you would pass this as a reference, and then you could work with it inside. So I can write the definition here as well, but just to be a bit cleaner. So quick actions. So whoops, quick actions, and I can create the definition. And now that we've actually come this far, I'll just show you guys how to print strings. So it's not like blueprint where you directly just call, print string, and this is not gonna work. So I can't just do this. So let's just say test function called, for example. I actually cannot do this. The very simple reason being that in Blueprint, Unreal actually imports, or rather includes, all your headers for you as per necessity. But basically that doesn't happen here. So it's not exactly headers, but you get the point. So in order to use print string, so how you would go about searching for functions is you do something like this. So you do print string Unreal C++. This is how you just search it up, and you would look for the one which says docs.unrealengine.com, and you would head in here, and it tells you the include file. So copy this path, paste this in, not path, rather the include, and now you would see you have all the various parameters, some of which are optional. There are only 2 parameters which you actually need, but anyways, now what we can do is, now you notice that you're not able to call it, but that's because this is actually a static function once again. So what you do is you do ukismet system library, and followed by scope resolution, print string, and now you'd see that it still shows an error. That's because you actually need to pass in a world context object. because it doesn't really know, where to output the string, like how to show it on the screen. So in order for it to know that, you actually need to pass in an object. If this wasn't a static function, you would just use this. So if this were inside an actor and it's not static, you would use this, but it says this may only be used inside a non-static member function. So what we can do is we can just pass in a uObject pointer over here, or rather we'll just pass in an actor pointer. So a actor pointer. Now remember, when you work in C++, any object, any actor, anything that you have which is enclosed in a class, basically any class, if you want to use them, you would use a pointer to it. You will never refer to it as a actor. It will always be a pointer. Just remember that. So an actor is just to give, some context to it. So we can just type in context, for example. It could be an object as well, I assume. So if I type in context here, now we would see that the error is gone. But obviously we changed the function signature. You could make this a uObject pointer, I believe. And now what we can do is we can copy this over, head back into our function declaration and put that in. So now our error should go. Now if I go ahead and actually run this, now if I head in to blueprints and BP object, or here if I call test, for example, I think it's called test. As you can see, now we can operate on this struct. And for the context, what we can do is simply we can plug any outer object in. So I'll just actually do that. So I'll open up the level blueprint. So for the context, what we can do is we can go ahead and get a reference to self. And for the target, what we would do is we would go ahead and actually get a struct. So instead of this, I'll just create a struct. So I'll just call this struct, for example, and it's going to be of type book. So we can use that, and now this function is going to operate on this struct. So this is just a basic way you can do it. Now if I go ahead and press play, after 3 seconds you should see something being printed, test function called. As you can see, that works. So that's pretty much how we would handle struct methods. So that pretty much covers the basics of using structs in Unreal C++. Now the next thing is obviously enumerations, and that should be about it, and then we can start working with a little more complicated things. At the base level, enumerations in Blueprint and C++ work the same, but in order to create them in C++, you can do the same thing actually. You can do enum. This one doesn't really need to have a prefix, by the way. So for example, let's just say fruit list, let's just call it. And inside that we can have our list items. So let's say we have apple, let's say we have our mango, and let's say we have a banana. Stuff like that. Make sure you just end everything with a comma. Now again, the same thing. This is not exactly exposed to Blueprint, but in order to actually expose this, you use the same specifier as your USTRUCT, but instead you type in UEnum. If you use the UEnum macro, and if you add in the parameter blueprint type, now this would be usable in Blueprint. But if you wanted to give it a different, name for it in Blueprint, so if you wanted to give a display name to this, basically, what you'd do is you'd use another macro known as uMeta, and over here you'd change display name equals, and you'd put in the string. So in our case, let's just call this one apple underscore 1 maybe. So just for me to demonstrate that it works. Now if I actually run the editor, And I can just go ahead into any blueprint and I can operate on that. So I can say switch on whatever we call that fruit list. As you can see, instead of apple, it actually shows apple 1, and mango and banana is just shown as is. Generally what you would do is you would simply have the display name to just display exactly what this list item was. So you would simply have this, and you would have mango over here. Generally you would just leave it like this, banana. So this is how you would go about doing it. Now we have brushed through the basics of Unreal Engine C++. Of course, if you want to know what function calls to use for your gameplay specific needs, you could refer the documentation. And later on, when we actually take an example, we will look into some of the common ones. So it's not really that you have to refer the docs for everything. I will be going through many of them. Now over here, let's actually do a quick exercise. Let's try to translate this into C++. Now, if you were to notice, this entire thing is actually purely in Blueprint, and let's say we wanted our code to run faster, or for whatever reason we needed it to be in C++. So let's actually go ahead and translate that. So it's really simple. Let's start step by step. So we have our get player camera manager function. Let's see which header file we need. So it says target is gameplay statics, right? So this tells us that we need gameplay statics. So if I head into Chrome and if I type in gameplay statics UE4 or UE5, you see you actually get the documentation page. So over here we can get access to which header file we need. So Kismet gameplay statics.it. So stuff like that. Let's actually go about doing it. Now for the cast node, we need a C++ class, because all our C++ classes will not have access to the blueprint classes, but all our blueprint classes will have access to the C++ ones. So you cannot access a blueprint class from C++. So that's one disadvantage. Now let's go about doing this. So I'm just showing you guys one example. Obviously we will talk about a few of the common ones, such as spawning actors and stuff, which are really common. Now let's start in the editor. So let's go ahead and actually create the classes that we need. So first of all, we need a base class for our BP character. So go ahead into tools, new C++ class, character, and call this one CPP_character. Of course, you can name it descriptively if you wanted. Create the class, head back in, and we need a couple more things actually. So one thing that we need is the pickup class itself. So type in actor and call this one CPP pickup. Alright, create the class. Now what I want you guys to do is head into BP pickup, and over here under class settings for the parent class, I want you guys to select CPP pickup, and over here as well I want you guys to select CPP character. So CPP_character, I want you guys to select that. Now what this basically means is that you are inheriting this BP character class from CPP character. So everything that's there in CPP character will also be there in BP character. Basically this is your inheritance. Now let's head back in. Let's just reload this, and I think we can close the editor for now. Or actually we might need that for reference. So let's actually open up the character. So we need a player camera manager, and from our header file, from our documentation, we know that we need this header file. So inside our character.h, because that's where we wrote it, always when you're including header files, you need to do it above the generated.h. So over here, Kismet gameplay statics.h, and let's just do this in the public section, and let's have a look. So when we press our left mouse button, we get the player camera manager. So let's try calling that static function. So go ahead. Let's actually create the function. Let's call this one, I don't know, what do we call this? So we're just tracing and destroying. So let's call this one remove pickup or something. So void remove pickup. Alright, we don't really require any parameters. Now let's go ahead and create a definition for it. So, whoops, let's just head in, and it has created the definition for us. So let's go ahead and get that. That's a static function. So gameplay statics get player camera manager, and over here what we can do is for the world context object, since this is an actor, characters are actors, so you can just use this. Generally you would just use this, and player index is 0 since we have only one controller per screen. So we got the camera manager, and from this we need the actor location as well as the forward vector. So what we do is, let's actually just store it in a temporary variable. So we can type auto temp equals, and we can store this in a variable. And what we can do is we can go ahead and get the actor location. So this is a pointer again. So temp with the pointer operator, we can get the actor location. We have forward vector here, let's do that as well. And temp get actor location. Now this might actually warn us right now to use the get camera location function. So as you can see, use get camera location instead. So get camera location, just spell that correctly. And now we have access to these locations. And what we are doing is we are basically plugging this into the Linetrace. So what we can do right now over here to simplify things is we have a forward vector. We grab that in and we multiply it by a float. So the operator is already overloaded, so we multiply that by 50,000 in our case. So let's just do that. And if we head back into our blueprint, so we add that to our camera location. So plus our camera location, so you could just do a plus again. So plus our camera location, we can put these in parentheses just to be a little more clear on what we're actually doing. So we can delete this line. We have that. Next, what do we have is our line trace. So if you just hover over this, you see it says target is Kismet system library, and I know this header file, so I'll just do it for you guys. Anyways, what we are doing is going to be correct. So let's close this up. So it's going to be Kismet system library. You could have a look at the documentation as well. So Kismet system library. And if we include that, our error should go. And if I open up the CPP file once again, now we should be able to call the Linetrace function. So Kismet system library Linetrace. If I do that, I should find Linetrace single. And for the parameters, we have a bunch of them. So first one is the world context object, which is going to be this again. And next we have the start and the end location. We look into all of that. So this, and our start location is going to be our camera location. So what we can do is we can actually store this in a variable right now. So what we can do is we can type in auto camera location equals get camera location. Now for the start, we can go ahead and type in camera location, and then we have our end. So again, we can store this in another variable. So auto end location, or let's just call this one end, equals whatever calculation we just did right there. So end is what we called it. Then the next parameter we have is a trace type query, which is the trace channel. So this is what you see over here. Now over here, this is a little bit peculiar in C++. So if I just do eTrace type query, so eTrace type query, and if I take a look, you get something like 1, 2, 3, so on. Basically, these are what you define in the project settings. So if I actually head into my project settings and just type in trace, you'd be able to see that you get trace channels. By default, we actually get 2. that is visibility and camera. So if we just do trace type query 1, that is going to be your visibility. And then if we take a look, we have a boolean for trace complex. We don't really want to trace for complex collisions here, so let's just do 0, or that is false. And over here we have a parameter which we actually don't need, and we also have a few more, I guess. We'll just use the ones which we absolutely need. So actors to ignore, we can just create an empty array and we can just pass that in. So tarray a actor pointer, and I will get to TRAs, don't worry. Basically this is like your std vector in standard C++. Instead of that, the one used in Unreal is called tarray. So all the same functions exist inside this as well. Instead of dot size, you have, dot num. There are a few names which have changed, but this is pretty much like your std vector. And let's just call this one ignore, and we'll just pass that in. So ignore. And the next parameter is eDraw debug trace. So basically whether you want to see the line trace or not. So eDraw debug trace. Whoops. And over here we have for duration, for 1 frame persistent. Let's keep that for duration for now. Alright. Once that is done, we have our hit result which we are going to output. So we'll just create another variable. So f hit result, and we'll call this one hit or out hit or whatever. And what we can do is we can just pass hit over here. And once we have our hit result, we have be ignore self. Yeah, we want to ignore ourself, and don't really need the trace color because this has a default value. So that's about it basically. So we can go ahead and close this. So I feel these parameters should be enough. And once this function is completed, we should have access to everything that we can possibly think of. So the first thing that we are going to do is we are going to cast it to the pickup. Now, in order for us to work with this, first of all, we need to include the header file. So hash include, because we don't know what cpp pickup is. So we'll just do cpp pickup.h. So this should compile because it is in the same folder. And once we actually include the file, what we can do is we can simply cast it. Now you won't use a dynamic cast here. Unreal actually has some things built in for us. So we can get our hit. So if hit dot actor dot get actor, if this is valid. Now at this point, if we haven't actually hit any actor with our line trace, basically this if is going to be false and we are not going to execute this code. However, if we have hit the actor, we can go ahead and cast it to our pickup. So if can go ahead and cast it. So this is going to be a cpp pickup. This is how you cast in Unreal C++ basically. You have a cast function, and over here we can just pass in the actor. So if this actor is valid, so again the pointer is going to be pointing to an actor if it is actually valid. In that case, what we can do is we can go ahead and destroy this actor. So hit.getActor, and we can call the destroy function. That's about it. And just to make sure, what we can do is we can just print it. So ukismet system library print string, and over here we can just pass in this instead for the world context object, and we can print destroyed a pickup, and we can go ahead and terminate that. So now in order for us to actually be able to call this from Blueprint, we'll set up input and stuff a bit later in Blueprint. It has a couple of extra steps. So in order to expose this to Blueprint, we'll again use a u function and make this one Blueprint callable. Make sure I get the case right and just indent that. And now if I go ahead and close my editor and run a debugger now, the editor should load up, and if we open up our character, we can get rid of all this code, and I don't know what we call this. So we called it remove pickup. I don't even know why we called this, but we can call remove pickup. Remove pickup. Now if I go ahead and press play, and if I left click, as you can see, our logic actually works. And okay, this is not a pickup, this was just a cube, so that's the reason it didn't work. But anyways, the line trace works. Now the reason it's working is because BP pickup is also a CPP pickup because we inherited from it. So that's the reason. What's happening is when we actually cast it over here, we are actually successfully casting to our CPP pickup as well, even though that was a BP pickup. So that's basically how we translate it. Now we can go ahead and clear out some stuff. This was just for clarity. So instead of using the camera location as a separate variable, we can go ahead and copy this over. Similarly for end, we could just do the same. And if we have anything else, we could do that as well. So we don't have anything else. We can go ahead and close this up. We'll leave this temp variable because having such a long line everywhere is going to be a little bit weird. But again, you could do this. So you could just place this instead of temp. Wherever temp is going to be there, you could go ahead and get the player camera manager and do that. But in this case, actually using temp would be a better solution. So we'll just stick with using temp. So we have brushed through quite a bit regarding C++, and as we create stuff, we will go through more things. Now, what if apart from a pickup, we also needed to cast to some other thing? So let's actually create another actor. So let's do it with our interaction actor itself. So let's go ahead and open it up. Not sure where we've used it. So let's just hit Ctrl F to find, and let's just find interaction. So we are basically nudging it. So what we're basically doing is we are again casting. So I have to just check where it is. So if we are overlapping, so that's what we are doing. So let's actually remove this logic and let's actually have the destroy logic itself. So remove this and remove this, or actually we could keep this. Now if you wanted to do it with your cast, so what you would have to do is you have to cast to interaction actor. If this fails, and then destroy it. And this for the most part will work. So let me just go ahead and drag that in. Forget about the C++ logic. And as you can see, this works. And even this works. However, one thing you might notice is, let's say in an actual game, obviously we'll have many such actors, not just an interaction and a pickup actor. So in that case, you will have to perform many casts, and casting is expensive for your computer's performance. So the way you get around this is, instead of casting multiple times, you could cast to an interface. And in Unreal Blueprint, there's actually a very elegant system implemented. We'll be talking about both the Blueprint and C++ versions of interfaces now. So in order to handle this problem, what we can do is we can actually create an interface. So I'll show you guys step by step to implement this exact logic using an interface. And we can actually have separate logic as well for both the interaction and the pickup actor. So head into your blueprints, right click, blueprints, blueprint interface, and let's just call this one, I don't know, destruct, I guess. Generally I have a convention of calling it BPI underscore. And we can call this one destruct pickup maybe. Alright. And we don't need anything for the input. But anyways, now the way you actually use this is for whichever actor that needs to be casted to. So for example, we are casting to our pickup and our interaction actor. So we would head into both of these, and under your class settings, under implemented interfaces, we can go ahead and implement BPI destruct. And do the same thing for the interaction actor. Head into class settings, BPI destruct. Basically, at the fundamental level, what this is doing is it is inheriting this interface along with actor. So basically your interface is also a class internally in C++. I will show you guys the C++ plus version, which will make things a little more clear. But instead of doing all this, what we can do is we can call destruct. Or I guess I called it pickup. So let's just call it destruct in general. To compile and save that. So we call this destruct. And now if I actually go ahead and press play, I mean nothing's gonna happen because although we have destruct, as you can see we can't really define the logic here. The way you define the logic is, for example, we can head into pickup, under interfaces, right click, implement event, and if I go ahead and just print a string and I can type in destructing pickup, and if I go ahead and destroy it, so destroy actor and target will be self, and I'll do the same for the interaction actor. So implement this event, whoops, paste this in, and we can do destructing whatever this is, interaction actor. So now you should be able to see that both of these different implementations are actually called. So if I press play, you see our pickup is destroyed, and if I actually click on this side, our interaction actor is also destroyed. So this is how you basically use interfaces instead of casting. Basically what it's doing internally, even though this looks like we got rid of casting, is instead of casting to our interaction actor, it casts to the interface, because interaction actor implements that interface, the cast is going to succeed and the function will be executed. The situation where the cast fails is automatically handled in the engine. Now how do you do the same exact thing in C++, you may ask? It's pretty simple actually. You just use the concept of multiple inheritance in C++. So tools, create a new C++ class, and over here what you have to do is select Unreal Interface, and we can just call this my interface for example and create the class. It should load up Visual Studio for you. So just reload that, and over here you should be able to see my interface.h and my interface.cpp. Basically this is where you would write the function definitions, and you can go ahead and define it in your various classes. So what you do is, for example, let's just have this function work for both the pickup and our whatever that was, interaction actor. So let's say we want this function to work for both of them. So let's go ahead and do that using an interface. We'll actually get rid of the C++ logic. So we'll get rid of that, and what we got to do is, first of all, since we are actually casting to the interface here, we can go ahead and include the header for that. So hash include over here, we can go, okay, we are including pickup already. So what we can go ahead and do is we can go ahead and include this interface in the pickup. So not after the generated, before the generated.h. And this is going to be my interface.h, and over here where you see public a actor, put in a comma and type in public I my interface. I is basically the prefix which is used for interfaces, just remember that. So my interface in the editor is going to correspond to I my interface in C++. So let's actually write our function. So let's call this void destruct maybe. And we can go ahead and add in our implementations. So we can right click first of all and make this one virtual. Right click quick actions, create a definition for it. This is just going to be like your default implementation. So now let's say we wanted to implement this function in another class. It's really simple to do it. Now that we have a virtual function here, we can head into our pickup.h, and over here along with this we can type in virtual void, and I don't know what the function was, so I'll just copy this over. Do the same thing in the pickup. And since we are actually overriding a base class method, what we can do is we can use the keyword override. And now if I go ahead and right click, quick actions, create a definition, head in here, and now let's say we do the same thing. So let's say we do ukismet system library print string this, and let's just say destroyed pickup from C++. And we need to include Kismet, of course, so let's just do that real quick. So let me just copy this over. So I'll just do this in the .h file. So now we can go ahead and actually destroy it. So we can say this destroy, or rather you can just call destroy. Alright, so we can go ahead and test this logic, but remember it's not going to work for our interaction actor because we again don't have another C++ class for it. So let's actually create that too. So new C++ class actor, let's just call it, for example, I don't know, cpp underscore interaction actor. Okay, so we'll create the class. And what we can do is we can again implement this. So in order to implement the interface, so I'll just stop the editor there. So in order to implement the interface, we'll do the same thing what we did for pickup. So if you head into the header here, copy this over, head into your interaction actor, implement the interface, and again we need the header file. So what we can do is we can do hash include whatever this is. So we have my interface.h, and then we can go ahead and implement this event by using virtual void destruct, which was our function name, and we are overriding a base class method, so override. And now we can go ahead and create the definition for it. And over here we can go ahead and print the string again. We can do that by simply including Kismet again. So let me just copy it over. Oops, I copied that. So head back into your pickup where we had included it, copy that, paste that back in, and let's just copy over the code from our pickup. You can have different code as well. I'm just showing you guys as an example on how to use it. So we'll change what we print. So destroyed interaction actor from CPP, and this should work. Also just head back into your CPP file, your CPP character, and where we cast it to the pickup, what you basically do is instead of casting to the pickup, you cast to the interface, since we inherited the interface. So it's going to be my interface, and make sure you actually include the header file. I've already done that. So somewhere over here we have included pickup.h already, and pickup.h already implements the interface, and we have included the header, so we don't really need it. So we can cast to this interface, and instead of destroying and printing, what we can do is we can utilize this. So we can have this separately. So we'll just do auto temp equals, I'm doing uppercase temp because we've already used lowercase temp here, and temp is going to be valid because the cast has succeeded. So what we can do is we can call destruct from here. Alright, now we can go ahead and run a debugger. Now if I head back into my character, connect this up, hit play, and you should see that we say destroyed pickup from CPP, but the interaction actor doesn't work. That's because we haven't actually set up the parent class over here. So go ahead and change that to CPP underscore interaction actor. And we could rename this as well BP interaction actor. Alright, so if I go ahead and press play, the pickup works. And as you can see, destroyed interaction actor from CPP. So that's pretty much it. That's how you use interfaces. And later on, we will also be seeing more practical examples. This was probably a good one, but still we'll actually implement this in our actual game. Now let's look at another case where you want to call blueprint functions from C++. Now this almost seems impossible because your C++ classes aren't actually aware of what blueprint classes exist, but actually it is. It's really simple too. So what you do, you could use it in any actor, any object, even in the interface if you want, but I'll just show you guys in the character by just printing something. So the way you actually call blueprint from C++ is like this. So you just write a normal function. So let's just call this void test bp func, let's say. And now what you got to do is you have to use the ufunction macro, and you can make this blueprint callable or not, but the specifier that you need is called BlueprintImplementableEvent. So now you can have the function declaration over here. You can actually have parameters too. So we can test that if you want. So int x, let's say. So now if I actually run this, you won't actually get a compiler error because Unreal automatically generates the definition for you and you can define it in Blueprint. So if I open up my BP character and under functions, under overrideable, if you just have a look, you will have test BP func, and as you can see, I can actually implement this over here, and we also got our input parameter. So we can just go ahead and print a string. We can either call this through Blueprint or we could even call this through C++. Let me show you guys by calling it through C++. So I'll do it on begin play. So what was our function called again? Test BP func. And you would see that this is actually implemented. So let's type in 100 for example, and this will work. And in the meantime, now I would like to show you guys one more thing that you can do. I just wanted to show you guys that yes, you can actually do this. You can actually implement it in Blueprint. But there is a possibility that you have some C++ code, but then you also have some Blueprint code which you want to be executed. So in that case, what you would do is you would use another type known as BlueprintNativeEvent. So we'll just copy over this function. And let's call this one test bp native func, and let's just have something else. For example, let's say we'll have a float. And for this actually what you need to do is you need to have another function called the implementation of this function. So that is going to be what you define in C++, and this is going to be your function name in Blueprint. So in order to explain what I mean, instead of implementable, type in native. Now if you compile this, you'll actually get an error. So what you're supposed to do is not create a definition. However, you are supposed to create an implementation for this. So the way you do it is you just copy over the signature, and instead of the same function name, you type in underscore implementation. Whoops. Implementation. So what you can do now is for the implementation, you can go ahead and create the definition. Head into your definition and we can go ahead and print something. So let's say we go ahead and print, for example, let's just say C++ implementation called, and we can close that in. And for a Blueprint implementation, we can set that up in Blueprint, no issues. So that should be it. Now you can go ahead and actually compile this once again. So apologies, I just made a few typos over here. So let me just copy implement over here. So implementation, and do the same in the CPP file as well. So underscore implementation, and now you should have no problems. So if we head into a BP character, and we can go ahead and override both of them. So test BP func, we can go ahead and print it. Actually, this is our blueprint implementation, and we called it from C++. So okay, we'll just go ahead and print it. We are calling it from C++, so what should be expected is 100 is going to be printed. Even the native event, you can call it from C++. I'll just do it over here. So first of all, let me implement that in Blueprint. So implement that, go ahead and just print that. That shouldn't be that hard. And just grab in our begin play here. And instead of, okay, let's just spawn this, let's keep all of this logic. And we can go ahead, and since we made it blueprint callable, whatever this was, and we'll just take in some random value. Now if I compile and if I go ahead and press play, as you can see, we get 100 as well as our 42343 printed. Now your obvious question is, why didn't the C++ implementation get called? So if I actually go ahead and delete this, and if I were to press play, now we would see our C++ implementation is called. But that's not really that useful, isn't it? Unless you just have some sort of a default implementation. So what you actually need to do in order to get the C++ version called is right click on the node and type in add call to parent function. Now it is going to call the C++ version. Now if I go ahead and press play, as you can see, it calls the C++ implementation, the blueprint implementation as well along with it. So that is basically how it works. Now if you were to do this, as you can see, we call the C++ function along with the parameters, of course, as well as the blueprint function. What you are calling here is actually the blueprint function. If it does not find an implementation, it is going to use the parent class version of the function. Remember that. So until now, we actually discussed everything which was foundational in order to actually start developing in C++. However, we do lack a little bit of knowledge regarding, the implementation of various data structures in Unreal. Now, apart from just using normal variables, you would use arrays and maps. There are others such as sets, linked lists and stuff, but for games, you would honestly just use arrays and maps most of the time. So in order to implement arrays in Unreal, so you don't use a static array. I mean, well, you could, but you don't use static arrays. You don't really use the std vector as well. You could use std vector, but you can't expose them to Blueprint and stuff, or you would have to write your own wrapper class. Now, if you guys don't know what I'm talking about, I'm basically referring to the standard template library in C++. But in Unreal, instead of std vector, we actually have another type known as template array or tarray. So the way you create that, so let's create a variable in C++. Let's do that in the public section. We're just doing it for demonstration. So I'll just make a UPROPERTY and make this one blueprint read write and edit anywhere. So edit anywhere, and over here what we can do is, instead of, let's say we have an array of integers. So the way you do it is you type in tarray, and as a template argument you would give the type as integer, and let's just call this rint array. Alright, now template array is actually internally something like your std vector. So if I actually control click on this, this is actually a class which implements it. And the methods which are associated with this are pretty simple. We will go ahead and check all of these. So similar to the std vector class in standard C++, tarray has a bunch of functions which gives us info about various things. So let's actually set some stuff up. So in order to initialize this array, so what we do basically, we can do it in the constructor or right here. We'll do it in the constructor just to keep things clean. So we'll call our int array equals, and within curly braces we can just give some values. So I'll just initialize it with some random values. Alright, so now let's go ahead and look at how to add stuff to this. So similar to add and emplace, we have methods for that over here as well. So we can type in our int array dot add, and now we can go ahead and add an item. So let's say for example I want to add 12. So our fifth element here, that is at index 4, is going to become 12. And this array is going to be resized since it is similar to an std vector. Now similarly also have emplace, so constructing an element in place basically dot emplace. This is like your emplace back function in std vector. So I'll just add in some random element over there. Now our array is going to be 23, 6, 43, 64, 12 and 4. Now what if I wanted to remove something? So I can type in our int array and I can remove either at index, so dot remove. I can either remove an element by using the remove function. So let's say I wanted to remove 23. I'm going to remove 23. And our int array, our int array dot remove at is going to let us remove something at a given index. So let's say I choose 0. So now it's going to remove 6 because we already removed 22. So 6 is our first index. So 6 is going to be removed. Alright, so we did all of these. But now what if we wanted to reserve some memory for our array? So what if you didn't want it to resize and search for memory? So even those functions are available. So let's call the reserve function before all of this. So our int array dot reserve, reserve, and we can, as we can see, we have 4 elements, 5, 6, and we removed 2, so we have 2. So we can reserve 4, but at max we have 6 elements, so let's reserve 6. So we can call that and stuff. So these are the most common ones that you'll use. You won't really use all the other methods, but again you can just refer the documentation if you really need it. Now we can go ahead and iterate through this array through a range based for loop, just like how you can with any of the STL data structures. So we can go ahead and do a for loop auto. We can just call this one element and we can pass in the array just like how you would pass an std vector. So our int array, and what we can do is we can go ahead and print it out by calling the print string function. So Kismet system library print string, you know the drill by now. So now in order to print an integer, you actually use this function which is a static member of the fstring class. So fstring from int is what you use, and you can go ahead and type in le here. Now remember, if you wanted to print a float, you would use this function known as sanitize float. Now it's going to cast it implicitly anyway, so even float works for this. And you also have other functions for converting between various data types. You could again have a look at either the fstring class, or you could go ahead and just search it up on the documentation. So if I actually head in over here, so we have our sanitize float here. We have to hex blob, from hex blob. We have various functions basically. So we have from int, as you can see, you can go through this class, see the return type and look at what the function does, and then you can go ahead and implement it accordingly. So now I'm in the editor. If I open up my BP character, and if I actually head back over here, we had made this blueprint read, right? So we should be able to access our int array. So if I just type in our int array, so as you can see, we get it just like any other blueprint variable, and since we initialized it in a constructor, we already have certain values. Now in begin play, if we go ahead and iterate through this, so I'll just do that. We'll not call this function anymore. Now we have an idea of what that is. So we have already set it up actually. So we've done it over here. So we're printing stuff in our begin play in C++. So we don't have to set it up actually. So if I go ahead and press play, as you can see, we have 4, 12, 64, 43 in reverse order, that is 43, 64, 12 and 4. And let's actually walk through the logic. So we have 23, 6, 43, 64, and we went ahead and added 12 and 4. So 12 and 4 should be our last elements, and we removed 23 and we removed 6. So our array should be 43, 64, 12 and 4. And if we go ahead and look at our logic here and our output, so we see that we get 43, 64, 12 and 4. So this is basically how you use the TArray class functions. So this is exactly the same as your std vector, but there are a couple differences in the function names. And most importantly, from a readability perspective, all of these functions use Pascal case, so it's readable compared to the standard C++ stuff, which uses underscores, which is not really that readable. So this is how you would iterate through an array. Obviously you could use a full length iterator, but there is no actual purpose to do it as per my experience. Anyways, let's head into the next part now and take a look at how else we can iterate through this through your standard C style for loop. So I won't be actually showing you guys the output since it's obvious that it's going to work. So you would just do something like for int I equals 0, I less than, now this is where we talk about another method in this class. So we do I less than r_int_array.num. This is similar to the size function in the standard template libraries std vector, and we can do I++. So we can just increment I. Could do I++ or I plus equals 1. Now instead of LE, since this is not a range based for loop, we can get our array and we can get the ith element. Now this is going to work exactly the same. Apart from arrays, the other data structure that you would use in a game is going to be maps. Well, there are linked lists and other data structures which you really won't use that very much in games. Even maps, to be honest, you just use it maybe a couple of times in your entire project. But anyways, in order to create a map in Unreal, basically you use the type tmap. So if I just copy over the UPROPERTY macro, and in the next line you can go ahead and create a map. And if you guys know about maps, basically it's just a key value pair. So for example, you can have two strings as key and value, and you could have something like a username password key value pair, something like that. So let's just create a simple one. Let's say we map a string to a float. So it's case sensitive, obviously. And we can call this one rmap. Now you can't just initialize a map like how you would initialize an array. So you would have to call the add or the emplace function multiple times. That's just how you would do it. So rint array, or rather rmap dot add, and what we can do is we can pass in the string and the float. So let's say pi and 3.14. Then we can go ahead and call add once again. So we'll just go ahead and do all of this in our begin play. So let's just find some other number, let's say num1 for example. Let's just grab in a random value. Now once that's done, you have other methods, but you aren't really going to be using them for anything. But I'll just show you guys how to iterate through this and how to retrieve the key and the value. So that's what you'll be using this most for. Now let's say you wanted to access an element though. You could do something like this. So let's just print out what the index num1 will contain. So copy this over And instead of our int array of I, what we can do is we can get our map of num1. Basically num1 is the key here, and basically by doing this you're getting the value of it. So in our case we mapped num1 to 43.4543, and if you want to iterate through this we can use a range based for loop here as well. So we could just say auto element, and we can pass in our map. And what we can do is we can get the element. So we'll print this. So we'll copy the code over once again. So we'll print both the key and the value. So let's just create a string variable temporarily. And the way you get the key of this, so each element in this map is going to be a key value pair. So LE is going to be a key value pair. What we can do is we can do dot key in order to get the key. And if we want the value, we can go ahead and do le.value. The way we'll do that here is we'll just append the string. So basically we'll concatenate the two strings. So what we can do is temp.append, and let's just put a colon just for visual purposes. And we can do temp.append, and since our value is going to be a float, we can do fstring sanitize float, and we can go ahead and get our value. So le.value, that is going to be a float. Now we can go ahead and rather than printing this, we can go ahead and print in temp. So we also learned how to concatenate strings on the way. So this is how you would iterate through this. This is how you would get a key of a given element in the map, and this is how you would get the value. Now remember, you cannot have two keys of the same value. So let's say I actually create another element with the key num1. It's going to throw an exception. You can't actually do that. So now we'll actually stop printing our array now that we are done with that. So if I go ahead and run a debugger now, since everything is set up now, if I go ahead and press play, you would see that we get pi 3.14 and num1 43.4543. And as you can see, we also get our 43.4543 that printed first because we had printed our map of num1. So basically the key here is num1, and we basically asked for the corresponding value. It is just as if you asked for our int array of 1. It's pretty much something like that. So basically instead of the index you would pass in the key. That's basically how you use this operator here. Now this is basically how you iterate through it. Now you could, do many other things with a map, but for the most part you'd just be using it to store key value pairs. Generally it's useful for having a track of game users and stuff like that. They're really very odd use cases for maps. You wouldn't really use it that often, so I'll leave this over here. Now when it comes to designing your game, once you're actually aware about all the things that we just discussed over here up until maps, in order to actually implement them in an appropriate and efficient manner, you would use the classes which the engine provides us. So we'll be going through some of the most important ones which will be used in all of the games, and there are other derived classes of it. The ones which I showed you guys in the flowchart previously when I showed the inheritance hierarchy, those are the ones that we will be discussing in detail. There are other classes. We'll just be brushing through few whichever are important, but if they're not, we are going to be just skipping through them. But if we ever use them in the last part of the course, we'll be having a look at them in depth once again. So now let's start talking about actors. Now at this beginning of this video, I actually talked a little bit about actors. Basically anything that can be placed in the level is an actor. So that definition still holds good, but it is incomplete. there is another thing which an actor can do, and that is it can tick. Now you guys have probably seen the tick function, so let's open up an actor actually. Let's create one because all of these have their own base classes. So let's create a pure actor in Blueprint. We'll do one in C++ as well pretty soon, or actually we probably have it. So let's call this one BP_A, let's say. I just created this for the sake of it. Now if I were to actually have a look over here, you would see that you have 3 tabs and the event graph is where you worked on for the most part, but we haven't actually gone in depth into all of these little details. So first let's actually go from the top. So what we have here is the class settings, and most of the times you'll just use it to implement an interface or change its base class, but other than that you aren't going to be using it. Now under class defaults you have a bunch of things which actually define what an actor actually can do. Now if you were to look at actor tick, you have several options. Start with tick enabled, tick interval, and you also have several other things. Now we did talk about this one, so I'll not be talking about that. But anyways, all of these are self-explanatory. And one thing which you won't see in any other type of blueprint other than actors is the replication tab. Basically, if you check this replicates tab, this actor will be eligible to be used in multiplayer. What I mean by that is that when you spawn this on the server, which we will get to when we talk about multiplayer, basically all your other clients can see it too. By clients, I'm referring to players in this context. And we have settings regarding that. Now these are just the flags. These are pretty self-explanatory, hidden in game and visible, stuff like that. And under the collision tab, these are things which we again talked about. But there are a couple more things which an actor provides us. The first one is your damage. Now if let's say you wanted this actor to be destroyed, so let's actually do that. Let's go ahead and create an object. So let's add in a model here. So let's say we add in a sphere. I don't know, maybe simulate physics on this, or let's leave it as is. What we can do is Unreal actually provides us with default logic to apply damage to this. So if I type in event damage, you see we get 3 of these nodes: point damage, radial damage, and any damage. So any damage is going to refer to all types of damages. Point damage is going to be your damage through a line trace or something generally. Radial damage is going to be something where you damage this actor through a grenade or something like that. So you would have a distance and stuff like that. So if I just press this, so you have your origin, so that's going to be where your grenade landed, for example. So it need not be a grenade, could be anything else. Just give an example. So from that point, if as you go further away, your damage is going to decrease, stuff like that. So let's just do event any damage. So any damage. What we can do is over here, we can go ahead and simply print this out rather. Just to demonstrate that this actually works. Now by default Unreal does not give you any health variable. You got to do that yourself. And one thing you might have noticed is this little icon over here at the top right hand side of any damage. Basically that property is called blueprint authority only. What it means is that you can only call this on the server. So you cannot call this on the clients. Obviously you don't want your players to be handling the damage and stuff. But anyways, let's actually go ahead and work on this logic. So when we left click, we do the line trace thingy. So let's bring up the line trace logic once again. So what we can do is we can line trace by channel, and we get our camera manager, get player camera manager, get the actor location. This is some stuff which we've already done. Then we get the forward vector and we multiply this by a certain value. So let's just convert this to a float and let's multiply this by, let's say, 50,000. we are going to add this together, and we can plug that into end and the start, and from our out hit we can go ahead and call apply damage. So there are multiple nodes: apply damage, apply point damage, and apply radial damage. We'll do apply point damage. You could just do apply damage, and base damage, let's just give it a value of 30, or just to keep things a little more interesting, so random float in range. So let's just say anything between 20 and 50 maybe. So it's just going to select a random number. And damaged actor is going to be the hit actor, obviously, and damage causer is going to be self. Damage type is something we won't be talking about, and hit info we could just pass in this whole hit result. So what we can do is, instead of doing this, we can recombine this, pass this in here, and we can go ahead and break this separately. So type in break and pass the hit actor once again to the damage actor, and we can collapse this as is. Hit from direction, basically that is going to be something which isn't really going to affect your damage, but once you know the damaged actor's location, you can actually find the direction towards it basically. So what we can do is, you can do something like this. So basically use this node called find unit direction. So unit direction, so get unit direction. So it's going to be from our start to our location, and this is going to be our hit from direction. So basically this is a position vector, and this is a position vector as well. So we can subtract it to get a vector joining those 2 points basically. And now it should compile. If you really don't want to use this, you can go ahead and split this, and this is going to work as well. It's just going to construct a vector in place. So we'll recombine that and use that. And if I go ahead and press play, nothing's gonna happen. But if I actually drag our BPA here, and if I go ahead and press play, so as you can see, we are applying some random amount of damage. So not sure why the lag exists, but anyways. Now once that's done, the next thing that an actor provides us, and also just one more note here. So now we're talking about the blueprint version of this. We'll also look at C++ stuff a bit later. There are a few things that I would like to go over in C++ as well. So the next thing is hit events. Now remember we had done the overlap for a character, so somewhere over here. So similar to that, you also have hit events. So you just type in event hit, and this is how you set up hit events. You also have hit events for each individual component. So if I click on the sphere, if I scroll down, I can actually do on component hit as well. That works too. Now other is going to be the actor which actually hit this, and other component is basically the component of the other actor which hit it. My component is going to be the component in this actor which actually hit the other actor, and hit location is the hit location, of course, and we also get a hit result. So way too much for what you need. So that's generally the reason why when I actually work on these things, I just create an interface myself, because generally you really don't require all of these things in order for your damage logic to work. Anyways, I'll show you guys how this is gonna work. So if I just go ahead and print this, and one handy node here is you can actually get this, and if you can type in get display name, and you're going to get the display name of the object. Basically, if my character bumps into this, so let me do that real quick. Okay, I can't, it's too high, so let's bring that down. So if I actually bump into this, as you can see, you get BP character. The reason it's printing it so many times is because we are in contact with it for quite some time. So when we are in contact and we are sliding on it, each frame it counts a new hit. Basically that's the reason it's happening. Alright, so the next thing that I would like to touch upon when it comes to actors is the construction script. So this is similar to your default constructor in C++. Now there is a way to actually get an equivalent of a parameterized constructor. I will get to that both in Blueprint and C++. But first let's work with this. So let's say I drag this in. Now every time I update this actor, the construction script is actually called. So let me just show you guys. So if I just go ahead and print string, and if I go ahead and move this actually, so first let me compile that, save it, and now if I head back, as you can see, every time I move it, it actually prints hello. Basically, every time you spawn this actor or you update this actor in the level, this construction script is called. At runtime, it's only going to be called when you actually spawn it. But over here in the editor, whenever you move it, it's going to be called each time. There is actually an option somewhere in the class settings. So run construction script on drag. So you can disable that if you don't want that to happen. So it's only going to call it once you finish placing it. I'll just leave it as is. Now if you want a parameterized constructor, basically let's say you wanted to set a variable. So let's call this, I don't know, maybe some float variable. And we'll make this of type float. Now if you want to actually set the value of this outside like a parameterized constructor, first select this variable and head into this option right there. Select instance editable and expose on spawn. Now what you've essentially done is you've basically exposed this when you actually call the spawn actor function. So if I just head into my character and spawn this on begin play, so I'll just leave this BP pickup and let me just do this actor instead. So BP underscore A. Now health points is not a parameter, so you can alt click that to delete the pin. Now as you can see, we can select some float. So I can set this to whatever I want. Now this is something which we touched upon. However, there is an equivalent of this in C++ as well. But it is a little more complicated than this. So if we actually head into our Visual Studio solution. Alright, so now that we are in C++, now let's actually test it out with our CPP underscore actor. So let's go ahead and spawn this from our character, or if we have anything else we could try that as well. So our interaction actor maybe. Yep, we could try that. So we can spawn our interaction actor. Now if we go ahead and head in here, inside our characters header file, so we can go ahead and include that as well. So hash include, and we can go ahead and include cpp interaction actor.h. Now let's actually create a function, or we can do it on begin play. So head into begin play. Now after we are done with this, or we can actually just remove this logic, we aren't really using this. The way you spawn actors in C++ is by calling the spawn actor function from world. So in order to get your world, you call this function known as getWorld. And from here, you can go ahead and call spawn actor. And this actually takes in a template argument. And this is going to be the type which this spawn actor function will return. So this is going to be a CPP interaction actor. And we could just spawn it like that. It's going to take in all the default parameters. You can actually set up subclasses and stuff. So let's say instead of CPP interaction actor, you wanted to spawn some derived class of it which is there in Blueprint. You could do that totally. So let's say I wanted to spawn BP interaction actor and not CPP interaction actor. So we can actually test that theory actually. So BP interaction actor spawned. I mean, the spelling doesn't really matter here. So let's delete whatever's there in the level. So BP interaction actor. So interaction actor. So I'll just go ahead and delete that. Now if I press play, I'm not really getting that. So what we can do, this is going to spawn your CPP interaction actor. But if we actually have a variable here which stores the exact class which we are spawning, So we can do that right there. So UPROPERTY, make this one edit anywhere, and make this one blueprint read write as well. Now what we can do is we can go ahead and pass this in. So the type which you use is T subclass of, and obviously we are looking for a derived class of ACPP interaction actor. So we'll just copy that over. So this is going to be prefixed with an A, and we'll call this one class to spawn, or rather we can call it actor to spawn. Now this will be available to us in our blueprint. Now one thing to remember, you have to make sure it is actually valid. So if our reference is valid here, so our subclass is basically, so if this class reference, so if actor to spawn is valid, only then we are actually going to be spawning this actor. And over here in the arguments list, you can go ahead and pass this in and paste this in, and you can also pass in a transform optionally, but I won't be doing that. Now let's actually pass in some parameters. So if you want to pass in a parameter using your deferred spawn actor, as I would call it, as the function is called, so we can actually do that with the same thing. So let's create a variable here which we would want to edit. So under the public section, we can go ahead and create a UPROPERTY. We don't need this to be blueprint read write or anything, so we can call this one int some variable. And the way you would set default values for this is if I go ahead and write the function again. So this is how you would spawn an actor. Here you would have what's going to be returned. So if I actually do auto temp equals spawn actor interaction actor, basically this temp will be of type ACPP interaction actor pointer. So a pointer to the spawned actor will be returned. Now what we can do is we can spawn another one actually. So we'll just do auto temp1 equals, we can just go ahead and copy this, and instead of this we can do spawn actor deferred. And just make sure you get the spelling right. So spawn actor deferred. So for this one we have to pass in the transform, so we can just write a constructor over here. So f transform, and that should compile. But once you call this function, the actor is actually not spawned. Now since we have a pointer to our actor, we can go ahead and call this function known as finish spawning. So if I type in finish spawning, this is going to actually complete the spawning process. Now you can just again pass in the default transform. So once this is done, our spawning would actually be complete. And in between this is where you can actually set your variables. So you don't have a parameterized constructor, but now we can go ahead and set our sum variable. So sum variable equals 100. Obviously temp1. And now what we can do is in our interaction actor, we can go ahead and just print it on begin play. So Kismet system library print string, and we can go ahead and continue with this and go ahead and print in f string from int, and we can pass in our value here. So sum variable is what we want, and that should be about it. Now if we go ahead and run a debugger here, everything should work as expected. Just make sure you close the editor before you actually build it. So now if we go ahead and press play, we shouldn't see any print strings, and this proves that our if check here is actually working. If we would have removed this if check, our engine would have crashed, since this actor to spawn class reference would be invalid. Anyways, we can set that since we have exposed it to Blueprint. So in our character, I assume, so this is in CPP character. So it's going to be inherited into BP character. And under your class defaults over here, you should be able to find your variable. So CPP character, under the third section here, actor to spawn, and we can select our BP interaction actor. If I go ahead and press play now, as you can see, we get two prints along with 10 and 100 for our spawned actors. Now the first one says 0 because in our first spawn actor function we actually didn't set any of the values. So this was our classic spawn actor. And in the second one we actually used the deferred spawn actor, which let us set the default values before calling the construction script. So this is basically how you would simulate a parameterized constructor in Unreal Engine in both Blueprint as well as C++. Now the next class that I would like to mention here is going to be the character class, and we have used that quite a bit. So if we just open up our BP character, for example, which is a character class, so we have inherited it from CPP character. Just to keep things clean, I'll just create a new character here, and let this just be called new character maybe. Now open it up. Now if I were to just look at the parent class, it says character, and character is actually a derived class of pawn. So basically every character is a pawn, and pawn is a derived class of actors. So when I'm talking about characters, I am collectively referring to both pawns and characters basically. Every character is going to be a pawn. Now the reason why I especially wanted to mention this, even though this is technically just a derived class of actor, and probably many other classes which I'll mention further are derived class of actors, is due to this character movement component. Now this allows you to do various things. Now if you were to just go ahead and look into these parameters, you can actually have a pretty basic idea on what you can do. At the beginning of the course, if you remember, I had mentioned that you can actually use functions to modify almost any of these values, not all, but most of these values at runtime. So for example, now let's just take our BP character for example, and let's go ahead and press play, and we know that we're using this. So we're walking forward, but what if this feels a little bit too fast for you? Now this is where our character movement component is going to help us. So the maximum speed of this character is actually set by a variable inside here. So if I just drag this in, and if I type in set max walk speed, as you can see, we are able to set some value over here. So I'll just do this on begin play. You could do it somewhere else as well. But let's say we wanted him to go only at 500. Default is 600 by the way. Now if I go ahead and press play, you see that he moves a little bit more slowly. Now if you feel this is a... Now one more thing is that the animation will also slow down along with his speed. So that's not something which you should really be seeing in this example. So we are moving slower. Let's say we wanted him to move a little more fast. So let's say we have 1000. We can go ahead and set the speed, and now we walk much faster. So stuff like this. And one more useful thing which the character movement component provides us is movement modes. So if I just type in movement mode and get movement mode, you can actually see this is an enumeration. We can just do a switch to see what are the enumerators here. As you can see, we have walking, nav mesh walking, which is for AI basically, falling, swimming, flying, and custom. Now there are various things you could even do with this. Apart from switching between them, you can actually set the movement mode. So for example, if I just change this to flying for example, and if I go ahead and press play, now you would notice that this behaves a little bit differently. Now if the movement mode is flying, if I go further, as you would see, he's actually floating in the air. So when you actually set this movement mode to flying, basically it also allows you to take vertical movement input. So apart from your move forward and backward, you could also do up and down. So let me actually do that. So where we have our add movement input, instead of forward, if I do up vector, so get actor up vector, if I just do something like this, and if I go ahead and hit W, as you can see, we can actually go up and down as well. So this is something cool which you could do. And there are a few functions which I would specifically like to talk about right now. And one of them is launch character. Launch character. So let's say I wanted to implement a jump pad or something. So let's just do it after a delay. So delay of about 2 seconds. And we can go ahead and give something for the launch velocity. Let's just give 10,000 maybe. Now if I go ahead and press play, as you can see, we were launched in the air. I mean, I just gave a really high value for the launch velocity. Let's say we give something like 3000 maybe. If I go ahead and press play, as you can see, we are launched in the air. So if you had something like a jump pad or something which you wanted to implement, this is a really cool way to do this. And the best part about all this is actually networked by default. Most of this logic, if you just run on the server, is just going to run well for multiplayer as well. So that's one thing. So launch character and stuff like that. There are actually many other functions which you would have access to. One way to actually take advantage of the context sensitive menu is if you just drag off of self, and if you can just head into character, you can actually look into various functions over here. This is what I find useful. You can apart from launch character, few more functions which I would like to go over are crouch. So if you set your movement mode to crouch and make sure you have you can crouch, so there should be an option somewhere here. So crouch should be under character movement, can crouch, make sure that is true, otherwise it's not gonna work. Make sure this is true. And if you go ahead and hit crouch, and one thing that I would like to show you guys is by setting this hidden in game to false. So let this be visible in the game. Now if I go ahead and take a look at this, as you can see, everything seems normal here. Let's actually just disable some of this logic. Alright, so I'll go ahead and crouch. So if I go ahead and crouch, as you can see, our capsule, whatever we had, is actually shrunk. This is basically your collision now. So let's say you couldn't pass under some things, now you can actually. So I'll just drag this a little bit below average character height. So let's say about this much. And now our walking speed is also very less, even though we set it to 1000 manually. Now as you can see, our collision is only up to the capsule. You can change the height, by the way. So if I just type in crouch, I should find crouch half height. You can actually increase that, no issues with that. And as you can see, now this has a separate max walk speed. So stuff like this is already implemented for you in the engine. Now all you have to do, if you really want to learn more, is just browse through this list. Just look at something which might be useful. So let's say you're doing multiplayer, you could have a look at this. Now this is not something which would really be that helpful, to be honest. But there may be a few settings which you might actually find helpful. Now there are many more things which you can do, and if you aren't able to actually write a certain mechanic using these, 9 out of 10 times you're just doing it wrong. It's just 1 out of maybe 10-20 times that the engine is actually deficient of features. So just like this, you could go ahead and explore this for yourself. All of those parameters which we saw in Blueprint are also accessible in C++. There is nothing special really. So for example, let's say I wanted to crouch, so I can just type in crouch. As you can see, the method crouch exists here as well. And not only that, if I want to access my character movement based functionality, there is actually a get function for it. So get character movement is the function name. So this is going to return a U character movement component pointer. So once we actually have access to that, so let's say auto temp2 equals, okay, it's in a different scope, so we can reuse temp. So auto temp equals get character movement, and now we can use this variable in order to just call our regular functions. So for example, if we want to change our movement mode, so we can type in whatever the function was over here. So movement mode. So set movement mode was the function name. Set movement mode. Now clearly it's not happy with us using this type, but fix for this pointer to incomplete class type. So the simple fix for this is to just look up the documentation for the header here. We don't have the character movement component header file, so we'll just paste that in our .h. And now if you go ahead and look at this, this should work. And now we get the options for the parameters. So for this, let's actually type in E movement mode. And we have move flying, for example. And then new custom mode, we can just set this to 0. So like this, you can set the movement mode in C++. So stuff like this is going to be analogous to both Blueprint as well as C++. However, note that some of these headers aren't actually included by default. So make sure you just go ahead and include them before you start working with them. So we are inside the BP player controller class, and we have dealt with this before, but going a little bit more deeper, player controllers or controllers in general are designed to handle input. So if we actually bring in an input binding, so for example, I just type in W on the keyboard. So what's going to happen is this input will actually be taken over our input bindings which we set up in our character. So if I just print a string, we'll actually not move, instead we'll be printing hello. So that's one thing to note. Other than that, the mouse interface has several important functions, such as show mouse cursor, enable click events, enable mouse over events, and stuff like that. All these are self-explanatory. One thing to note is that your pawn or your character obviously is going to be possessed by a player controller, and without a player controller you can not actually control your character. And all of these are actually set inside your game mode. So which player controller class you use is decided by your game mode class, which we will talk about soon. Game mode, game state, and player controller, all of these work in conjunction. A player controller is going to possess a pawn which you can control. Now once that's said, there are a few other functions which are important here, such as set input mode game only, which will take your game input basically. And when you have set input mode game and UI only, so in that case you are going to be able to interact with widgets as well as take player input in the game. Similarly, UI only is going to disable your keyboard input entirely. So stuff like that, functionality regarding input is available in your player controller. Despite using all of the above mentioned classes, it is technically impossible to set up a well playable game. So we have a few more classes which actually set up the whole framework to actually start developing the game logic itself. And those are game mode, game state, and the player state. Now the player state isn't that important, but the game mode and game state will provide you with all the functionality that you need in order for your gameplay logic to work. So we have already created a game mode. Know that every level will have one game mode and you have to set that. And the important part here is these classes. These can be set over here in the world settings. and a pawn class is as expected BP character. However, this can be changed at runtime, in the sense you can possess a different pawn. The default is going to remain the same, but you can call the possess function on your player controller. So let me actually show that. So let's say I'm on new character right now. So now I can't move or do anything. However, if I head into my game mode, and let's say after begin play, I just give a delay of few seconds. So delay, and I give, let's say, 3 seconds or 2 seconds, and I get my player controller. Now note, this is a single player game, so this works. Otherwise, anything that you do will be with respect to the server. Game mode in a multiplayer game will only exist on the server. That's one thing to note. So from here we can type in possess, and what we can do is we can just spawn a character. So where our player start is, we can just copy this over, let's say, or we can have a target point instead. So just type in target point, drag this in, and get the location. So we have something like 10 negative 11,420. So head into the game mode class, spawn actor, select BP character for example. So BP underscore character, and for the transform, negative 11,420, and we'll do 350 for the Z. And for the pawn, this is going to be the pawn which we will possess. Now if I go ahead and press play, wait for 2 seconds, and as you can see, we have possessed our BP character. So stuff like this you can easily set up in your game mode. So anything such as this which is handled on the server is done in the game mode. But the game mode isn't really limited to this. The game mode has several functions such as post login, and you also have other things such as on logout. So this is basically when you join the game in a multiplayer game. This is basically when you leave the game or you disconnect. So you'll still have all the references available to you. So that's where you'll use the game mode. So basically you'll use this for stuff which is core to your game logic. However, let's say you wanted to store something like a timer. Now the timer has to be in sync with everyone. So obviously it has to be on the server, but all your other players must be able to read it at least. So in that case you use a class known as GameState, which does the exact same thing. So if I just type in GameState, I'm going to use GameState base. GameState is basically GameState base with a few extra functions. So let's call this one BP underscore GameState. Oops, BP GameState. Open it up and ignore the viewport and stuff, doesn't really matter. And once you have this, over here we can have something like a match timer. So I'll create a new variable and call this one timer. So I'll make this of type integer. Over here we can go ahead and start the timer. So set timer by function name. We can go ahead and create a simple custom event here. So custom event, and we can go ahead and call this one, for example, timer increment. We can copy the name, paste that in. We want it to run every 1 second. We want it to be looping, and it has to run till the end of the game. So we can do timer plus plus. Now this value of timer over here can be read by your widgets and stuff like that. So there's actually a function which you can use for this. So let's do that in our widget. head into your UI, HUD, BP HUD, and where we have our stuff set up. So let's actually revert our character settings. So change the character to BP character. And over here for the spawn actor as well, we'll remove that for now. For now, we'll forget about it. Over here where we actually create our HUD, this is where we have our reference. So what we can do is we can actually create some more text here. So we can type in timer. So whoops, you can type in text, drag in some text here, maybe just increase the font a bit, and we can go ahead and have this to be light, anchor it to the top right hand side, and instead of this we can go ahead and set this to be whatever the timer is. So in our game state, every time this happens we have to update it. So what we can do is we can get our player controller here. We don't have a reference to it currently, so get player controller. We have to cast it to our BP player controller, cast to BP player controller. Now we can do this on begin play, and we can store a reference. In a multiplayer game this is not going to work obviously, so promote this to a variable and type in PC ref maybe for player controller ref. We can go ahead and update. Okay, we have a update health function. We can create an update timer function. So custom event, update timer, and this should work as is. So give the timer value to this. So type in timer, get a reference to your HUD, make sure this is variable, and we'll call this one timer text. Make sure you compile this. So timer text, set text, and we can set this to be whatever this timer reads. Obviously you can use format text and you can make this show minutes, seconds and stuff like that. So we have our timer, so we can do format text. So format text, we can have minutes, colon, seconds, something like this. So make this in curly braces, and our timer by 60 is going to be our minutes, and our timer mod 60 is going to be seconds. However, we also have one more parameter which we need to take care of, is if this value is less than 10, we want to append a 0 at the start. So rather convert this to a string first. So to string, and once we have the string, we can check if this is actually less than 10, and if it is less than 10, we can use a select instead. So select. So if it is true and if it's false, we need separate things. So if this is going to be greater than 10, which means this is going to be false, so we directly want to print that out. But let's say this is less than 10, we want to append a 0 here. So append, type in 0, and then we want to print the seconds. So some simple logic like this. Now we can go ahead and test this out. And if you were to look at the top right hand corner, it does not update because we have to set the game state as well. So if I just select BP underscore game state over here, and if I go ahead and press play, this should technically work, but it's not. So let's have a look. Under our BP game state, we have our player controller, and we are actually not calling the update function. So update timer. Now this function should work as normal. So the timer is going to be the value which we get over here. And on begin play, we can just set the timer to 0. So we'll just call the update timer function once. If I go ahead and press play, as you can see, our timer works and it increments every second. And if we just give it a little bit of time, so we have a runtime error here, we'll take care of that. So it says assess none trying to read property HUD. This error is in our player controller. The reason is when the game state is actually created, the player controller isn't actually yet created. So that's the reason why, or rather the player controller is created too, but the HUD is not yet created. So once this begin play is called, our HUD is created. So a simple fix for this is to get a validated get. And if it is valid, we are going to set this text and we shouldn't get any errors now. Anyways, as soon as we create this HUD, we can go ahead and update the timer. Whoops, update timer. And we can set it to 0. For our timer variable, we can actually set it to some higher value right now, so that we go ahead and test out the minutes part of it. So let's say set this to something like 65. It should start at 1 minute and 5 seconds. So 1 minute and 6 seconds, 7, 8, 9, 10, and our logic works properly. So for stuff like this, you would use the game state. Now the game mode is going to drive the actual logic itself behind your game functionality. But let's say you wanted to access all the players' information. You would do that through the player state class. So I'll just be vague about it. And if you right click in your game state and type get player array, you can actually get an array of player states. So you can actually loop through this in fact. And we can get stuff like the player name. So get player name. And for multiplayer games, you can get the unique net ID. So for these things, basically any details which all players need to have access of at all points of time, those are the things which your player state will hold. So that's about it basically. And one last class that we have left to talk about, which is important, is going to be our game instance. Then we can head into more advanced stuff and we can have an example project created. Unlike all the other classes which we spoke about till now, the game instance is kind of special. The game instance behaves very differently compared to all of these classes. So if I actually just open up my game mode for example, so we'll open up the main menu, first things first, maps and our main menu level. And now in my game mode, I'll just go ahead and print stuff. So I'll just print post login and I'll just type in logout maybe. So logout, and we can also have event destroyed, event end play. So we'll just go ahead and print stuff over here as well. So destroyed. I'm just doing this in the game mode, but this could be in any other class. And this is going to be end play. Alright. So if I go ahead and press play right now, and if I go ahead and press play, as you can see, our post login was called. And as soon as I close it, or rather I should switch levels, because if I close the game, the logic isn't really going to be executed. So I'll just type in open main menu level. As you can see, our logout function was called. So what I'm trying to say here is that this game mode class will not persist between levels. So once you log out, this game mode reference, whatever we have, is not going to persist. Now forget about the game mode reference. You can't even access it from anywhere else. So let me actually show you guys using the game instance. The special thing about the game instance is that when you switch levels, your game instance will still remain the same. When you open up the game, an instance of the game instance is created. So basically an object of type game instance is instantiated, and that is going to remain the same. So go to Blueprint class, type in game instance, And over here we can name this our game instance or RGI, anything you want. You could put a BP underscore, you can have a C++ class as well, but I don't really find the point in having a base class for this one. Now instead of begin play, you'll actually find events such as event init. So this is when your game actually starts. So if I go ahead and print this out, if I type in init, and if I head into my project settings, type in game instance, I can actually change this to BPRGI. If I press play, and if I press play again, or rather I'll head into the level and do it. If I press play, you'd notice that init isn't even printed here in the console, but it was printed way before everything else. That's why it's way down at the bottom over there. The reason is, even before the viewport was properly spawned and even before it started logging stuff, the event init was actually called. So the event init basically refers to when you start the game, not when you open up a level or not when you create something else. Now one thing which I want to show you guys is, I'll head into Blueprints, head into our game instance. I'm going to go ahead and call the getGameMode function, and I'll go ahead and promote this to a variable, and let's not name it, it's fine. And then what I want to do is, after a while, so let's say I switch from one level to the other. Now I'm going to go from this level to the main menu level. So I'll head into main menu level, and in the level blueprint here, I'll just access the game instance, get game instance, and we can cast it to BPRGI. This can always be a pure cast because it will never fail. And over here, get whatever the variable was called. I think it was called new variable 0. And we can go ahead and right click and convert this to a validated get. We can go ahead and print it, and we can say not valid, and this is going to be if it is valid, so valid. So if I go ahead, and I'll actually leave a bit of a delay here. Oops, delay. Let's say about a second, not more than that. So if I go ahead and head into my level again, and if I press play, as you can see, everything works normally. But I'm going to go ahead and type in open main menu level, and as you can see, I get not valid. So what this exactly means is that our game mode object, which was created when we loaded the level, because game mode objects are specific to a given level, as soon as we change the level, our BP game mode object was destroyed, and whatever game mode we had over here in our main menu level, so this is none, so it's just going to take game mode base. So that object was created. However, our game instance was still the same. So if I actually store a reference to the game instance somewhere else, that is still going to be completely valid throughout our game. So anything that is persistent between levels, you would have it set in the game instance. Generally, you would handle save games and stuff like that through the game instance, because even if a player exits a level, your save game logic and stuff should be able to work. And stuff like settings and all, those things are what you would put inside the game instance. Anything related to file handling will also be put in the game instance, and many other things regarding networking in general outside the game is going to be in the game instance. For example, a database, you could handle it through the other classes as well, but this is going to be the safest way, since this class is going to have itself instantiated throughout the program, in our case the game. And even when you actually exit the game, we have event shutdown rather than event destroyed or event end play. So if I just type in print string, and if I just exit, nothing's really going to happen because the viewport is already destroyed by the time the shutdown is called. So stuff like that. Let's say you had to close out some connections or something. You could do that through your event shutdown. Let's say you have a database or something like that. Just give an example. Anything that's persistent between levels, you would use the game instance. And one thing which should be obvious by now, but I wanted to mention, is each player in a multiplayer game will have his own game instance. And you cannot put in-game networking code in this. You can put networking code, but whatever's outside the game. If you have any in-game networking code, there is absolutely no reason to use the game instance. There is no use of calling RPCs through the game instance, since one player's game instance is in no way related to the other player's game instance. So if I actually start two instances of the game, let's say I have two players, even though they may be connected, your game instances will be different. So this player will have a different game instance, unlike the game state or the game mode where it's going to be common for one game. So let's say two players are connected, both of them will have one game mode and game state in common, which will be created on the server. But in a game like this, game instances will not be the same. So I should have done listen server or client. So standalone, in standalone, even game mode, game state and classes like that will be different, because in standalone you are not actually connected. But in any case, your game instances are never associated with each other. So with all the knowledge that you have, now you should be able to create an entirely complete single player game in Unreal Engine 5. Of course, you will need to refer the documentation at times. At times, you will need to mess around with stuff, but this much of knowledge should be enough for you to create a complete game. Completely functional game using all of Unreal's core features. However, I am aware that I didn't touch upon particle effects and audio, that is sounds. We will take a look at that when we actually create a practical game. I am not a VFX artist, nor am a sound design person personally. So that's the reason I didn't touch over them. But we will go over some resources which you can use, and I'll just talk about what I do to actually get hands on those resources. Now that's done, we can go ahead and start talking about plugins. Until now, we just implemented plugins which were there in the marketplace. Or if you have a plugin from GitHub or something, you would download it and maybe just paste it inside your project. So if I head in here, you just create a plugins folder and paste that in there. That's simple. But what if you wanted to create your own plugin? If you wanted to do that, and this topic is very less discussed, so not many people actually talk about this stuff. So you're in luck, because we are talking about this in detail now. So head into plugins, click on add, and you see many options. Now we won't be worrying about the editor plugins. Those are for more advanced users, and if you're in a state where you're creating editor plugins, I really don't know what is the reason for you to watch this course. So we won't be touching upon this. We'll be looking at third-party libraries later on. We'll be looking at blank content only and blueprint library. Now blueprint library is self-explanatory. It'll just contain a blueprint function library. Let's say you wanted some functions for a vector or something. Maybe you are implementing another data structure for which you want functions. You could have a blueprint library. And content only is basically the type of plugin where you'd have models and stuff like that without any code basically. But the one which we'll be doing is blank. And just give an author name. In my case, I'll give Gamium. And description, this is my first plugin. Well, it's not, but just for the sake of giving a description. And let's call this one test plugin. And go ahead and create it. So the plugin has been created and we have Visual Studio open. However, before we actually start working on it, I want to touch upon one topic, that is the build.cs file. Basically, everything you have in the engine is divided into modules. So the core functionality of the engine is like core UObject and engine. So now that you have actually created your plugin as well will have a build.cs file. If I actually open the folder over there, so plugins, test plugin, and if I head into source, test plugin, I have a build.cs file here, and I have content, binary, stuff like that. So what this basically is this plugin itself is actually a module in itself. So if I want to use this plugin in C++, let's say, I should go ahead and include that module. So I can do that by typing in a comma, and we can type in test plugin. This concept will be more clear once we actually implement a third-party library. When we implement a third-party library, you actually have a separate module for the library as well as your plugin as a whole. Basically, your plugin acts as a wrapper so that it can interface with Unreal Engine, because Unreal Standard API does differ a little bit compared to your standard C++, what you do generally. So you'd use the plugin as sort of a wrapper to, interconvert types. So let's say you wanted to convert all the std strings into f strings, which is there in Unreal. So stuff like that. So you'd have the plugin as a wrapper, and you'd interface that through the plugin inside the engine. So let's actually take a look at our plugin now that we have a basic idea of build.cs. In our editor, we already have our test plugin content folder open. We can work with this normally, but anything we created inside here will be actually packaged inside our plugin. So for example, let's create an actor class. So let's just call it some actor, and whoops, and we can make it do something, let's say. So for example, let's say we have some logic. So let's say every frame it just prints out something. Obviously you would have some more practical logic in here. So let me go ahead and type something. So let's say our actor is ticking, something like that. And we could go ahead and have C++ classes as well. So over here under tools, we can create new C++ class. I'm just showing you guys how to do it because we did go over the blueprint itself. So you know how to work with blueprint. It's just that you're creating it inside this directory, and I'll show you guys how to reuse it in another project. So head into tools, new C++ class, just like how you would. Let's say you wanted to create an interface. So I just took an example, and instead of my interface, we can call this one our plugin interface. And instead of beginner course, you can type in test plugin, because this is a separate module in itself. And now if I go ahead and create the class, you'd see that under our source, or rather under our plugins folder, so I'll just reload the solution. Under our plugins folder, under the source folder, now you should be able to see our interface. So now you can work with this just like how you would with another file. So this is how you would actually go about doing it. So now if I just go ahead and close this, and rather I'll just close the editor. And remember guys, make sure your plugin is enabled here. If you are not able to see it in the editor, make sure you enable this. So what you can do is, first of all, let's see if it actually builds successfully. So we'll just create a U function. So it's going to be a virtual function because we want to override it. So virtual void test function, and we can go ahead and leave it as is. We don't really require a default implementation, but we'll have one anyways. So right click, quick actions, and create a default implementation. And now we should be able to implement this interface. So let's make this a U function. So U function, U function. And just to make our job a little bit easier, we'll just make it a BlueprintImplementableEvent, so that we can actually just give the logic in Blueprint itself. So this works. And now if I just go ahead and build this, you should see that both this plugin as well as our whole project will be actually built. So it says Blueprint implementable events in interfaces must not be declared virtual. Let's just fix that. And now it should build as is. Just make sure you don't have a definition here because it will look for the definition in Blueprint. Now let's say I wanted to use this in another project. This is how you would go about doing this. So open up your editor, head into the plugin section again, and where you have your plugin over here under project other, click on package, just select a random folder. I'll just select my documents for example, and go ahead and package the plugin. It will take a little bit of time, but once that's done, you should be able to implement that in another project. So meanwhile, while this is actually compiling, we can go ahead and create another project. So open up your Epic Games launcher. So our packaging is actually complete before the launcher loaded up. So you can actually check it in our documents folder. So head into test plugin and you should be able to use this in your projects. And I'll show you guys how to do that. So just ignore that, head into library. Let's actually just launch the engine as is. And over here we can go ahead and just create a new project. So we'll just create a blank project, blank with nothing. I'll just create Blueprint, and for the project name, okay, we do have a C++ class, so it might actually want to rebuild stuff once again. So anyways, what we'll do is we can create a C++ project, call this one plugin test, and we can go ahead and create it. So I'll show you guys how to implement it both in Blueprint and C++. Anyways, now that we are actually in the process of creating it. So it should take a while, but eventually once the project is opened up, we should be able to import the plugin just like that. And I'll show you guys what steps you need to take in order to actually get this in the plugins list. Now our project has been created, so we are in a blank level. We'll just go ahead and create a new map, and let's just call this one some level. Open it up, save it, and make this the default. Project settings, maps and modes, make this the default. So that should be good. And if you open up your Visual Studio, which we will open later, we'll close this up and close the editor as well. And beginner course, will just minimize that for now. If I head into my file explorer, what I can do is I can copy this over, and where I have my other project, so I believe I created it under Unreal project, so plugin test. And what you want to do is you want to create a new folder called plugins and paste this over there. Now what I want you guys to do is right click, generate Visual Studio project files. So this is actually going to integrate it. And once you're done with that, if you want to use the plugin content in C++, all you have to do is head into source, plugin test, and under plugin test build.cs. We don't actually need to come here. Actually, this is for the plugin. What's the plugin using? So what you have to do is head into your plugin test the project, head into source, plugin test, build.cs, and over here, so I meant to come here. So over here, what I want you guys to do is where we have our modules, I want you guys to add test plugin. Just don't get confused. Plugin test is our Unreal project name and test plugin is our plugin name. And now I'll show you guys how to implement it. So we can go ahead and build this once again. So we'll close everything up and we'll just generate the Visual Studio project files once again. And we'll close our beginner course. We'll open it up and we'll just create one C++ class and maybe a Blueprint class. So we'll do Blueprint first since we are opening the editor anyways. So we have some level, and if we actually go ahead and create something. So let me just create an actor. If I head into all classes and if I type in, so I'm not sure what I called it, so we can head into plugins and check test plugin content some actor. So some actor, as you can see, we get some actor. Now if you're not getting this, it simply means that you haven't enabled it in your plugins. So under installed other, you should have test plugin and you should have your author name and stuff like that. So make sure you have this enabled over here. And now if I go ahead and drag this in the world and if I press play, as you can see, our code which we had in our actor is now working in the other project. Similarly, we can use the interface as well. So over here under class settings, implemented interfaces, we can go ahead and look for our interface. I think we called it our plugin interface. And we have our test function which we can implement, and we can go ahead and tell something. So you could just say test function called. In order to implement this, however, we would require C++ since we actually didn't make this blueprint callable. However, we can still choose to edit it in the source over there. So if I just head into our source and if I actually go ahead and edit the CPP file, we can actually rather in the plugins folder, test plugin, if I head into the source folder and edit the CPP file, or rather the .h file, and add the blueprint callable specifier, I would still be able to use this over here. But anyways, we will implement it in some class which we create here. So I'll just go ahead and close Visual Studio here, and I'll go ahead and create something. So we can create a new C++ class of type actor. We are able to implement this, but we can't call it. That's the reason we are actually doing it. So we'll just call it my actor for now and go ahead and create it. So live coding should do its thing. So our file should in fact open up in a new window right now, and go ahead and just don't mind it opened up in a separate window. And now we can feel free to go ahead and include our interface. Just gone ahead and reopened the solution file here, and now inside myactor.h, since we included the module in the build.cs file, we should simply be able to include our plugin interface.h. Now you should be simply able to inherit the interface by using public our plugin interface, and now we have successfully inherited the interface. Now since this was a Blueprint implementable event, you can just go ahead and use it in Blueprint itself. And just to make things a bit convenient for us, we can head into our plugin interface.h file under the plugins folder, and we can add in the blueprint callable flag. So now we can go ahead and actually call it from the blueprint. So we can go ahead and run a debugger now. So this is how you implement it in C++. My main intention here was to show how to include the header file rather than using the interface. That is something which we already covered. So wait for the editor to load. And once the editor is loaded in, what we can do is we can go ahead and create a new blueprint class, and we can remove this actor first of all, otherwise it'll keep printing our actor is sticking. So go ahead, select actor, we'll leave this at new blueprint 1, add this, and under the parent class, or we could have done it over there itself, we'll select my actor, and now again we have our test function, and we can again go ahead and implement our event. So we can go ahead and print something, let's say test function called. Or we could have gone ahead and inherited my actor instead of some actor here, but then again you would have to change some other stuff, so we'll just redo this. And now if I go ahead and press play, nothing's gonna happen. Head into your level blueprint, and for example just go ahead and get a reference to it. And now if I just call in test function message, this is what we want. And now if I go ahead and press play, you see we get test function called. So this is basically how you do it, guys. So this is basically how you would use a plugin which you made and implement it in another project. And as you guys saw, you can absolutely feel free to edit the plugin contents once you have pasted it in this plugin folder. Now let's move on to third-party libraries. Now there is one thing to understand before we actually head into implementing them, and that is that there are differences between your standard C++ API and the Unreal C++ API. A very simple example would be the difference between std string and fstring. So in Unreal you'd use fstring, whereas in standard C++ you'd generally use std string. Now interconverting between them is really easy. So if you want to implement a third-party library, the way you would do it is you would build your third-party library inside of a plugin. So basically you would put it in a separate folder, and I will show you guys the procedure, so nothing to worry about that. And the Unreal plugin which you will create will act as a wrapper to kind of, interface between the standard C++ and Unreal C++ API. So the way you do it is, again, create a new plugin first. Select this third-party library template because it has most of the important things that you would need in order to actually set it up. So again, I'll just put Gamium for the author, and I'll just call it some third-party library plugin, and over here we can just call this one tpl underscore plugin or something like that. So third-party library plugin. So go ahead and create it. So now this dialog box should appear over here, or rather message box, and we'll just click open or OK. So basically that was just some code which was written in the example library. Now over here we shall not be using their library. So they have actually provided us with a library which we can use as a reference. So if I head into plugins, tpl plugin, source, you see there are two folders here. Now third party is the folder where you'll have your third party library, and tpl plugin is the folder where you would have your plugin content, and anything under this folder would be edited in your project solution file, and I'll show you guys what I mean. So right now head into third party plugin library. So what we can do is over here, as you can see, there is an example library. Now whichever file says example library dot something, that is basically your actual third-party library. So in order to implement our own third-party library, we can go ahead and delete whatever they have put over here. So we don't need any of this. So this is just an example, and what they have done is they've used a DLL, but I'll be showing you guys how to implement a static library and a DLL separately. So we'll do a static one first. So I'll just go ahead and delete all of this. Now what we are left with is a blank folder with just the build.cs file. So what you want to do now is open up Visual Studio, and over here you can go ahead and create a new project of type static library, and click next, and we'll just call this, I don't know, test third party library or something. So test third party library. So we'll create it under a G repositories, or rather we'll just select our solution folder. So we'll go ahead and select our beginner course, head into the plugins folder, tpl plugin, source, third party tpl plugin library, select this folder, and what we can do here is we can check place solution and project in the same directory. So we would have all those project files as they appeared in the example. So go ahead and press create. Now you should see that our library is actually created. So if I go ahead and open up this folder over here, as you see, this folder has been created. It's not necessary that you have it over here. So you can just go ahead, cut this and paste this over here. And you can go ahead and delete this folder. So it's open in Visual Studio. So I'll just close everything. So I'll just save it. So we can just cut this and paste it over here. So we shouldn't have opened that. So we'll just replace it as of now. Nothing should happen. Now once we're done with this, we can open up our build.cs file. And over here you would notice that we have a bunch of stuff which I seriously don't expect you to understand. Basically these are for Linux and Mac, so you can just go ahead and delete these. I'm not going to be showing how to work with .so files and stuff, so I'm not really a Linux guy, so we'll just be working with our Windows library. So we'll not do the DLL now, so I'll just comment this out. We'll do the DLL a bit later. And what this is basically our library directory and the library file itself. Now example library.lib was the file which they had created. So whatever example library they had, that file was named example library.lib. But ours isn't yet here. So we can just go ahead and add in some sample code so that we can actually create it. So head in here, change the configuration to release first things first, and head into source files, add a new item, and over here you can go ahead and create a .h file because we will need some sort of a header to include it. So we can just type in test class. We'll just create a class. So test class.h. Maybe you can create some static method inside. And over here, we can actually move this over to the header file section. Right click on source file, add new item, head of source cpp file, and we can call this one testclass.cpp. And once both of these files are open, over here we can just start writing a class. So we can call this test class, and under the public section we can simply have a method. So under public, and under private we can have a string variable. So std string, and we need to include string obviously. So hash include string. So we have our std string. We'll just create a variable called maybe test string, and we can write a constructor here to just initialize it. So what we can do is we can go ahead and create a test class and write the definition for the constructor. The reason I'm not doing it in line over here is because I want to show you guys that the lib file is actually doing something. So if we have the definition right here, so we wouldn't really need the library file. Now I can go ahead and create the definition for it. And what we can do now is under this, we can go ahead and just initialize our string. So we can say test string equals, this is some test string. Doesn't really matter what you put in there. And we can just have a method. So we can have std string get name maybe. Now this is going to return that string basically. So we can go ahead and test that. So we can go ahead and return test string. Now this should be about it for this. So before you go ahead and build it, just set up this pch.h file and stuff. So go ahead over here, instead of testclass.h, just include this pch.h. And what you'd want to do is you'd want to come here and just include your testclass.h over here. So now this should compile. So if I go ahead and press build, make sure it's in release configuration and it should work. So now if you were to head into your TPL plugin library folder, now under this x64 folder which has been created, you should find your .lib file. Don't worry about all these other files, just go ahead and copy this file name, which will be the same as your library file's name, your library's name. So test third party library.lib, that is the file which we want to include. So now that we are done with this, now we should in theory be able to wrap this using our TPL plugin. Now this is actually the code for our Unreal plugin. Now inside this we'll actually be writing some code in order to just wrap this class, whatever we wrote over there. So go ahead and head into your beginner course solution, that is your main project solution. And now if you head into your test plugin, or rather the one which you created now, so TPL plugin, source, TPL plugin, and we should be able to actually work with this. So we'll just do it inside this header file. As I showed you for the previous plugin, if you want to add in more files and stuff, you can do it through the project, or we can actually do that since we have our solution open anyways, our Unreal project. So over here we can go ahead into tools, add a new C++ class. We don't really require an actor, so we'll create an object. So object, create it, and we'll call this one wrapper object. And this will just be under my TPL plugin. So we can close our solution since it will open it up once again and create the class. Now if you were to open up your solution, you should see a wrapper object.cpp and stuff. And one more thing, this is something which you really don't need. So now you can just feel free to head into this function here and just delete all this code. And over here as well, you can go ahead and just delete this. Make sure you just have the functions. And for this one, basically we don't have our example library.h. We instead have our test class.h. So this will work. We don't need it here, so we aren't going to use it. So you can just leave the rest of it as is. And now if we were to continue now. But now if I were to go ahead and build this, so if I just go ahead and hit build. Now wait for it. And now you would notice you actually get errors even though you didn't have any code. The reason is, well, we don't actually have our UObject module. If you get any errors like this, cannot open include file, and it's something like this, basically it's the same thing. You haven't included the module. So what you have to do is head into your TPL plugin. Under source, you should find your TPL plugin build.cs file, and if you were to recall your main build.cs file, that is your project's build.cs file. So if I head into source, beginner course build.cs, you see there is a module known as core UObject, and this isn't there in the TPL plugin build.cs. So just go ahead and include that, and now it should build successfully. So if I just click on build, now this should build with absolutely no problems. So now we can go about implementing a wrapper object. Basically we are trying to get our test class to work with our actual code here. So I'll just do it under the public section. So whenever this UObject, that is UWrapper object, will be instantiated, I want our actual third party library object to be instantiated as well. So we can go ahead and type in test class obj equals, we had a default constructor, so we'll just call that. And the reason we get errors is because we haven't included the header, so we can get TPL plugin library, so library, and we call it test class.h. Now we shouldn't get that error. Now we should be able to create our object. And now we can go about writing our functions for it. So the only difference in the main with the standard C++ API and Unreal's API in our example is that we used std string over there, but we want to use f string. So we can write a U function for it. So U function, we can just call it getName, and the return type is going to be fstring, of course. And we can create a definition for it. Create a definition, open it up, and inside the fstring constructor we can get our object obj.getName.cstr. So cstr. So this is how we can just convert it. Now this is something related to the conversion. You can just look into the documentation or the forum. So this is how we would go about converting it. And we'll make this one blueprint callable as well, just so that we can test it in Blueprint. And now successfully we have translated our standard C++ function in our third-party library, and this is now usable in Unreal. So if I just go ahead and run a debugger here, inside our project now we can ignore this and we can head into content, and we'll just do it under blueprints. Go ahead, create a new blueprint class, and this will be of type wrapper object. So we don't find it, and we forgot to make this blueprintable once again. No issues. We can make this blueprintable, and you can make it blueprint type as well if you wish. So we can go ahead and restart the editor now. And now under content, blueprints, if I right click, create a blueprint class and type in wrapper object, we should get a wrapper object. And we can go ahead and just call it bp_wrapper. So this is our wrapper class basically. Now if I were to actually go ahead and call the function, we can actually do that. So we'll instantiate the object and call it. So our function was called getName. Oops, getName. Call function getName. Target is wrapper object, and we get a string. So we can go ahead and test this method out. So in our level blueprint, we'll just construct an object. So we can ignore this. We can go ahead and construct object from class, and we can construct our wrapper object. So BP wrapper. We didn't really need it, to be honest, but anyways, we can go ahead and call the function getName once it's successfully constructed, and we can print strings so that we can check if it works. So now if I go ahead and press play, as you would see, I get this is some test string. And this is exactly what we put in our third-party library. So if I head into third-party, test class.cpp, as you can see, we had our std string, and we actually called this method through our wrapper class. So this is basically how you implement a third-party static library. So now let's get to DLLs. Now working with DLLs is going to be a little more tedious, and if you were to take my opinion, in Unreal Engine at least, it's really not worth the hassle to work with DLLs. I always prefer just working with static libraries or any Unreal native plugins. But anyways, I'll just show you guys with the example itself. The procedure is the same. Head into plugins, click on add third-party library, and we'll just call this Gamium, and plugin name, let's just call it DLL test. So we're going to create the plugin, and it should take us into Visual Studio. So we get this message box here, so which is from the functions given in the DLL. So just head into your Solution Explorer, and under your plugins, you should find your DLL test plugin. And if you open up your third-party folder, you should be able to see the code. Now we'll just be modifying it in here. So we'll just call a function. So example library function, let's just head into the definition. They're just creating a message box. Similarly, we could just have our own function. The important bit over here is the export part. So basically you have this macro which is going to export the function. Now the usage of classes isn't really covered here, so I'm just going to do that instead of writing my own function. Obviously, you can implement the same thing with your own DLL. But remember the changes to the build.cs files which you have to make. So under plugins, DLL test, source, DLL test, or rather third party, DLL test library. And in this build.cs file, again you will probably have to change a few parts. You can remove this if you're working only on Windows. So this is over here, just change the file name to whatever your DLL is. And over here for the lib file as well, just make sure you change it to whatever your file name is. Even here as well, just do those changes and you should be good to go. And the addition of modules will still remain the same. So you will still have to include core U object and stuff. We'll do that, so not to worry. So if you want to actually export a class, you would have to do it right here in the .h file. You can have the definition separately in the CPP file, but I'll show you guys how to actually do it. So the way you do it for classes is a bit different. For functions, you can follow this example and move on. But over here, let's say I want a class, so I can do example library export. Now I am assuming we are developing for Windows, so I'll just go ahead and delete all these elifs. So I won't be having any of that, so I'll only have the macro declared, even over here as well. So I'll just go ahead and remove all of this, and I'm just assuming that everything is for Windows. So with that assumption, let's continue. Now if you want a class, we can go ahead and declare it. And one more thing, in your .h file as well, make sure you just have this macro. If you want to work with class, if you're working only with functions, you don't really require. So now what you want to do is, let's just call this one test class. And over here we can go ahead and have some methods. So let's say int get num or something, and we can have a variable as well. So under private we can have int num, and for this we can go ahead and provide a definition for it. And one more thing, for each definitions, so for your class definition here, make sure you put in export. For methods, you would put in import here and export in the definition. But since your class definition is here itself, make sure you have example library export or whatever your library name is. And we can just go ahead and return num. So what we can do is we can write, we can just set this to some value. What we can do here is we can write a constructor actually. So this class is called test class, and we'll just write it in line over here. What we can do is num equals, can grab in a random number between 0 and 99. So this should work as expected, and then our get num function should work as well. Now once you're done with this, our DLL's example library should work. So what we can do is we can go ahead and before building actually we can create a new file. So head into your editor and we can close the solution for now. We can build it and close it. So we have live coding enabled, just ignore that. So build it. So this should build successfully. Now if I just head back into my project, beginner course, and if I head into my UProject file here, once it loads up, you would see the message box as is. If you don't want that, I'll just show you guys how to disable that. If you don't want the message box, head into your DLL test, third party library or whatever, or rather source DLL test, private, DLL test.cpp. This is the file where it's actually given the function definition. So just go ahead, open that and edit the file to remove the function definition. So let it open up. And over here, what you would want to do is you would want to remove this function definition. So you can remove this and then the message box isn't going to pop up. You can remove this as well, but that's not going to be called unless it fails, so not to worry. And even this path as well. So if you do require to change it, you will have to change it. If you're implementing your own, make sure you account for all of these. So heading back, go to tools, new C++ class, all classes, object. We'll go ahead and or we can do actor just to keep things a little more interesting. So we can go ahead and create an actor, click on next, my actor, make it under DLL test, and we can go ahead and create the class. So this should open up our solution file, and don't mind if live coding fails, we'll just close and reopen that, not to worry. We can go ahead and open the solution file once again. So we'll go ahead and close this. And once the solution is open, we should be able to go ahead and find our file here. So under DLL test, private DLL test.cpp, or rather myactor.cpp, and we should find all our function definitions. And not to worry if you get so many errors, it's just to do with the build.cs file once again. It's kinda dumb, but it's something which you have to deal with. So over here, make sure you include engine and make sure you include core UObject. Make sure you have these two modules. If you want to access Kismet and stuff like that, you'll need engine. If you want to access your UObject type, you'll need core UObject. So if you don't have an idea of what contains what, you can go ahead and have a look at the engine module in the documentation. Everything is given over there. Otherwise, you could just follow along. So head into, now it will build. IntelliSense isn't refreshed yet. So head into your myactor.h and we can go ahead and include a header. So you can go #include DLL underscore test library. And our header is called example library.h. Of course, if you have your own header, that's going to replace this. And we shouldn't get any sort of errors here. And over here, we can just write a function. We'll just do it inline. So UFUNCTION, make this one blueprint callable to make things simple. So blueprint callable, and we can call this one void run DLL function. So I'm not really bothered about the name too much. And now what I can do is I can go ahead and write a definition for it. We'll just do it over here. So from our DLL, we can go ahead and grab it. So the function which we had was called getNum. So we can go ahead and instantiate an object to that class. So our class was called test class. We'll just call it obj. And we can go ahead and call the function. So we'll do it in the next line. And obj.getNum. We can go ahead and print this by typing in ukismet system library print string, and we can just pass in a this pointer, and we can do f string. So it's an integer, so from int, and this should be good to go. Now what we can do is we can include Kismet because we don't have the print string function here. So #include Kismet system library.h. Now this should build successfully, assuming we haven't made any mistakes here. Now it's giving us an error. It says test class type redefinition. A simple fix would be just to do pragma once. So pragma once, and this should build now with no problems. Now we can go ahead and open up the editor. So once we open it up, we won't get the message box now because we had disabled that. And over here, if we just head into a level blueprint, for example, and make sure under the play mode, just change this to standalone because we had it set to multiply, we can go ahead and construct an object from class, or rather we can do spawn actor since it's an actor. So my actor, my actor is what it was called, and we can just have a default transform. It doesn't really have anything, and from this we can go ahead, and I'm not sure what the function was called, so let me just have a look. So our function in my actor was called run DLL function, so we can go ahead and call that. So run DLL function. So in theory we should get stuff printed over here, but this will probably not work now because we haven't actually compiled our library itself, which is kind of stupid. So head into DLL test. So third party DLL test library, example library.solution, and now just click OK. And now what you would want to do over here is go ahead and select your release configuration and go ahead and build it. Oh, and yeah, make sure you close the editor when doing it. That was the error which we got right there. Now if you were to go ahead and open up your beginner course U project, once that's loaded in, now you should be able to call the function and it should work as expected. So in your level blueprint where you called it, run DLL function, and we can go ahead and click on selected viewport, and as you can see we got 95. If I go ahead and play, we get 66, and we keep getting random numbers every time. So our DLL actually worked. But if you do want to implement your own, it is going to be a little more complicated than this. Even with just including the one which was provided to us with Unreal, it was a big hassle. So make sure you guys avoid using DLLs. I prefer using static libraries, or I restrict myself to those for Unreal at least. So that's it, I guess, about third-party libraries. We can go ahead and talk about multiplayer now. It's going to get fun, guys. Now let's talk about networking in Unreal Engine. So networking basically in Unreal revolves around star topology, basically your server client model. So basically you have one player or a dedicated machine which acts as a host, which we call the server, and you have all the other players which are clients. Now there are two types of servers in Unreal Engine. One is a listen server and another one is a dedicated server. In a listen server, the server itself acts as a client as well as the server, that is the host, whereas in a dedicated server, the server only acts as a host and does not have a player controller. So these are the two types of servers, and basically any data that has to be passed through a network, as you can see in this diagram here, there is no connection, there is no direct connection between two clients. Always, if data has to be passed from client 1 to client 2 or vice versa, it has to be routed through the server. So that is one thing to note when it comes to networking in Unreal Engine. Now there are many questions which might arise regarding the efficiency of this and stuff, but most games these days work based on this principle, and it is in fact very robustly implemented, and we will be talking about all the features of Unreal networking soon. I've brought up my main menu level here, and I just want to demonstrate how you're going to join two standalone games, that is two games on separate computers, into one. So if you aren't familiar, net mode will basically let you choose between the types of servers which I talked about. Play as client is your dedicated server basically, and play as listen server is going to be a server which is also a player along with the other clients. Play standalone will basically mean two separate games, and that's what we will be doing. Now what if you wanted to connect between these two? So we'll be using the game instance for it. So open up your BP game instance. Now I am recording this a little bit later, so that's the reason you may see a few things which you haven't seen. So BP RGI, and we can just set up a couple of custom events. We'll first of all delete all of these. We don't need these. So I'm not sure, we may have broken some reference. Doesn't matter. So we'll just go ahead and fix that. So we'll just delete that. And now if I head into RGI and I'll create a custom event. Now basically connecting to a single game is handled by something known as a session. So every time your players are connected, Unreal actually has something known as a session stored internally. We aren't going to be diving into the C++ part of this. We'll just be doing this in Blueprint. But please note that if you want finer control over these properties, you would want to work with C++. So session is basically what is going to allow your players to connect. So let's go ahead and create a session. So what we can do is we can do something like create lobby would be inappropriate. I'll just call this one create session. And we'll go ahead and type in create session. And as you see, there is an async task over here. And if you guys aren't familiar with this clock symbol and a node like this, this is an async task. And public connections, we'll just set that to 2 for example. So 2 players. And player controller, this is for listen servers. If you have a dedicated server, you don't have to pass in the player controller. But in our case, we are passing it in. So we are going to use the function get player controller. And then use LAN is set to false. You could do it if you wish. And upon success, what you can do is you can go ahead and load a level. So open level. And we can go ahead and open our beginner course level. Alright. And then what we can do is we can go ahead and create a function to join session. Or I would call this one create match so that it sounds a little more familiar. Join match. So what we can do is we can first of all find sessions. So type in find sessions. These are the only few functions which are there in this library, so that's the reason I'm not really going over them that much. So we can get the player controller, and what we can do is max results, you can just set it to something like 100. And we are going to check if it's a failure or if it's a success. So what we can do is first of all we can get the length. So if it's a failure, we're just going to print something. So we could say failed to join a match. And what we can do is we can get the length. And if it is greater than 0, we'll go ahead and just join the first session. Obviously, you can have your own logic here. So each session is going to be one hosted game, basically. So let's say there are three members in this array, or three elements in this array. What it basically means is there are 3 people hosting a match right now. That's what it means. So now what I can do is I can grab the results and I can get a copy of the first one if the length is greater than 0, and I can go ahead and type in join session. Alright, and here we'll again need to pass in the player controller. And note that you can only run these session functions either on the player controller or in the game instance. You cannot run them on other blueprints. It is simply going to fail. Now, once that's done, let's say we have no sessions. We can go ahead and create a match. So create match. And on success, we don't need to do anything. Engine will handle it for us. Over here you can have something like a progress bar or something. Until on success is called, you could probably have some throbber or something like that to show that it's loading. Same over here. So this should be good. And something very simple which you could do is inside the main menu. So on clicked, what I can do is instead of opening it, I can grab a reference to my game instance. So I can type in get game instance, which is a static function, and I can cast it to BPRGI. This will always succeed. I'll just cast it over here. I'm not going to bother storing a reference to it as of now. And I can go ahead and, or actually I'll just do it the right way. So I'll just call this one main GI. You could call it anything. It's just a reference to our game instance. And once we have that, we can go ahead and use it, and we can go ahead and join match. So join match. Now that that's done, if I go ahead and press play, here, as you can see, nothing is really happening. But after a while, we go ahead and join this session. Basically, we load up the map. Now that we have actually created a session, and if I press play on the other game here, and if I just wait for a while, so you would want to disable the input during this time, but anyways, for now we'll just not do anything. You would see that you actually don't join the session. The reason is you actually need to be listening for incoming connections in order to actually be able to join the game, and I'll show you guys how to do that. Over here where you have open level, make sure you just put in listen under the options. So make sure you do that before you actually do it. And one more thing, plain editor is crashing my game for some reason. So I'm just going to go ahead and I'm going to run this standalone. So standalone game and standalone. So play standalone, and I'll play this as a standalone game. So I'm not really sure why the issue is happening, but this is one way I can test it. So if I press play on one of them, and if I go ahead and wait, so we should land inside a session. As expected, we are in the level and we are able to do stuff. Now I'll just go ahead and click on play here. In theory, if everything is set, we should in theory land in the same map. So as you can see, post login was called on the server, and if I were to notice, my client has successfully connected over here. So as you can see, I'm able to play the game like this. So this is basically how you connect to clients. Now let's actually talk about how to set up stuff in multiplayer, guys. Okay then, so if we want to work with multiplayer, what we can go ahead and do is we'll start with a new level, because if I go ahead and press play with 2 players here, and if I actually close the game, you see we'll get a few runtime errors. Now this is mostly because our code isn't really set up for multiplayer, and you will soon understand why. So basically now what I want you guys to do is head into your maps folder, create a new level, and we'll call this one multiplayer testing. So go ahead and open it up. So this should be a blank level. So I'll just grab in a sky and grab in a directional light here, and we should have everything set up. And maybe if we want, we could have fog, and we can just create a simple landscape. So head into your mode selection, landscape, and we can go ahead and create it. So I'll just do a little bit of noise so that we have a starting point, so that we have some sort of a workable landscape. So increase the brush size. So the strength is a little too much. 0.05 should be fine. So let me just go back. Okay, that should be good for us. Now what we can do is we can go ahead and talk about multiplayer. So the main aspects of multiplayer in Unreal are replication and remote procedural calls. If you are clear with how to use these two concepts, it's pretty simple to code a multiplayer game in Unreal Engine. It's much more difficult to do it with general knowledge of networking, but with Unreal's framework, it's really very simple to set up multiplayer. We'll discuss both Blueprint and C++ aspects, but first the basics. Now I want you guys to head into Blueprints, and under here I want you guys to just select your character and your BPA. So I guess this one is where we had physics enabled. So if we do, yep, we have physics enabled. So I want you guys to just show the problem with just running multiplayer in general. So I'll just go ahead and drag this in, and what I can do now is I can go ahead and grab a few player starts here. So I'll grab one here, grab another here, and make sure they're all facing the same direction. So what I can do is I can make this one 90. So they're all facing towards this ball right there. And now what I'm going to do is I'm going to change the world settings to use our BP game mode. And for the player controller, we can ignore that. We'll still get the runtime errors. So what we can do is we can remove this logic. So we'll forget about the HUD for now. And if I go ahead and press play, now you see the ball has fallen down and it's rolling down the hill over there. And as you can see, I kicked the ball. But if you were to notice, the ball is in a completely different position. So the ball is over there for me. And if I actually head near the ball here, you'll see that I'm not actually going near the ball on my other screen. So if I actually turn around, my character is somewhere there and my ball is somewhere over there. So as you can see, both of these are not in sync. Now this is something related to the widget, nothing much to worry about. So basically what I'm trying to say is that these two games which are running on separate windows are not in sync. But you'd notice one thing, that your characters are in sync. So for example, if I go ahead and run forward, and if I go ahead and run forward over there, and if I actually look up, you'd see that my characters are in sync. It's just that the physics object over there is not in sync. So the reason this is happening is because in our character, if you head into your class defaults and head into the replication tab, you see that these two flags called replicate movement and replicates are enabled. Basically, this is Unreal's way of telling us that, or rather asking us, whether we want this particular class to be in sync with all players when instantiated. So let's say we instantiate a BP character, it will always be in sync. Obviously there are conditions, you have to instantiate it on the server. We'll talk about servers and clients soon. So let's head into our actor and try to fix it. So head into your class defaults and let's try enabling replicate movement and replicates. If I compile and if I go ahead and press play, as you can see, now the ball's rolling down, it's near me, and as you can see, this seems to be in sync. If I go ahead and block this, as you can see, this is almost completely in sync. Now, one of my characters flying is due to the movement mode, just ignore that. But as far as I can see, everything is in sync. So this is basically how you get stuff to go in sync in a network game in Unreal. This is the most basic aspect of it. You might see that there are a few more flags here, such as always relevant, call pre-replication, net load on client. Most of these aren't really important. We'll just talk a little bit about net cull distance squared and net dormancy and stuff. But most of the times, 9 out of 10 times, you'll only mess with replicates and replicate movement. Sometimes you may need your actor to be always relevant. Let's say it's something important to your gameplay. You'll have always relevant enabled. So once that's said, let's also talk about net priority. Basically, the higher the value, the more priority is given for this to be updated. So let's say you have thousands of actors and your bandwidth is insufficient to actually update all the actors. The ones with higher priorities will be updated first, basically. So now that we know the basics of replication, let's start syncing up some variables. So if I head into my actor and if I go ahead and create a variable, so we have some float already. And what we'll do is on begin play, we'll go ahead and set this to some random value. So we'll get random, so random float. And what we can also do is we can go ahead and print this string. Alright, so let's look at what happens. So let's actually delete some of our other methods here. So I guess we had some stuff in our character. So we'll just stop calling this function and we'll ignore this spawn actor. And I'm not sure if anything else is printing something, so we'll ignore the left mouse button as well. Now if I press play, as you can see, we only get our post login and we have 0.809 and we have 0.43. Now clearly this is not what you want. You want them to be in sync. So if you want variables to be in sync, the first thing you'd want to do is you'd want to set this replication tab to replicate it. Now let's go ahead and try that actually. So if I press play, we still get different values. The reason is, even though we set the value, we need to set it on the server and we also need to wait for the replication cycle to take place. Basically, your value doesn't immediately get replicated. Instead, your value gets replicated in the next replication cycle. So every once in a while. So in our case, if you head into class defaults, you see this net update frequency parameter. It's set to 100. Let's say we set it to something like 10. Now this variable will be updated after approximately 0.1 seconds. Obviously it can be less than that, but up to 0.1 seconds. If I make it 100, it's going to be up to 0.01 seconds. So it's not instantaneous. Remember that these two players, what we play here, they are not running on the same machine. So you cannot expect the variable to update immediately. So what we can do is we can actually set some logic to update this. The principle which actually goes into this is the fact that all your replicated variables need to be set on the server. So let's go ahead and do that. Now just a quick note here. The event begin play which is there, since this actor is replicated, each time one computer out of all the players will spawn the actor. So for each computer this begin play will be called. So if you didn't get what I mean, if I actually simply go ahead and print a string, so if I go ahead and type in print, and if I print hello and if I press play, you would notice that the server and the client print hello. What that basically means is as soon as the client logged in, that is when the client entered the game, this actor was spawned on the client and begin play was called both on the server as well as the client. So what we can do is we can check if we are on the server. So we can type in is server and we can do a simple if check. If we are the server, we can go ahead and set this value. So we can go ahead and do that. And if we are not the server, we can go ahead and print it. So one more thing we can do is, okay, this is gonna work. Let's just do it. So we can go ahead and print some float and go ahead and press play. As you can see, the values are the same. In case you guys have any doubts regarding that, you can go ahead and plug this in directly like this. If I press play, you see 0.718, 0.718, the value is the same. So basically all your replicated variables need to be set on the server. That's the first thing. Now what if you wanted a client to set the value? So your client cannot actually set the value. However, oh, and just another thing, this logic is going to work for 3 players as well. So if I go ahead and do this for 3 players, so as you can see, all 3 players have the same value initialized. So that's going to work as well. Okay, anyways, getting back. So let's say now instead of this, we wanted a client to actually set the value for us for all the players. So the way you do that is through a remote procedural call. So replicating variables, this is about it. There's really nothing much to it. So this is basically how you'd replicate variables. I will get to rep notify. So let's say you wanted to call a function when a variable has been replicated. Instead of replicated, you can check this rep notify option. So then what's going to happen is when the value of the variable is set, this function will actually be called on all the clients. So if I go ahead and play, you'd see we get a hello as well along with that. So we can just type in rep notify. So we get whatever string we put over there. So basically, that basically shows that our replication logic is working. That's pretty much it. We can have any other functionality. For example, let's say you have rep notify on a health variable, you can update the health bar. So something simple like that. Now, let's go ahead and run this logic from the client. So let's say we set this on the client and we already saw that that does not really work that well. So what you have to do is you have to use a concept known as remote procedural calls. Basically, they're just custom events meant for multiplayer in Blueprint. So type in custom event and we'll call this one set some float. Some float is the variable name, so we just made a setter for it. Under this replicates tab, set this to run on server. Now what this is going to do is this is going to ensure that this runs on the server. So if you call this from an owning client, now we will get to the problem with it. And if we run it from an owning client, we are going to be able to call this on the server. So reliable basically means you want it to run in order. So let's say you ran 2 RPCs. So it's going to run in the same order if it's reliable. If it's not reliable, the order may change. Since it's networked, it's not instantaneous. So stuff like that can happen. So now I'll just make this reliable. I'll just go ahead and print a string and I'll call this one server RPC. So now what we can do is we can go ahead and we'll not do this set with notify. We can go ahead and instead of that, we can call our set some float. And let's see if we get anything printed. Now something weird happens. As you can see, we are not able to actually call this RPC. If I were to actually play this and if I open up the output log here, as you see it says warning unit driver process remote function, no owning connection for actor BPA C1. This is basically the display name of the actor. Function some float, set some float will not be processed. What has basically happened here is that Unreal basically does not know which client actually owns this actor. Now this actor isn't owned by anyone. And if you were to notice this RPC call, it says reliable replicated to server if owning client. Now this if owning client section which is there, that is what is causing our server RPC to fail. Now let's do a similar drill but inside a character. So if I were to just create an RPC here, so I'll just go ahead and create a custom event, custom event, and I'll just call this one sv_test, something like that, and make this one a server RPC, reliable. Go ahead and we'll just print out a string and we can say RPC called from character. Now we want to be able to call this from the client instead of begin play, since we are in the character anyway, so we can use a more elegant solution, maybe on a key press. So maybe K on the keyboard because we don't have any other thing. So K on the keyboard. So find it over there. So there is K. So when we press it, this will obviously run on the client which presses the key. We can call svtest. So go ahead and play this. And if I go ahead and press K, it works on the server. And if I were to press K on the client, it works on the server too. I mean, obviously it's a server RPC, so the function will run on the server. But the point is our RPC worked and our client was able to make the server RPC. Now what if we wanted to be able to call this? So from a client. So for this, you'll basically need to have an owner for this. The way you do it is through the spawn actor function. So if you've just placed it in the level like that, you will have to use the set owner method, which again, I mean, if you were to place something in the level, it's pretty obvious you wouldn't have an owner for it. But let's just see an example where we use the owner. So what we can do is, okay, we already have a spawn actor function. And for the owner here, this is something which I did a bit later. So for the owner here, go ahead and plug in self. So spawn an actor doesn't matter. The location and stuff doesn't matter. We aren't worried about the actual actor itself. We are worried about the RPC. So make owner self. And now what I want you guys to do is run this only on the client. So let's say, for example, we'll again do it on key press. So then that's going to be easy for us to manage. So we can manually call it. So on key press, what we can do, and we want to spawn this on the server, obviously. We don't want to spawn this on the client because it is replicated, remember. So you have to spawn it on the server itself. Even spawning cannot be on the client. So make sure you spawn it on the server. So is server. Only if it is the server, we are going to spawn it. And obviously this will run multiple times because for each player which will be spawned, this will run. So there's no way for us to actually ensure that it happens only once, but nothing to worry. So we can just grab a reference to this. And we'll need to make this replicated if we want access to it from the client. So we'll go ahead and promote this to a variable. And we'll call this one obj, for example. And make this replicated so that we can access it from the client. And now when we press the K key, we can just check if it is valid. I mean, it will be, but just for a safety check, if it is valid, we can go ahead and call our RPC. I don't know what we called it. So we called it set some float. So we called it set some float. Go ahead and run this. Now, if I were to press play, and if I press K on the keyboard, as you see, we get server RPC printed. So if I were to check this, we have server RPC over here. And let's just test it on the client as well. So go ahead and press K. As you can see, server RPC is getting printed. So we are able to call it on the client. Basically, the ownership is important. Generally, it's a good thing actually that you wouldn't really require to call any RPCs from actors like this. Generally, you would have RPCs in your character, game mode, game state, stuff like that. Not in the game mode. Game mode, everything is going to run on the server. But for the most commonly used classes, networking is already set up for you. And in case you wanted to use it for an actor like this, I've shown you guys how to do it. So this is how you do it. Make sure you just set the owner. So let's say I don't actually set the owner. And if I go ahead and press play, this will still work actually. So if I press K, this is going to work. But if I do it on the client, it's not going to work. So that's one thing to note. From the client, the reason this won't work is because now that we do this, so let me just set the owner. When I set the owner over here, now when I press play, I have two characters. So one is on the server and the other one is on the client. And for both of these characters, the begin play is going to run. So this is going to run both for the server as well as the client. So for the first version, everything is going to run fine. But when this begin play occurs on the client's version of the character, even this character will have a begin play on both the server and the client, because since this is networked, this character will be spawned both on the server and the client. So when the begin play is called on the server for this one, that is when the owner property starts mattering to us. Over here, if we don't set self, in which case it will refer to this particular character in the game, our logic is not going to work. So that was pretty elaborate in my opinion. This is probably something which you wouldn't even require that much, but this is basically how you do RPC calls. Now there's one more type of RPC which I want to hint upon, and that is multicast. What if now that you're on the server, what if you wanted to print this for all the players? In which case it's really simple. Type in custom event and we'll just call this one MC_print. I mean, we actually didn't set the float here, which is kind of ironic, but we'll just do sv underscore print. So sv print. So we'll print this and we'll just duplicate this over here and make this a multicast RPC. Now, I generally don't prefer making these reliable. Generally, you would use multicast for things such as particle effects. So you wouldn't really need reliable, but anyways, I'll just do it for this example. And we'll call this one multicast. So we'll just call MC print. And remember, multicast RPCs have to be called on the server. If they are not called on the server, it will only run on that client. So it's not going to run on all the others. So if I were to press play, as you can see, we get multicast RPC. So this is basically how we would go about doing this. Now this worked on the server's instance, obviously because we spawned it over here. Otherwise it wouldn't work. So if I were to just go ahead and press play, you would see it works. And if we had more players, it's going to work again. If I had 3 players, it's going to print it multiple times. So it's going to print it on the server, client 1 and client 2. So we have server RPC, multicast RPC, and stuff works like that. So this is basically how you would go about calling RPCs. So you have svprint, which is routed to the server, and we can actually test that out rather than doing it on begin play. That is kind of an incorrect way. Obviously, I showed you guys the right way to do it. So this is some sort of logic which you would never use. So we'll just ignore all of this. Go ahead and press play. If I press K on the keyboard, you see we are calling the RPC. If I press K on the client, it works as well. If I press K on the other client, it works as well. And all of the players can see the printed string. Now you can also have the logic the other way around. So let's say you are the server, and then let's say, for example, I'm just taking an example here. Let's say when the game starts, you wanted to show a countdown, and the widget obviously will be spawned on the individual clients because obviously it's a widget, so it has to be spawned on the particular client's computer. So for that, you will again use a client RPC. So I'll just do it over here. So let's say when I press the K key, we'll test this on the server itself. Client RPCs can only be run from that owning client or the server. If you run a client RPC from another client, it's not really going to work. So in order to do that, we'll just create an RPC. So we'll make this one CL underscore test and make this run on owning client. And what I can do now is I can go ahead and print a string and let this just be there. So if I do CL underscore test, and if I were to press play, if I actually press K here, RPC called from character runs on the server. Over here as well, this runs on the client, and over here as well, this runs on the client. So this is basically how you do it. It'll just run on the client. But what if you wanted to run this from the server? So if you do this through a server RPC, it is going to be routed through the server. So I'll just do that and show you guys. So what we'll just do is we'll just DIY it ourselves. So we can say sv test, and this will run on the server. We can have another print string, and we'll call this one sv for server. And over here, instead of that, we'll call the server RPC. And now what we can do is once this is printed, we can go ahead and call the client RPC. So CL test. Now if you were to notice, if I go ahead and press play, if I press K, as you can see, now both are called on the server. So the server RPC worked and the client RPC worked. But if I do this on a client, as you can see, the server printed SV and the server again called a function on this client. So this is basically how you would go about using client RPCs. So for any multiplayer logic, this is exactly how you would go about doing this. In C++, this logic is pretty straightforward. There are just a few additional steps for rep notify and replicating variables. But other than that, even the C++ part is pretty straightforward. So generally you would use Blueprint itself for core multiplayer logic, unless it's something, you know, fundamental to your game and you want it to work properly. Like let's say you had like a firing mechanic or something and you don't want any sort of performance issues or any overheads, then you'd use C++. Otherwise you'd really just use Blueprint for most of the things, because it makes things so simple. As you can see, you don't have to do stuff like opening ports and stuff. So all of that is handled by Unreal. And now let's go ahead and see how to run RPCs in C++. Now I've gone ahead and opened up Visual Studio. Now we'll just ignore the plugins part right now and we'll head into our source folder, beginner course, public, and we'll head into, first of all, we'll head into a character. Now what I want you guys to do here is, first of all, before you actually use any networking feature, just make sure you include net/unrealnetwork.h. Make sure you include this header. If you do not include this header, you will get all sorts of weird errors. So make sure you do that. Now, first things first, let's talk about variable replication. So if you want a variable to be replicated, you basically have to make it a U property, first things first. And this one will give the specifier blueprint read write as usual to make things simple for us. And one more thing which you have to give is you have to give the specifier replicated. And we'll make this, let's say, a float replicated CPP variable maybe. Now one more thing which you have to do, this is additional, this is not something you have to do in Blueprint, but one thing you have to do for the replication logic to work is you have to actually write one function in the CPP file of our character. We'll go ahead and do that, and then we should be able to make this work directly. So I've gone ahead and opened up the documentation. So this is the function which we actually need. So we can go ahead and copy this and paste it inside our character.cpp file. So I've opened that up and I've just written a comment called replicating variables. Go ahead and paste it, and we can go ahead and have a definition for it. So over here, this is going to be a cpp underscore character. Just put your class name followed by the scope resolution operator. Then you can go ahead and just move everything to one line to keep things clean. And over here, you'd want to run this macro called doRepLifetime. And this takes in two parameters. One is the class, which is going to be our current class, and the variable name. The variable name is going to be this, or it's going to be replicated CPP variable. Now I'm recording this a bit later, but one thing that I forgot to mention is make sure you call super of this function. Otherwise, you'll get weird classes when you use the weird artifacts when you use the derived classes. And for the parameter, you can just pass this in. So make sure you just do that. Otherwise, your movement variables and stuff will not be replicated if you use your BP character. So that's one thing to note. And now if I were to go ahead and run a debugger, we should be able to do it. Just make sure you close the editor and then run a debugger. So as you can see, the build succeeded. And now we should be in theory able to use this variable as a normal replicated variable in Blueprint. So I'll just show you guys. Replicated variables are shown with those two balls on the top. So BP character is inherited from CPP character, so we should have it. So if I just type in CPP get replicated CPP variable, and as you can see, this variable is replicated. If I were to actually go ahead and check this variable over here, it says CPFNet. This basically means it's replicated. So now this should work like a normal replicated variable. Now I'll show you guys how to handle RPCs as well. So RPCs are simple. I'll show you guys how to handle server and multicast RPCs. I won't really go over client RPCs. They work pretty much the same. So I'll go ahead and stop this now. And for RPCs in C++, you need to basically have a U function first of all. So create a U function, and you cannot make RPCs in C++ blueprint callable. However, you can wrap them inside another function and then make them blueprint callable or whatever. So what I'm going to do is I'm going to put the specifier server, and one more thing, I'm going to make this either reliable or unreliable. So this is where you specify it. So reliable, or you can make it unreliable. Now I can go ahead and actually write something here. So let's say void test server RPC underscore CPP, just to indicate that this is in C++. Now what you need to do is you need to define it over there, but also rather than defining this, you're supposed to define another function known as the implementation for this. So what we are going to do is we are going to just copy this over into the next line. This need not be a U function, and type in underscore implementation. Okay, just ignore the parentheses there. Implementation. And now what we can do is we can create a definition for this instead. So I've already done that. So I have the definition for this, and we can do something simple such as a print string. So uke is mid-system library print string, and we can go ahead and print in this is a server RPC from C++. Now this should in theory work. And if we want to call this RPC, what we would do is you can just go ahead and call this. We don't have to call the implementation. We have to call this in order for the implementation to get called on the server. Or we could just do something else, such as wrapping it in another function. So I'll show you guys both the approaches actually. So I'll just do it on begin play. So on begin play, what we'll do is we'll go ahead and we'll actually delete some of this code. So we'll delete this, and what we can do is over here we can go ahead and check. So if we are on the server in fact, or if we are not on the server, we are going to do it. So if is server, so I guess it's called G is server. I think it's a variable, not a method. So if this is not a server, we are going to call this RPC. Over here we'll call test server RPC underscore CPP, and this will work as expected. And we can go ahead and wrap this in a blueprint U function. So we'll create a U function, make this one blueprint callable, and from here what we can do is we can just type in void wrapper for CPP RPC, and this one we can just write it like any other function and the RPC will run. Now what you can do over here is you can go ahead and run this function inside of that. So we'll go ahead and call this, and since this is blueprint callable, we can go ahead and just call this from blueprint. Also realize that just because of the way the function call works, this is not going to run at all. No matter what you do, it is going to come outside the if. So if it comes inside the if, it's again not going to, the condition is again not going to be valid. So you're not going to run this function. So anyways, we'll just run it as is, and then we can go ahead and run a debugger. So now if I were to actually go ahead and wait for it. So once it loads in and I go ahead and press play. If I press play right now, you would notice that you get this is a server RPC from C++. So we got two server RPC calls, one from the client and one from the server. Now I'll also set up some logic so that we run this during gameplay. So under your BP character, what we can do is we can run the wrapper. So type in wrapper for CPP RPC. Now if I go ahead and press play and press K on the keyboard, as you can see, it runs on the server. And if I do it on the client, that works as well, totally as expected. Now, one extra feature which I want to cover in C++ RPCs is the validation. So if I just type in a comma and type in with, okay, I have my caps lock on, with validation. Now what I can do is I can write a function which returns a boolean, and instead of underscore implementation, if I type in underscore validate, you can make it so that this function will only run under a certain condition. This is especially useful for something like cheat detection. So if I were to just create a definition for it, and what I can do is if this returns false, basically this client which is calling the RPC will get disconnected immediately. So I can just do return true for now, and this RPC is going to run. So if you had something like a health variable or something, and you do something like if health is, less than or equal to 100, and or maybe if you had any other condition. So let's say the health, you had a set health function, which is an RPC of course. So then you would check if it is less than or equal to 100, because you don't want the player to set the health to a value greater than 100. Stuff like this, but for now we'll just leave this to true. This function will run. Just to showcase, I'm just going to print string once again. So this, and we'll call this validate, and we'll not do this on begin play. So oops, print string. Go ahead and run a debugger, and before we do that, I'll actually just show you guys how to handle RPCs as well. I mean rep notify as well. So let's say I wanted to make this rep notify. I would use the replicated using flag. We'll do it after this actually. Now if I were to go ahead and press play, as you would see, the validate function was also called on the server. So the server is going to validate, and accordingly it is going to disconnect the client if the condition is not met. So that function, whatever we saw right there, that has to return true in order for the RPC call to take place successfully and for the client to continue stay connected. So this is basically validation, and now let's talk about rep notify. I am back inside the header file, and for rep notify, over here you can just go ahead and create a function. So what do we call this function? This need not be a U function, but you can make it as well. So we'll call this one on rep. It's just a convention to use on rep, but it need not be. On rep wrapper for CPP, let's say. For CPP. And this one will just be void. No need to return anything. You could return a value if you wish, but there's really nothing much you can do with it. Go ahead and write a function definition for it. Now again what we can do is we can go ahead and just print something. So we'll just copy this over, and rather than validate, we'll just print rep notify from C++. So now what we can do is now we can feel free to come in here, and rather than typing in replicated, type replicated using equals and just pass in the function name. So you don't have to pass in anything else, and this is going to work as you would expect. One thing that you would want to do is wherever you call this function, that will obviously be on the server, make sure you call this function as well separately. So where you set the variable, so we are setting this replicated CPP variable, so we'll do that. Make sure you call this as well. So if you're setting this in Blueprint, make sure you make this function a U function and make it Blueprint callable. So we'll do that actually. There's one issue with it in C++. This is how we would, this thing works in the same way as it works in Blueprint. So we'll just do it on our RPC itself. Anyways, we are running the RPC. So in the implementation for it, we'll not have the print string. Rather, we will have our rep notify. The way you do that is we'll modify the value of the variable. If you modify the value, automatically rep notify will be called equals, I'll just type rand mod 19. I just chose a random number over there. And what you want to do is you would want to call this function only over here. and the rest will be handled for you. Now we can go ahead and run a debugger. And you would see that rep notify will be called and rep notify from C++ is going to be printed. It just works just like that. So wait for the editor to load in. And once we are inside the editor, if I go ahead and press play, as you can see rep notify from C++ and it was called on the client as well. Since there are two versions of the character here, so one on the client and one on the server, both of them called it 2 times, so that's the reason we got 4 prints. And the same thing is going to work when we use the wrapper. So if I just type in K for example, you see the rep notify works. So we get the validate, rep notify as well as anything else that you would expect. So rep notify on the server and the client. And if you want to do the same in Blueprint, so you can go ahead and set our replicated CPP variable to something. And you would notice something weird. First of all, I have to do it on the server. So we'll do it on a server RPC. So SV test, rather than doing CL test, we'll go ahead and set the value of this variable. And we can do SV test. Go ahead and close this. And if I were to press K, let's just wait for it. As you see, this rep notify is only called on the client. This is not actually called on the server. So in order for rep notify to work, again once you do this, you will have to type in on rep wrapper for CPP. So make sure you actually type that. So now if I were to go ahead and press K on the keyboard, you see it runs both on the server and the client. So there's just one extra step which you have to take in C++. That is if you have your replicated variable in C++. So that's about it for rep notify. I guess we have covered almost all aspects of replication. Multicast is something which I'll just talk about. So all the same parameters except over here you'd have net multicast. So don't mind the spelling, I mean the capitalization. So I have my caps lock on, net multicast, and this will work as expected. You can again have your reliable and validation and stuff like that. The rest of it will remain exactly the same. So you'll have your implementation and you can have your validate if required. But you wouldn't really have a validate for a multicast RPC. So I'll just go ahead and delete that. And this should work just as expected. So I'm not going to really show that. This is how you would basically set up a multicast RPC. And the documentation is there. We did the example for the server. There are no syntactical changes to this. So it should be totally okay. So we'll just delete that definition. And I guess then we are done with multiplayer, guys. Now that we are done with covering all aspects of game development in Unreal Engine, let's go ahead and actually take a look at how to install Unreal Engine from source. So the main part is actually done. Now we'll be doing a couple of things such as downloading the source, looking at how we can build it, as well as we'll be going ahead and changing the engine version on our existing project. So first of all, as I mentioned at the very start of the course, make sure you guys do get access to this repository here. As of this date, the release branch should have 5.1.0 and you should be able to download the zip file over here. So download the zip. First of all, especially when you're installing Unreal Source, just to avoid, the permission issues which you're going to get, make sure you head into your C drive, new folder, and just create a folder called Unreal Source or something. Need not be the C drive, just make sure you do it in your SSD if you have one. So in my case it's the C drive, so that's the reason I'm doing it. So I'll just go ahead and install it there. So go ahead and extract the files. Over here under C, I'll go ahead and browse the directory over there. So C Unreal Source. Go ahead, extract, and extract it under that directory and hit OK. Now we're just a few steps away in order to install Unreal Engine. So first of all, go ahead and run your setup batch file and try to run it as an administrator just to ensure it has all the permissions for everything. So run the setup batch file as an admin. So something like this should show up, and once it's completed, we'll head into the next step. After the setup batch file has completed running, you can go ahead and run the generate project files.bat. So this file is basically going to generate your Visual Studio solution. So let's go ahead and run that again. Try to run it as an administrator. Should work regardless, but if you do get any errors, just run it as an admin. So you should see something like this, and this should complete relatively quickly. At this point, you should be able to see your solution file. So go ahead and open it up. Once the solution is open and you see ready over here at the bottom left hand side, what you should do is you should go ahead and head into Engine, and if it does ask you to install a few more components in Visual Studio, make sure you just go ahead and do that, just follow along. But in my case, I've already done that, so I'm going to go ahead, right click on UEFI and click build. Now once your build has succeeded, under your engine, binaries, Win64, you should find Unreal Editor.exe. So by default, the build configuration is set to development editor. If you don't see this, it means your build configuration was probably something else and it didn't get built. So anyways, let's go ahead and open it up, and our editor should load up. If we do get any errors, we can go ahead and debug it now. So everything seems to be working fine, and it is going to compile some shaders. Once that's done, I'll be right back. Alright, so now what I want you guys to do is go ahead and copy your beginner course project, and now I'll show you guys how to change the engine version. So head into your beginner course uproject file, right click, switch Unreal Engine version, and now you should see source build at whatever. So basically I opened and closed the editor, that's it. So whatever we did there, opened Unreal Editor.exe, I just closed it immediately, and now I'm back to this location and you should see this. So if I hit OK, it is going to generate some Visual Studio project files, and unless something's horribly wrong, it should in theory work out of the box. So that's about it, and now you can go ahead and just build your solution once again, because there may be a few API changes which you might have to make. So those will be listed in the output log and as well as in the release notes and the documentation or whatnot. So head into your solution. Now we have switched the Unreal Engine version. So now we can go ahead and right click on our beginner course and click on build. So we get our first error here, and this is actually fairly common. So basically we have switched the Unreal Engine version, and we have a plugin over here which is based on the older version of the engine. There are two ways to fix it. One, you can head into the marketplace and reinstall the plugin which is meant for 5.1, or I'll just show you guys the way to do it without using the marketplace. So in the marketplace, it's really easy. You can just go ahead and update the plugin. But over here, if you really want to just use the same one, what you can do is you can head into your engine installation directory. So in my case, it is C, Unreal Source, Unreal Engine Release, Engine, Plugins, Marketplace. It's not here because we haven't yet installed, so you'll find it there. So we'll go to our previous installation, Program Files, Unreal Engine. This is where I had it, UE5.0, Engine, Plugins, and you should find Marketplace. And the one we are interested in is Low Entry Extended Standard Library. You don't need to copy it to the engine installation, although you could. What I'll do is I'll just take it to the plugins folder over here. So over here, and inside the U plugin file, we'll do the same modifications. Over here, what we are going to do is under the engine version, we are going to type in 5.1.0. And now if we go ahead and try to build this once again, we shouldn't get that error, hopefully. So it will take a while, and if we do get any errors, we'll go ahead and change it or fix those. So we have a few errors here, and these are mostly the changes which came according to the documentation due to the platform SDK upgrades, but it's not really a problem. So because I don't think any of you guys, unless you guys work for a AAA studio or something, I don't think you'll be using this. And this is from the plugin. This is not something in the engine, so nothing to worry. So what you can do is we can simply just delete this code and just do return false. And even for the Xbox one, so we can just do the same thing. And I'll tell you guys which file this is. It's basically this file right here. So in the error list, you see platform PS4 whatever. So just head into that, just double click on that, and you will reach there. And over here as well, so line 264. So I feel like this was it. So before changing, it was in line 264. So now it's gone a bit up. Anyways, let's try building this once again. And as you can see, the build has indeed succeeded. But once the plugin actually comes for 5.1, what you can basically do is install 5.1 here, like in the Epic Games launcher, install the plugin from the marketplace, and then you can go ahead and copy that into the plugins folder in the engine level. So what you would do is you would have it over here. So C Unreal Source, Release, and Engine, Plugins. Over here you would create a new folder called Marketplace or something, and then you would like just copy it in. Anyways, we are not really worried about that right now. Now what we can do is, now that it's built successfully, we can go ahead and run a debugger, and we should be able to run this in 5.1. So I did show you guys multiple things. So the errors which you get will actually depend on what plugins you are using and how's your code base and what changes are made to the engine's API itself. So depending on that, you'll have to look at the output log and the error list and do something. And there are a few deprecation warnings as well. So if you just have a look. So I'm not really sure what this is, but this will probably be changed soon once the plugin is updated. But right now I'm not really worried since it's just a warning. So now I can go ahead and run a debugger. Alright, so our project has opened successfully, and it is prompting us to change a few project settings in order to actually use virtual shadow maps and Nanite. So that's not really an issue. We can head into the project settings, and over here under, it should in theory be here, so platforms. So let's just search for platforms. It'll be under any one of these. So platforms, Windows, and you can go ahead and enable shader model 6. And over here we can go ahead and I don't think we'll require shader model 5, so that should be about it. And now you can go ahead and restart the editor. Alright, so now I've restarted the editor, and now we are using Unreal 5.1. So that's about it for installing the source and changing your engine version. Now there are a few more ways you can handle some of the things, such as the plugin part, but on the whole, this is how you do it. And if you do want any more specific references, you always have the documentation which you can refer, and the release notes, and maybe the Unreal Slackers Discord server. So that's about it. Alright, so we're finally inside the last section of this course, and obviously it is about how to package your game. So it used to be very simple before, so you just go file, package, project, but now you probably have to just do it through the project launcher, which I will show you guys. It's really simple. So head into tools, project launcher, and you can use this, but I'm going to be using a custom launch profile. So go ahead and create a custom profile, and I'll just walk you guys through each option. You can give a name to this profile. Let's say this is for testing. Let's say you're building this for testing, so you can name this profile testing. You can reuse this profile for the next time when you package the game as well. Packaging basically means you make your game, or you turn your game into an executable basically. Now project is going to be beginner course, of course, and build configuration. So debug and development will be used when you're actually, testing out your game and you're still not yet at a stage where you can send it to other people. So your print strings and stuff are gonna work, but under shipping, none of your print strings and stuff will work, but it will take a bit longer to build. And testing is somewhere in between debug development and shipping. So it's below shipping, but it's above development and debug basically. So you can select any one of these. I'll just select shipping. And here, these are settings we don't need to worry about. And about cooking the content, you can do either on the fly or by the book. Basically, what on the fly and by the book is going to differ in is basically if you do by the book, everything is going to be cooked beforehand basically. So if you're packaging your game for shipping, most of the times you will have by the book, and you would select Windows if you're developing a Windows game. Obviously, if you have anything else, let's say you're making an Android game, you would select Android and stuff like that. And under cook cultures, you'll find English somewhere here, so EN. It should be selected by default, so EN. And you can select your maps which you want to cook. So we're using all, so we'll just select all, but you can choose to cook only selected maps. But note that if you don't cook a certain map, you won't be able to open it in game. You're going to get errors. Your game will probably crash. So that's one thing to note. Now, release DLC patching settings. These are some things which I'll not go over. And under advanced settings as well. So you can go ahead and mess with these. So you can enable this if you want all the content to go in a single .pack file. Stuff like that, and everything is pretty self-explanatory. Next, package and store locally. Then you can go ahead and give it a path. So generally I'd like to do it in the project location, saved, and I'd like to create a folder called staged builds. Staged builds. If you've used the project launcher in the older versions, you probably already know what this is. And is this build for distribution to the public? We have selected shipping, so I would assume it is. Of course, it's again your preference. Do you wish to archive? You can select yes or no, doesn't really matter. And deploy, we can select do not deploy because we aren't actually launching the game. So if we select do not deploy, basically you can launch it through the executable itself. So once that's done, you can head back and you can click on launch this profile. So now once everything has been completed, you can head into the directory over there. You should find a Windows folder and you should find your executable right there. So open it up and you should launch your game. So we will end up in this map right here. Again, you can change your project settings and you can change the default map. But anyways, our purpose here was to check if the game packages, and everything seems to be working. The physics simulation works and so on. So that's pretty much it. Okay guys, so this is going to be the last segment of the course, as you guys would know, and I hope you guys would have enjoyed the course till now, and congratulations if you have completed the course till here. And the further part is going to be 2 hours of me creating an entire game. So hopefully you guys will enjoy it. See you in the engine. Alright guys, so this is the last section of the course, and this is not actually going to be about, learning anything new. However, in this part, I will be live demonstrating without any cuts how to make an endless runner such as Temple Run or Subway Surfers or any other which you might have played. So we'll be taking the most simple approach, or at least as far as my knowledge is concerned. If you do have anything simpler, you can let me know in the comments. And hopefully within an hour we'll be able to make the whole game with the menu, animations and all that kind of good stuff. So let's get started. So let me actually have a stopwatch here so that we have track of our time. So I'll just create a game. It's going to be third person because we'll have the animation blueprint and stuff. But anyways, I don't think we'll be using that. Not to worry. We'll go with blank actually. C++. And we'll call this one endless runner. Create it. Now this will take a little bit of time. And I do have a couple of things being installed in the background, and I also have a list of plugins that I'll be using. So you guys will have a pretty good idea of what we'll actually do with plugins and stuff. Because in the course, I think I just went over these briefly, but I went in depth about how to actually create your own plugins and stuff. Anyways, so our project will be created soon and this will compile. So until then we can go ahead and open up our Epic Games launcher, head into library, and we can close this editor for now until we add everything. So what I'll do is I'll go ahead and search these one by one. So city, subway tunnel. So I have to create a separate project for this. Not gonna go over that right now. So we'll go construction volume. So volume 1 and volume 2. We'll go ahead and add this to endless runner. We'll add this to endless runner. I'll clear the cache later. It's just taking up storage. And we want LE extended. So LE extended. So we have already installed it to 5.0.3, so nothing to worry about there. So adventure character, whoops. So this will be the character which we'll be using, and it's going to be hella fun. We don't have time to actually model our own character. That's the reason we are doing this. So I'll just go over this real quick. So FX variety pack. Not sure if we will get the effect we need, but I'll just add it just in case. Okay, I need to download it yet, so not gonna do that now. So window dialog box. So I've already installed it. So these two. So we'll use these for obstacles and stuff. And lastly, we'll just have some trees. Maybe at the side we could have something. Stone pine forest. And go ahead and add it. Once everything is complete. Now, depending on your system, if you have a hard drive or something, this process is going to be a little bit slow. So this is under my Unreal projects, endless runner. So we'll be using the file explorer for this. And I'll just delete this later on. So now once the engine is loaded up, we can start making our game. And we'll go ahead and create a maps folder first. So right click, maps. We'll have only one. And all the obstacles will be spawned at runtime dynamically when you're playing the game. So we don't really care about having multiple maps, but we'll have two. So one is going to be your main menu. And the other one is going to be the actual map. So I'll go ahead and create the map. And I'll call this one game map. Alright, save that and go ahead and open the main menu. Head into project settings and just change that as well. So under your maps and modes, you should have open world. We'll change that to main menu. So editor startup map will be main menu and it's going to be main menu again. So editor we can start with our game map actually. But the game has to start from main menu. So just go ahead and click import. Doesn't really matter. Alright. Now over here we can start making a main menu. So right click, create a new folder, and we'll call this one content once again. And inside this we'll actually create stuff because the main content folder is a bit clogged up. So we'll call this one UI and we can create a main menu. Right click, user interface, widget blueprint, create a user widget, and we'll call this one main menu or BP underscore main menu. And we'll suffix that with a WB to indicate it's a widget. And it's going to be just quick and dirty, so we'll add a canvas panel here. And at the center, we'll just have a start button and an exit button. So we'll add in a vertical box. So vertical box, and over here we can go ahead and make this center aligned first of all. Center aligned position 0 with 0.5 for the alignment value. So this is going to make sure everything is centered. We can go ahead and increase the size a bit, even vertically. And we can go ahead and add in 2 buttons. So button 1 and Control D to duplicate. We'll make it so that it fills it, and we obviously want the play button to be bigger. We don't want our users to exit the game. Anyways, we'll add in the text here. So add in some text, and change the background color for both of these buttons. Make it almost black. Maybe not exactly black, but almost. So I like this shade of color. Now rename this to play, or rather start, we can try. Change the font maybe. So the font we'll use is going to be the light one. So 40 seems about right. Make this one 40 as well, and this one is going to be light, and this one is going to be exit. So we can add the functionality as well, because this is pretty simple. So on this button, we'll rename this to exit button, or it's really not required, I guess. So on click, and for this one as well, we are going to add an on click. This is the start button, so I'll just comment this out. And for this, we can go ahead and execute console command, and we can type in exit. Now our exit button should work. We can go ahead and test that. First of all, we haven't even created the widget. So under content, we'll go ahead and create a new folder and call this one blueprints. And we'll have 2 subfolders here. We'll call one as game and the another one as main menu, because we'll have different player controllers and stuff for the main menu and the actual game. So under main menu, right click, go ahead and head into blueprint class and create a player controller. And we'll call this one BP main menu player controller. So this is basically for, creating the widgets and stuff. We'll just use the player controller. Now under the event graph, we can just do it on begin play. So we'll create a custom event, create main menu, and create a widget. It's going to be BP main menu widget blueprint, and add this to the viewport. Now I don't think we really need the reference, but we'll just store a reference to it anyways. So main menu widget blueprint, we'll just have a reference to it. And from this, we can go ahead and add it to the viewport. Alright, and on begin play, we can create the widget. So create widget, or rather create main menu is the function name. So create main menu. And now if I compile, save it, go ahead and press play. As you can see, nothing happens because we haven't changed the game mode yet. So over here, we'll create a new game mode. So go ahead, all classes, game mode. So we'll create a game mode base. So we'll call this one BP underscore main menu game mode. Now under your world settings, go ahead and change your game mode to BP main menu game mode. And over here, the player controller can be our BP main menu player controller. And now if I go ahead and press play, we should get our buttons. Start won't do anything, but exit is going to work. Now let's actually head into our game map here. So maps, game map. We'll worry about the main menu a bit later. So we are in the game map. We can go ahead and add our sky. So sky atmosphere, skylight, and we can add in our directional light. We can also have a fog. So we can have exponential height fog, and we have everything set up. Now we could change the time of day as well. We'll make this one dynamic for now. So fully dynamic light, because I don't have any time to actually build this. So go ahead and rotate it to make it like a morning or evening scene. This should be about good. Not gonna spend too much time on it. Save it up. And over here under content, now we can start building the actual level. So I'll just go to my blueprints folder here. Under game, I'm going to create the game mode and stuff for this one as well. So type in game mode. So I'll create game mode, BP game mode. This one is just going to be called BP game mode because this is for the actual game itself. Under your world settings, go ahead and change that once again. So BP underscore game mode. We'll have a CPP game mode if we really require, but I'll try to stick with blueprint as much. Now let's check our time. So 10 minutes in. Now under your game mode, we'll also have a game state to count a score and stuff. So game state. So game state base BP underscore game state. So we have our game mode, oops, and we have our game state. And now we can also have our character and stuff. So we can create that. First of all, we can just right click, blueprint class, character, and we can type in BP character. Open it up, and we have some basic things already set up. For this mesh, we'll be using one of these which we bought under man. Under mesh full, we have all these various options. So we have 4 options. So we'll be using these 4. So these 4 will be the options for the players to choose from. That's how we'll do it. So we'll create a derived class for this for BP character. So under our characters, what we can do is I can type in character. I'll just move this here and go ahead and type in subclasses. So this is like your main character. So every character is going to be a BP character, but then we'll specifically make them choose a mesh. So go ahead and create a blueprint class, type in character, and over here we can make it of type BP character and call this one character 1. We can actually just name them. Maybe we'll call one Adam. Duplicate that, we'll call one John. I'm just giving generic names. We had 4, so we can call one Jason, and maybe we can call one Bill. I just chose random names. So open this up, and for the mesh we can go ahead and start replacing it. So head into the location where we had the mesh. So this is going to be our first character. We'll set up the animation blueprint a bit later. So it's a bit off, but not to worry, we can go ahead and adjust that. -90. And we can head into the other classes here. So under content, blueprint, game, character, subclasses, we can head into Bill. And this was called SK Manful 1. So we'll call this SK Manful 2. Over here we can select SK Manful 3. So SK Manful 3. And for this one we can have SK Manful 4. So SK Manful 4. So that's pretty much all set. So I'm not sure if I should just use the default one here. So Manful 1. Not sure if it will inherit the transforms, so I'll just try this. I'll compile this. So if I open the full blueprint editor, okay, it has inherited the transforms. That's a good thing. So we don't have to do everything once again. Alright, so we have our character set up. In our main menu, we can go ahead and add a character selection option. So head into content, our actual content folder. Under the main menu, we can have a button somewhere. And maybe over here, we can type in change character. So I'll change the color of this. I'm not really worried about the visuals as of now. So I'll just go ahead and change this. Okay, I changed the color. So background color, I'll just make this dark again. And we can add in some text. And we'll call this one change character. Alright. make this a little bit wider so that it's visible for our player. So make this one 45 maybe, or 35. 35 seems good. We'll make that one light once again. Maybe we could make start a bit bolder. So let start be regular, because we want our players to deliberately click start. Alright, so once you click on the change character menu, it should just give us a list and we will create the widget for that. Now we'll also need a game instance class. Head into blueprints, and game instance is general, so we'll create one here. So game instance, go ahead and call this one main GI or something, and under the project settings we can go ahead and change it. So game instance, game instance, change that to main GI, and over here we can have a variable for selected character, and we can change that. Actually we can change that to be of type BP character class. So we have BP character, we should see it somewhere here, BP character class reference. So this is going to be the character which we have actually selected, or we could have it in a struct. We'll think about that a bit later. Now once we have that, we can go ahead and start making the actual obstacles and stuff. So one thing to note is that we want to make this modular in a way. We want to be able to spawn them one after the other. Let's just go ahead and do that. So when the game starts, we want to have a bunch of obstacles, and then we'll look at what to do. We'll work on the obstacles after we work on the animations actually. So we'll head into the skeletal mesh. We have certain animations. So content, blueprint, we'll head into character, and we'll create the animation blueprint right here. So animation blueprint, and we'll go ahead and select our UE4 mannequin skeleton. This is the one which comes with the pack actually. So create, and we'll call this one character anim BP. Open it up, and inside this we have a bunch of things. So we'll create a state machine, doesn't really matter. Now we can go ahead and have an idle. So we'll have idle, and we'll create a blend space for this. So right click, go ahead into animation. So basically this is for transitioning between your idle and walk animations. Blend space, and we'll call this one walk run. Okay. Over here we'll have few things in the horizontal and the vertical axis. Horizontal axis is going to be the direction, and the vertical axis is going to be the speed. So we'll go between 0 and 600, but we'll see if we can do something else a bit later on. Now open this, and we can have our third person walk halfway over here. We can have our third person run full way, and we can have our third person idle at 0. So we transition between these, something like this. For the direction we'll have a negative 180 and positive 180 obviously. So this will be like your angle from your forward direction. That's basically what this is. Now we can change the animation blueprint after we actually set it up first. So for the idle, we have our idle animation playing, and we should already have this working. And we can have this as a new state. So walk run. We will set up the conditions, not to worry. Whoops, go ahead and do that. So on begin play, we can go ahead and get the pawn owner and cast to BP character. And we can make this a pure cast because this will succeed. Or if it doesn't, we can go ahead and poll it. And once we get access to our character, what we can do is we can get access to the speed. So get velocity. and we want the vector length. Right now we have a vector and we want the magnitude of this vector, and we can promote that to variable, and obviously the magnitude of the velocity is nothing but speed, so speed. And we can also have direction, so get actor rotation. We'll set it up a bit later actually. Okay, so under the update animation, what we can do is we'll need this on every frame, so we'll use a reference instead. So promote this to a variable and call this one character ref. We'll be using this multiple times. So we can drag this over there. So this will be our speed, and also what we can do is we can also get the direction. So we can use this function known as calculate direction, and that is what will set the direction to be, set direction. So we'll create a new variable called direction. It's going to be a float once again, and we are going to set the direction to be equal to whatever this is. For the velocity, we can just grab in our get velocity here, and base rotation is going to be the actor's rotation itself. So get actor rotation, and we can plug this into the velocity as well. Now what we are basically doing is we are calculating the direction so that we actually input the value correctly in our blend space. Basically we are not using this value anywhere else. Oh, here we can plug in our direction and speed. So direction and speed. So these were our vertical and horizontal axis values in our blend space. We can also have jump, which we will do. We don't have a state transition. So if speed is greater than, let's say 10, we can go ahead and transition. And over here as well, if the speed is less than 10, we can transition. So rather speed. So speed is less than or equal to 10. We can go ahead and transition into this state. So now we shouldn't have any of those warnings. Alright, now if I actually create something here, so I'll just create a player start, so we'll know where to start. So player start, and I'll just go ahead and box out a simple level. So shapes, so I'll have a cube, and I'll just make this really big. So this is just for testing purposes, and for the default pawn class I'm going to select BP character, and let's set up the animation blueprint over here. If we go ahead and select our character anim BP, in theory everything should work fine. So our camera is a bit off, that's nothing to worry about. So under our BP character we need to set up a camera, so add a component, and this will be of type camera. Go ahead and add it. We can adjust the view, that's nothing to worry about. And if I go ahead and press play, we have our camera here. So we can make that a little bit further back, maybe tilt it down a bit, and I hope this looks good. Okay, so this looks good. So we have assist none in our character animation blueprint. So that's only in the first frame which is happening basically. So we can convert this to a validated get. That's a simple fix. You can go ahead and turn that into a validated get. Go ahead and press play, and now we shouldn't get those errors. You can set up our movement logic real quick here. So the character is always going to be moving, and I think we might have to change the animation blueprint here, because we always want him to be running, because we don't want him to stop. So we'll always have running actually. So sorry for that, but anyways, there's something we can do. So he'll always be running. So this is how he'll always be. And we can also have, a copy of this. So we'll just copy this over and we can type in run fast. We can make this go at a higher speed. So there should be a speed multiplier somewhere here. So playback speed is what it's called, I assume. So playback speed. So nothing under the details. We'll look into that. So there's actually an option called playback speed. So we are going to increase the speed and make it so that it's actually as if he's running. Now what we can do is we can head into the character once again, and now that we have him running continuously, we'll actually do it so that the obstacles in the world actually go backward. We can create the blueprint for that now. So we're finally heading into the obstacles. So we've spent 25 minutes, not done really that much. Under game, in the blueprints folder, we can go ahead and create a new blueprint class. We'll do it in a new folder. So we'll call this one course rather. This will be the obstacle course basically. And we'll create a new actor. And we'll call this one obstacle underscore base. And we can go ahead and create a child blueprint class and we'll call this one obstacle 1, obstacle 2 and so on. So obstacle 2, duplicate that, duplicate that, duplicate that. We'll have 5. We'll see if it gets too hectic, we'll reduce this number. Over here we'll need some sort of a base. So we can try using some of the things which we got from the content packs. So under hanger, I guess we had a road, I believe. If I type in road, we have this which is pretty tileable, I believe. Over here, road set. We have this. So we can use this. Just that we'll need to know what's the length of this and stuff. I don't think we'll go for Nanite or anything. This is fine. So close some of these which we are not using. Head back into the obstacle base. Over here we can go ahead and add in a static mesh. And this will be common for everything. So head back, select that. And go ahead and put that in. So this is there at the origin, but not to worry, we'll find a way to fix that. So it would have been nice if we had multiple lanes, but we have to live with this right now. So I'll just go ahead and recenter this. I'm not sure how big this is going to be. So I think that is pretty well centered. We can go ahead and add in an arrow component just for a reference. So add in an arrow component attached to the root. This one is going to be at the origin obviously. We'll just rotate that for a reference. Or we'll keep the rotation to 0. We'll look into the rotation and stuff. So we'll duplicate this once again. So Control D to duplicate. And we'll just have one over there. I think one is enough, but we'll just have it just in case. Alright, so this is exactly at the end. Now at first we can spawn, for example, 10 of these. And then we can later see what to do. We can have something in the side, by the way. We don't have anything. So we'll just add in a plane. And for this, we can increase the scale of this. Maybe we can make this 100, I guess. Okay, that's a little too big. 50. Maybe change it on the Y. 50 is a bit too much. 40. Maybe 30. 35. 32 seems to be about right. So it aligned perfectly here. And it aligned almost perfectly here as well. we can have 32. Now this is approximate, you can do it accurately when you actually do it. So go ahead and duplicate this once again. We'll attach it to the root. Duplicate. This will be for the other side. Alright. So we have something on both the sides. Now if we head into our derived classes, we should also have all of those. So we can spawn this first of all just for testing it out. So open the level blueprint and we can just do a for loop. So for loop, and we can have a loop of length 10, let's say. We'll select an origin. We'll start from a certain point. So target point, we can start here maybe. We'll make the z value of this 0. We'll make the x and y 0 as well. So this is going to be where we start. And we can go ahead and start spawning this further on. So we'll have access to this target point now. So create a reference to target point. So we are going to spawn actor from class and it's going to be BP obstacle. Or I'm not sure what we called it. Obstacle base. This is for testing, so it's fine. So we can get actor location. It's going to be 0, I'm aware, but in case we wanted to change it, the logic should still work. That's why I'm using the target point. So get actor location. We'll break this down actually. Split the struct pin. Now the y and the z are going to remain 0. So I have to see which is the forward axis here actually. So in the obstacle base, we have y as the forward axis. We can rotate everything by 90 degrees if we don't mind. We can just rotate everything by 90. Oops, we change the location. So we can change this to 90. And stuff doesn't seem to be working. We'll have y as the forward axis in our case. Don't mind. So the x value is going to be 0. We are going to split the struct pin. So we are going to multiply this by the index, and we can go ahead and split this, and the y is going to be this. X and the z are going to remain 0. Let's go ahead and just test this out. So go ahead, selected viewport. So if I click F8 and if I were to notice, we don't have anything. So we should have our target. Okay, we are taking the target point's y location, but we need the last obstacle's location. So we need the value of this actually. We need the location of this arrow. So this arrow. So this arrow is going to be located at negative 3200. So we'll just copy the number. We'll just brute force it here. So we have the target point. That's where we start. And into 3200, so it's negative 3200. So I'm not sure if we really need this. This is going to be 0 anyways. So this into 3200, index into 3200. Now let's try this. Okay, So our obstacle course is spawned successfully. So a bit of an issue with the direction over there, but that's totally okay. Alright, so we have that completed. So we spawned our initial course. So we can grab in our player start first of all, and we can rotate that. We can delete one of them. We can maybe rotate that -90 degrees. So now we should face the right direction. Now move this a little bit to the left. So for reference, we'll just have one obstacle. So we'll just have obstacle base. We'll set everything to 0, 0, 0, 0. And we'll base the player start accordingly. So our player start just disappeared somewhere. Okay, it's up there. So we'll click end to snap it to the ground. Go ahead and do that. And now we should in theory be centered, hopefully. Yep, we will be centered now. Now if I go ahead and press play, as you can see we are centered. Now we can also set up the logic to move sideways. So we can linear interpolate actually. So we'll add in target points. So copy this over, we'll copy the X location of this. So X is going to be 20. We need 20 here. And the Y location really should be the same actually again. So Y location should be the same. Now we have got these in the same spot. Now we can have few more. So these two are equally spaced. Now we can set up some logic so that we slide between these basically. Head back into the character to set that logic. Under your BP character, if we press the right arrow, we won't do changeable controls. So right arrow, so right, and we can have left as well. So keyboard events left. Under right and left we can change them. So if we press right, we also need access to which target point we are at right now. We can have all of these in a blueprint. We can have these in the game state. Content, blueprints, game state. We can type in, we'll have an enum. It's going to be simple. So content, we'll create enums. So enum, right click, create an enumeration. And over here we'll call this one which side of the road you're in basically. So I don't even know what to call this. Which side, I guess. I mean, which is kind of stupid, but at the same time it's descriptive. So it's either going to be left. Okay, you're at the center by default, so I'll have center first. Center, left, and right. So if I save that and head back into my game state, now I should be able to create a variable of type which side. Which side? Which side? It's just my naming convention. So we'll call this one with side maybe. Alright. So we'll have access to this at any given instance. And on begin play we can store a reference to this. Get game state. We can go ahead and cast to our BP game state. And we'll have a reference to that. Promote that to a variable and call this one game state ref. Okay. Now from here, when we press right, we can first of all get access to the variables. The first variable which we need is the only variable which we have right now basically, which is the side. So we'll type in side and we'll do a simple switch. So if we are at the center right now, we can go to the right. If we are at the left right now, we can go ahead and head to the left basically. If we are at the left, we can head into the center. If we are at the right, we don't need to do anything. So basically on center and left, we can do that. Again, we'll copy over this logic. Depending on which side, we don't want to do anything if we are on the left side here in this case. And we can linear interpolate on tick. So linear interpolate is what we'll just do. So we'll type in lerp and we should find a linear interpolate and we should be able to feed in the alpha. We'll think about a logic for that. Now we'll have access to where we are. By default, we are at the center. Just took a small break there. Now over here, we can continue with our side switching logic. So we'll actually get hold of all the locations and stuff. So by default, we are over here. So if I press play, we are over here. But when we want to move to either this or this. So we'll actually have a few variables for this. I'm going to be hard coding this, but you can have a more elegant solution for all of these. So I can go ahead and under my game state itself, I can have right location, center location and left location. So I'll duplicate these. So I'll call this one left location and I'll call this one center location. And we'll manually set these values. So this value over here is -230, -270 and 0. This is the left location. So -230, -270, 270 and 0. We can actually save some data, I believe, by using floats. We only need the we only need to linear interpolate the x directions. So we'll just store the x values of these. So this is 270, 20 and -230. Not sure if they're spaced equally. I'll just have a look at the top view. I want them to be spaced equally. So between this and this, there is a difference of 250. Between this and this, there is a difference of 250. So yep, they are spaced equally. Okay, so the right location is going to be 270. Left location is -230 and this is going to be 20. So I'll just store these like this. Now what I can do is I can go ahead and actually move the character. So I'll try set actor location. Not sure if this is going to work. So if we are at the center, we'll try to set this to the right location. So we are going left, so left location. So we only want to change the x. So go ahead and split the struct bin, change the left location, and the rest is going to be the actor's location itself. So get actor location. Go ahead and split this. Y and z will just remain as is. Alright, so we can go ahead and try this. So if I press the left arrow, so nothing is really happening here. So we can see by printing if something is happening. So nope, we are not actually taking the input. something has to do with the input. So arrow left keyboard, not really sure. I'll try to use A and D for now. So A on the keyboard. So we'll use WASD. So when I press A on the keyboard, we can try that. A is going to be instead of the left arrow. Alright, so we don't have access to the game state according to this. That's mostly because we didn't set it. So that's pretty simple to handle. So we can change that to BP game state. Now over here we can try the left arrow logic itself. So if I type in left, not sure what else we have. So left is the only thing we have. So we can go ahead and try this. So left arrow doesn't seem to work. Okay, left arrow works. So that was the game state issue, not our thing. So we can use this logic. We can linear interpolate instead. Or we have our interp nodes anyways. We can have a variable for the target location. So this is where, we want to get our character. So target X location, just to be precise. So linear interpolate is going to be a little tough. So f_interp2 is what we'll use. It's a pure function. So f_interp2. f_interp2 constant, because we want it to interpolate in a constant rate. So delta time is going to be delta seconds. Interp speed, we can adjust that. So we can promote this to a variable and we can call him sideways speed. Over here we can replace this with the target X location. That's going to be the X. Oh, this is an integer, we'll make this float. So target X location, and current is going to be our current X location. So target is our target X, current is our current X location. So current X location. So we can get the actor's X location again. Alright. So this should be it for the sideways movement. And over here we can go ahead and set these. If we want to go left, we don't want to do anything when we are on the left side. Alright, we can get the game state and we want to go left. So left location. And we can duplicate that, and if we are right, we can get the center location. Okay, but the logic isn't done yet. I'll get back to it. So we can use a select to just make things a little bit more simple. So if we are at the center, we'll go left. If we are at the right, we'll go to the center. So the logic should make a lot more sense now. And we can set this over there, move it in. Similarly, we can copy over this logic for our right. So that it simplifies things a bit. So if we are on the right, we don't want to do anything. We'll go to the center if we are on the left, and we'll go to the right if we are on the center. So get the right location. So this is what we'll set it to. Alright, now our logic should work once if I go ahead and press play. So if I put the left arrow, nothing really seems to be happening. Let's just check out why. Oh, okay, our interp speed is 0. Okay, so now if I try, alright, nothing really happens. So let's try 100. So our actor location seems to be fine. So current and target is okay. And now we can go ahead and print hello. So we're not changing the location, I assume. That's what's happening. So when I press the left key on the keyboard and when I press the right key, so we are changing the target X and the target Y location. So we'll try it without the interp first. A bit of debugging will so we can just copy this in. So I'll just remove this logic from tick. If I hit left or right, nothing really is happening. So we can print it and check what's going on. Alright, once again, the input isn't working. We'll use A. So we'll go ahead and use A on the keyboard maybe. Go ahead and use A. So if I type in A, the input, okay, it's just about the window being in focus. Alright, so if I go ahead and run this, okay, this works. Now we can try it with the interp logic. So now we don't need this. Okay, the speed is just way too less. So we can go a bit crazy on this, 50 maybe. Nope, still very slow. 200. Okay, it's still really slow. So 500. Okay, this is not going to help. Oops, it's going 50. So if I make this 500. Okay, this is a lot better, but maybe 1000 would be fine. Alright, so this seems about right. But now we need to change our actual state itself. So again, we'll use this select node right there. So if we are in the center, we have to set our side. So we'll grab a reference to the game state and we'll set side depending on where we are. So if we were at the center and we moved left, we'll set our side to left. So center, we'll set it to left. If we were at the left, it's going to be left itself. If we are at the right, we'll make this center. Copy over the logic. Okay, so for this, so everything will remain the same except when we are on the left and we go right, it's going to be center. If we are on the right, it's going to remain right. If we are at the center, it's going to go right. Okay, so now we can go ahead and try this out. So something happened with our logic right there. Okay, so we had to get the actor's location instead. We made it 0, so he just sunk under the ground. So go ahead, right, left, right, left, right. Okay, so it is a bit glitchy. It is a bit glitchy at times. So let's try enabling teleport. Sometimes that should fix the issue. Okay, when I'm at the right, he's moving to the center for some reason. So when I'm at the right and I click right again, so the logic is when I'm at the right and I click right again, I should still remain at the right. When I'm at the left, I move to the center. So let's try that. So I go to the right, click right again, I go to the center for some reason. So when I'm on the right, the target shouldn't actually be this, it should be the right location itself. When I'm on the left, this shouldn't be 0, this should be the left location itself. Because you're doing the interp on tick, so that's why it's happening. Left, right, and center. Alright, so now our logic is working totally fine. And we can stop printing hello, it's just annoying at this point. Okay, then I think we exceeded 1 hour. Okay, we're pretty close. But we are left with our last few steps. Now we have to make the obstacle move, which is pretty simple. Now we can spawn it dynamically instead, rather than spawning it, or rather just using this. I think we are spawning it. Yep, we are. So I can press F8, head into my perspective view. And now for the magic, head to the obstacle blueprint itself, course obstacle base. We can try this on tick. So on tick, we want to set the actor's location. So we want to change the location of this actor. We'll get the current location. So get location of this actor. So get actor location. And when we move forward, we are increasing the Y basically. So when we move forward, we are increasing the Y. So the logic was wrong. Okay, when we move forward, we are going more towards the negative Y direction. So what we can do is we can go ahead and move it backwards. So we want to increase the Y. So the X is going to remain constant. The X will be as is. Delete that. Split the struct pin. Z is going to remain constant. But Y is going to be Y plus, let's just say 1 times delta seconds. Let's try delta seconds itself first. This should remain constant for all actors because this is tied to frame rate. So I think it's moving, but it's moving very, very slowly. Yep, it is moving as you can see, but it's moving very, very slowly. So we can just go ahead and multiply this. So multiply this by some value. Let's just say we multiply this by 100. So not sure if, yep, there we have it. So as you can notice, it's not actually the character that's moving, it's the whole obstacle course which is moving. And what's weird is our character is actually following it even though we haven't actually attached him over there. Okay, so we can fix the X location of the character as well, because he seems to be just sliding along. So there is actually a setting somewhere here. So it shouldn't slide along the surface. So something over there, character movement maybe. And there is something over here. Okay, ground friction. Let's try 0 on that. Okay, we are just still moving back. So if I hit F8, actually the whole thing is moving back. So instead of that, we'll just set the location, the X location every time to be constant, or rather the Y location. I'm not sure what it was, so we'll copy it. So Y is negative 270. So negative 270. I don't want that to change. And as you can see, our logic is working. And it seems like we are moving forward. The speed is something which we can worry about a bit later. So maybe make this 300. And as you can see, it feels like we're actually moving, but what's actually happening is the whole course is just moving. The character is actually standing still. So now our man is going forward. We can finally go ahead and set up the obstacles itself, I guess. And add in a jump state, obviously, because right now he doesn't jump. So we can adjust the speed, maybe 350. A little more quick would have been nice. Go ahead. Okay, with that, something we'll worry about later. Now, for our next step, so I don't think we really require teleport. So our X, Y, and Z is all set. So for this, we'll be using the jump as well. So we'll go ahead and create a binding for our space bar, and we'll call this one jump. And when I release this, we are going to stop jumping. Okay. So now we should in theory just go up. We can adjust the settings of the jump under our character movement component. And we can also have animations. So under our animation blueprint, we can set it up. So content, blueprints, game, character, Anim BP. We can ignore these and we can add a state, and this is going to be jump, jump start, and jump loop. Jump loop. Alright, so jump start, jump loop, and we'll see what animations we have. And from our jump loop, we want to go back to our run animation basically. So jump start is going to be our third person jump. And for the transition, we'll check if we are jumping. So if we have our character reference here. So is there any variable? Not sure. We can try this. Okay, nothing's really happening. Okay, we are getting a runtime error saying we don't have the character ref. So we'll only access this in the anim graph. So go ahead, if this is valid, we'll go ahead and okay, we can check if this is not valid first of all. So we only get it once, and occasionally it's going not valid. So we can promote this to variable and call this one jumping. And in our transition, can set it up. Okay, so the variable isn't doing anything. So we can head back to the character and create a variable for it in the first place. So jumping. Now we can go ahead and set this to true. We can go ahead and set this to false as soon as we release it. Get jumping. Okay, this logic should work. This is jump start to jump loop. So when our time remaining for our jump is less than, let's say, 0.05 seconds, we'll enter this transition. And jump loop to third person run when this jumping is false, basically. So not Boolean, I guess it's called. So we'll just invert the value. Now if I go ahead and press space, okay, the animation is weird. So we can again do and maybe, and if the jump loop has at least played once. So jump loop. So we can get access to the jump loop here. So time remaining for the jump loop is less than 0.05. We can try this logic. Okay, we just went into a completely random state there. Again, probably some logical error. Okay, so in our jump loop we haven't fed the animation. Okay, so our jumping logic is working. So we can change this to maybe something a little more smaller, 0.02. So this is going to feel a lot smoother. Okay, so we are jumping. Now we can start adding the actual obstacles. Under the course, we can head into obstacle base, and over here we don't want anything. This is not something we'll actually be spawning, obviously. Obviously what we'll spawn is going to be these. So under obstacle 1 we can have stuff. I'm not even sure at this point if we are able to see the sides. We are barely able to see it. And we also need to destroy it once we actually reach a certain point. And we also need to keep spawning it, basically. So wherever our player start is. So let's go ahead and add a trigger volume. So trigger box. So the X is going to be 20. The Y is going to be whatever this is, and Z is going to be 0, let's say. And we'll just increase the extent of the box, maybe 500, 500 and 500. Okay, and we'll set the hidden in game to false. So hidden in game is false. So F8. So this can go way ahead. So a little more. So we can select this trigger box and we can do ×2. By the way, that's a pretty handy thing which you can do in Blueprint. So just a little bit more. So more. Okay, I want to simulate now. So go ahead and simulate. Okay, so as soon as we end overlap on this, we want to spawn a new one. So go ahead, on actor end overlap. On actor end overlap trigger box, we'll try to print first. Okay, so as soon as we go out of this, first of all, for the last index, we'll go ahead and promote this to a variable. So we'll call this one last spawned obstacle. So we'll always have a reference to that. Go ahead, copy this over. So spawn actor, we'll make use of this. Remember, we had our arrow component. So the arrow which is there opposite to the origin is what we need. Game course obstacle base. So near the origin we have an arrow, and over here as well we have an arrow. We'll make use of this arrow. So the location of this arrow, so this is called arrow 1. So we'll call this one end. So that's a little more descriptive. Under the level blueprint now, so we'll get the end. So get end. So get end, and from end we can get the location. So get world location, and we can probably copy this over just like that, and we can change this to this, and the rest of the logic should actually work just like that. Okay, so now if we actually wait for this, as soon as this goes away, one more is going to be spawned. But there's another thing, we want to destroy it once we actually go after a certain point. We want to actually just destroy it. Like once we are behind the player, we have no reason to still have it, so we can have a trigger box for that once again. So 500, maybe 500 and 500. Go ahead, and over here as well we'll set up begin overlap for this instead. So on actor begin overlap. So begin overlap, on actor begin overlap, destroy actor. Okay, let's try this out. So I'm not sure where this box is. Let's unhide it. So hidden game, set to false. Okay, so in theory we should be destroying it. Okay, we destroyed the box itself. So other actor is what we have to destroy. Whoops, we need to take this a little more further back. So now if we wait for it to reach there, so we are continuously spawning the box over there, and if I actually head back into my view, I cannot see anything happening, and our world is spawning normally. How cool. So over here we can add a couple of things. So obstacle 1, we can add a few shipping containers maybe. Oh, we can make it random. Actually that would be nice if we just make this completely random. So somewhere at the center, I'm not sure where the center is. I think it's negative 1600. This is where the center is going to be. Oops, I moved the end itself. So first duplicate it. and this is going to be negative 1600. This is going to be center obstacle, and we can go ahead and duplicate this, and this is not going to be called center obstacle, this is going to be called left obstacle, and we can call this one right obstacle. So our right obstacle is going to be to the right, obviously, and our left obstacle is going to be to the left, obviously. So this is 250, this is negative 250. Okay, so we have set that up. We should have done this in the base actually. So we'll cut this and we'll paste this in our base. So don't mind that. Now we should have our obstacle both in the base and the others. And obviously the logic is going to be in base itself. So since we are randomly spawning it, it's totally fine. We can use the base itself, I assume. Now in the event graph, on event begin play, we can go ahead and create a static mesh, or rather spawn a static mesh at that location. For that we'll need a few actor classes. So obstacles over here, we can delete these, and if we play, everything should work. However, under this folder we can make a few actors actually. So obstacles, we'll call this path actually, path underscore base, in case we need any derived classes. Now click on blueprint class actor, and this is just going to be obstacle 1. Few will be dodgeable, few will be not. So we'll make dodgeable and non-dodgeable obstacles. Dodgeable, we'll just have 3 for each. We'll create childs. So child, control D, and we'll name this one child 3. So 1, 2, 3. So this one is going to be non-dodgeable. So we'll go ahead and create a child, control D, and this is going to be child 3, obviously. Okay, so finally we can go ahead and add stuff to these obstacles. So obstacle dodgeable child 1, we can, instead of the default scene root, obviously, obstacle dodgeable here as well, we'll simply have a static mesh. So static mesh, so that's done. I will leave the root, it's fine. And we can look for some stuff here. So we have quite a few meshes. So we can have a barrel in one place. So we can have boxes, we can have barrels, we have so many options here. So we're going to select this, let's say. Let's try this. So in path, we want to spawn actor from class. So for the class, we'll make this obstacle dodgeable. So spawn transform is going to be this. So oops. Center obstacle, let's try this first. So center obstacle and get world transform. Go ahead and try this out. Okay, it's just sliding along for some reason. and we want to attach it. Yeah, that's the reason. So attach to component. We want to attach this to our actual plane, or we can just do it for the root component. So now in theory this should work. Okay, so this seems to be working fine. One more thing, we can make this a bit faster actually. Now we can promote this to variable, so speed. So we'll make this one 500. Okay, as soon as we hit something, we should stop and our game should get over. So we'll have event hit here. First we'll print something. Go ahead and test this out. So if the other actor is an obstacle, cast to obstacle, we should have made a base class, to be honest. Go ahead and head into content, blueprint, game, course, obstacles. We'll create one called actor of type obstacle base, and we'll inherit these from the base classes. So class settings, so obstacle base, and these will also change. So we'll inherit this from obstacle base, so obstacle base. Alright, so we can go ahead and cast to obstacle base, and we're going to print, or rather we can just exit the game. Execute console command and we'll type in exit. Let's try this. Okay, our logic is working. Okay, we still hit it. So we need a better jumping logic. That's the problem with our jumping logic. It's not our obstacles. So under this we can go ahead and change stuff in the character movement. So under jump we should have this parameter here. So if we change this to 500 for example, so now we are able to dodge this obstacle successfully. And they're a little bit too far apart, I believe, these obstacles. So what we can do is we can have two actually in each one. So go ahead and select all three of these. So I'm not sure what 75% of 3200, so 0.75 into 3200 is going to be 2400. So at negative 2400 we'll have it, and we'll go ahead and duplicate this. So these, and we'll have these at 800. So we'll have a gap of 1600 between each obstacle. And now if I go ahead and press play, we have to set up more logic actually. So we are spawning the obstacle dodgeable here. Now we'll make some non-dodgeable obstacles as well. So set up the non-dodgeable one. We can have something like a shipping container or something. So the way I do it is going to be if I add in a static mesh once again, and we'll have a shipping container, maybe container. Okay, we have quite a few. That's nice. Let's try with only the non-dodgeable one. Non-dodgeable. The rotation's off. Go ahead and rotate it by 90 degrees. Okay. So this is not exactly on the floor, but we can fix that. Head into the left view. Okay, it is on the floor. Not sure why it's not on the floor over there. Can try just moving it a bit. That about fixed our problem. And we obviously should be able to move aside and dodge it. So we are spawning obstacles, and now we can set up a little bit of logic to make this random a little bit. For dodgeable we can have few more. So for dodgeable we'll leave it as is. Child 1, let it be as is. Child 2 we can make something else. So this static mesh can be, we can look over what we have here. We can have this roadblock thing and change the logic obviously. So dodgeable, I think it was child 1, so child 1. Child 2 rather, child 2. Open it up. I mean, it is a bit down, but you get the point. So change that 10, 20. We'll just move all of those by 20 units. And for the third one as well, we'll just add one. Now obviously you can go ahead and make more of these. I feel like if we have some sort of a traffic cone or something like that, so I'm just looking for what I can have. So okay, these seem like the perfect choice. Let's try that. Again, forgot to change it. So under my path, so course path base, we can go ahead and change this to child 3 to test it. Again, it's a bit low, but that's not an issue. Okay, I forgot to get the window in focus once again. That's my fault. And we have to move it down, I believe. So move it down by 20 units. Okay. So we have our dodgeable obstacles. Let's set up our non-dodgeable obstacles as well. So in our child 1, we can again look for what else we have. Maybe if we have a truck or something. Nope. We can look for what we have. So construction volume 1 meshes. So can have a fence. Yeah, that's not a bad idea. So this is child 1. So let child 1 be the same. Let's actually open up child 2 and let's actually open up child 3. So these are the ones which we'll try to change. Oh, here meshes, we'll select the fence for one. The rotation can be 0. Change this. Non-dodgeable child 3. So it's a little too big. So we can scale this down, maybe 0.8. Okay, so I don't think you can dodge this one. Okay, we can dodge it when we move aside. So we'll just have one last one. So for this one, so obstacle child 2, we'll change it right now. So child 2, these are the various obstacles basically. Non-dodgeable child 2, select that, and this is child 2, I assume. Yep. So we can look for something else which we may have. Okay, this looks like something interesting. Oh, light generator, whatever this is. Let's try that. I don't think this should be something which you should be able to dodge. Okay. So that works. Now we can set up some randomizing logic so that we spawn everything in random. So this logic is the same. We need to select the class basically. First we can select a random integer. So random integer. So this is going to be the number of random integer in range actually. So this is going to be the number of dodgeable obstacles. So we need at least one dodgeable obstacle, otherwise the game is going to get unplayable. So we can either have one or we can have all the way up to 3. And what we can do is, depending on the number, now this is going to be number of dodgeable obstacles what we have. So promote this to a variable. So number of dodgeable obstacles. Okay, so now that we have this, if we have only one, what we can do is we can select one. So number of dodgeable obstacles. So we can switch on int and we can select something. So we can start at 1. So start pin at 1. If we have only one obstacle, our logic is going to be really simple. So we'll just select a random one over there. We need to do this 2 times, by the way, or multiple times probably, I'm not sure. So we'll have more obstacles, to be honest. These are not enough. So we'll space them a little more closer. Copy these. Right obstacle, left obstacle, center obstacle. Control D to duplicate, and left obstacle 2. Where's center obstacle 2? Okay, we didn't duplicate everything. So center, left and right. So center, left and right. Control D to duplicate. Okay, we aren't duplicating anything, we'll just duplicate these. So, okay, left, center and right. Can move this somewhere in the center, right at the center. And we can space these two equally apart, which I believe they already are. Are they equally spaced? Yep, but we need to space them out a bit more. We have 800 for the spacing here. So we can select our obstacle 1. We can try giving, negative 600 maybe. So if I do negative 400, so that will be way too much space. 500, maybe we can try 600. So have 3200, let's divide it. Let's take 33% of that. So calculator. So it's somewhere around 1066. So we'll have 600. It's fine if they're not equidistant. You can obviously do the math yourself. So obstacle is what we need. So 1, whoops, 2 and 3. So 3200 minus 600 is going to be 2600. Okay, now let's see if this works. Yeah, obviously we are not spawning it, that's different. But now, in theory, our logic should work. So we can actually loop through. So we can select the number of dodgeable obstacles for each level. So we'll have an array of this. So we'll create an array. So change the type, it's fine. So we can do a for each loop. And for each index, we can try and get a random integer. So we can set array element. So this is the index. We can do a simple for loop. So for loop. So from 0 to 2. So size to fit, we'll do that. And we'd actually want to reserve 3 locations. So 1, 2, 3. So we don't need size to fit. So in this index, we are going to set this item. So for all our 3 levels, we know the number of obstacles which will be dodgeable. Once we have that number, we can go ahead and spawn them. So we can have this in an array and randomize them actually. Anyways, don't worry too much about the logic. It's just my logic which I'm making up. We can select this. So we can store these in an array. So create an array. So promote to variable. Or we can actually just have an array. So what are we using this for? We are just using this for the location. So we can get the transform of this. We can only have the transforms in the array. That would work, I guess. So first we'll have the transforms. Go ahead and create an array for transforms. Transforms 1, transforms 2, transforms 3. We'll need 3 arrays. So we'll the location is enough for us. So array of vectors, transforms 2, transforms 3. I know I shouldn't be calling them transforms, but we'll take a look at the right obstacle, the first level ones basically. So we have this selected. So right obstacle 1 will go according to naming order. Transforms 1. We'll compile this blueprint. So we have 3 elements. We can access it right here. So the first one is going to be this. I'm not sure if we can paste this. Yep, we can. We have right obstacle. Copy this. Okay, we took that. So left obstacle. Copy this and okay. The right and the left have, okay, they don't. So paste one has negative 250 and the center one will probably have 0. So we'll paste it. We'll have 0 over here. Okay, and now that we have this, let's grab our obstacle 2s or obstacle 1s. So this is negative 600. 1, 2, 3, negative 600. This will be constant. So one is going to be 250, another one is going to be negative 250. Similarly, we can grab our 2. So negative 1600, this is basically our midpoint. Negative 1600, 250, negative 250, and this is about it. Now, once this is done, we'll collapse this to a function. So determine number of dodgeable obstacles. Okay, we have the number of dodgeable obstacles now. Now what we can do is we can loop through this. So for each loop, I really wish we could have a 2-dimensional array for this. That would have helped us a lot. Now what we can do is we can go ahead and randomize this. Can we not randomize this? Okay, we cannot. So we have a plugin which will help us. So low entry. We can restart. Save everything. Alright, so back here, I think now we should have, okay, we are coming close to 2 hours. I think this will be done in 2 hours, not 1. Blueprints, game, course, path base, and we should have a randomize. Oops, nope, we don't. So I think we might need a few functions. So how do we go about randomizing this? We can look at the Epic Games launcher if we have any plugins. So array helpers, I guess I had one. So we'll go ahead and install this to the engine. We can simultaneously use it. Once we have this, so once we actually randomize this, depending on this, we can go ahead and set this. So switch on int and we'll use select for this. So just close the editor just to let that happen. And now if we go ahead and launch our endless runner, okay, go to edit, plugins, So edit plugins and array helper. Go ahead and restart. So this is the sort of stuff I just hope it doesn't take too long. Right, hopefully we have some sort of a randomize function. So randomize. Okay, we still do not have a randomize option. So let's just look for it. So randomize array unreal. I don't know. Is it just called something else? So okay, never mind. It's called shuffle. So first of all, we'll shuffle the arrays. We'll shuffle all the three. We'll do that before we actually set this. We'll go ahead, shuffle this. Go ahead and shuffle this once again. We'll put that in the previous function itself. So we can go ahead and shuffle. Generally, I don't recommend you guys do array operations in Blueprint, but anyways, once this loop is completed, we can do that. And this will go to the return node. Just for you to understand the flow of logic here. And now, depending on this, we can go ahead and spawn them. So the array element is going to be the number of obstacles. So this switch is going to start from 1. So start index is 1. You will either have 1, 2 or 3. So if you have 1 or 2, we can use select probably. Copy this over. So everything else is 0, so we can just leave it as is. So we can go ahead and over here, if this is 1, if we have one dodgeable obstacle, we can go ahead and spawn just one of them as dodgeable. So dodgeable. So 1 is going to be dodgeable, and the spawn transform will just use the first index. So we'll select. So depending on which index it is. So transform 1, transform 2, transform 3. So option 1, option 2 and option 3. So we'll select any one of these arrays, and if we have to spawn only one dodgeable, so we can get a copy of the first one. We'll split the struct pin here and we'll just get this location. Now we need to just repeat this logic. So Control D, and we want to do two non-dodgeable ones. So dodgeable, and index 1 and 2 are going to be non-dodgeable. So non-dodgeable. We have to spawn a child class of this. So can use the select once again. So random integer, and max is going to be 2. So it's going to be max is 2. So 1 and 2. So it's random number between 0 and max minus 1. Let's just use random integer in range. It's a little bit confusing. So minimum is 0, maximum is 2. Okay. And this is going to be dodgeable. So dodgeable. Obstacle dodgeable child 1, child 2 and child 3. This is what we have. Done. And for this one, this is non-dodgeable. So we'll copy the logic, but instead of dodgeable, we'll have non-dodgeable. So child 1, child 1, child 2, and child 3. Okay. And we need this once again. So copy over this entire logic. Alright, so this is going to be the same. This is going to be for index 2. Now, if we have 2, we can go ahead and copy this over. So Control C and Control V. And we can just move this aside. So for index 0, it's going to remain the same. Whoops, Control V. Oops, copy this. Control C and Control V. Index is still going to remain the same. Once this is done, we need the attach as well. We didn't copy over the attach. Okay, so we have to duplicate this whole thing. So index is this, and index is going to remain the same everywhere. So now we need 2 dodgeable obstacles. So for this one as well, we have dodgeable, and this is going to be index 1 obviously. And for index 2, we can go ahead and have this. Alright, so copy this, and again we can pass the index. So array index, go ahead and pass that in. And when we have all 3 dodgeable obstacles, we'll just go ahead and copy this much. Control C and Control V. So in case of 3, this is what we'll do. So index is still going to remain the array index. Control D and Control D. Copy this over, move the execution pins, and the index will obviously just remain the same. So the last one is going to remain the same, and this is going to be 2, this is going to be 1, and this is going to be 0. So make sure you have 0, 1, and 2. Okay, so now our logic should work, and if I were to go ahead and press play, okay, everything works. Okay, alright, so we stepped on to something. We need to make sure this doesn't happen in our first run. So okay, we have to just ensure that the obstacles aren't spawned in the first one, basically. So we'll create a boolean first box. So if this is not the first box, we'll go ahead and do this. So inside the level blueprint, under this, if we go ahead and refresh nodes, we have to pass this in. So expose on spawn. Alright, so now if I refresh, I should get this. So only if this is index 0, so double equal to 0, then this is the first box, otherwise it's not. Okay, so now our logic is working. Let's go ahead and play the game now. Alright, so as you guys can see, our game is working as expected. We don't have a score yet, we'll just set it up quickly. So as you can see, our logic is working. So we can set up a scoring system real quick and dirty here. Content, we'll do the start thing also. It's really simple. So go ahead and open level. We call this one game map, I believe. So maps, game map, go ahead and paste that in. We can start from the main menu. Go ahead and play, start, and we started the game. So as you can see, everything is working as expected. You could have some stuff at the side. And we'll have a scoring system. We can have a time-based scoring system. So the score is going to go up at a constant rate. Content, we'll create a widget for it. So use a widget, and we'll call this one HUD. And we'll just simply have a text. So we'll wrap this with a canvas panel, and this is going to be our score. Once we will set the game mode and stuff. So game map. Over here we'll have BP. We don't have a player controller. We'll create that. Game. Go ahead, head into Blueprint class, player controller, BP underscore player controller. So you should have BP player controller. So on begin play, we can go ahead and create the widget. So create widget. It's going to be HUD, and we can go ahead and add to viewport. Right, so let's look at our time. We don't have much. I think it'll take probably just a little over 2 hours, but it'll be done. So once we create this, we can grab a reference. So promote this to a variable, and we'll call this one HUD. Now I don't recommend you guys use bindings, but I think in this case, just to make this real quick, I'll use bindings. So we can have game state. On construct, we can get reference to the game state. So get game state, cast to BP game state. And what we can do is we can grab a reference to it. And we can create a score variable. Content, blueprint. We have blueprint. Main menu, I guess, no, game. So game state, and we can have a score. So we'll make this an int 64 so that we can have larger scores. So int is a 64, and we can have a timer. So set timer by function name, and it's going to be something which happens every 0.5 seconds, let's say, and we are going to increment the score. So promote to variable, score timer, and we can have a custom event, increment score, or increase, I'll call it, doesn't matter, we'll not worry about that. We are going to get the score, and we'll set it to score +2 maybe. Plus set score. So we'll go ahead and do that. Copy this, put it in the function name, make this looping, and we can use a binding here. So we can bind this. We can get the game state. We can make this a validated get. This is a little more expensive on your computer, so don't do this. So we can get the score, and we can convert this to text. You can use a format text node and stuff. I'm not really going over that, so we'll just do that actually. So format text. Alright, and we don't need to convert this. If we press play, as you can see, our score is increasing at a constant rate, and you can see it on the top left hand side. For those of you on mobile phones and who are not able to see it, I'll just make this text a little bigger. So 40, make this one regular, we don't need bold. And this should be good. So as you can see, everything is working fine. And you can go ahead and set up any logic if you want to, like, you know, save it or whatever. But for now, I'm happy with this. So that's it for this video, guys. Thanks for watching. We do have a complete game, and instead of exit, you can just show the score on a widget or something. We'll do that. Let's not leave it halfway. The last part before we just complete it. So we'll create a widget and we'll call this one end screen. Okay, we'll add a border, wrap this with a canvas panel. So we can go ahead and wrap with canvas panel, and this border should take up the whole thing. So offsets are going to be 0 and the brush color is going to be something black maybe. And we can just go ahead and add some text. So we need to align it right at the center. So vertical box. We can use an overlay rather. Overlay is going to be helpful here. So overlay. So border is going to be filled. The overlay is going to be filled as well. So 0, 0. Alright, and over here we can have text. And this is the advantage of using a canvas panel. So 40. Can make this regular maybe. Can go ahead and put score, and we can go ahead and give the value. So let's go ahead and set that. So event construct get game state, cast to our BP game state, and we can get access to the score variable, get score, and we can set the text of this. So set the text, set text, and this is going to be about it. We'll format it. So format text. So this is the score. So let's go ahead and center that, make it 0.5. 0.5 and make everything else 0 here. Oops, the size shouldn't have been 0. Make this one center aligned, and make sure for any vertical alignment which we have. Okay, no, we don't, so I'll just reduce the size of this maybe to 100. Okay, this should be good. Now if I go ahead and press play, nothing will happen because we haven't spawned the end screen. Where we have our event hit in our character, so we can cast to obstacle, and instead of that we can go ahead and create a widget. Create a widget, end screen, and we can add it to the viewport. Alright. Let's go ahead and do that. So I'm testing the end screen, so I'll just die immediately. Okay, so our score is 300 apparently, which is nice. Okay, not sure why we didn't exit immediately there. We need a do once. I understood the problem. So do once. Because once we die, the game's over. Don't want to redo that. So okay, we need to do once from here actually. No, we just went over the obstacle, which was kind of stupid. So go ahead and try this out. And our score is 280. So that's it for this video, guys. I hope you guys really enjoyed this entire course. I know it's been over 11 hours at this point, but hopefully you've learned something new, and I hope you enjoyed the last part where we actually made an entire game and we didn't use any C++ to be honest. So that's about it. Hope you guys enjoyed and see you guys later. Goodbye.